So good morning, everyone. My name is Ahmed. I'm part of the organizing team here at Zak. I'll just quickly introduce the Zak World of Façades conference series, and then we'll get straight into the presentations. We've been organizing this conference series since 2012. This is edition number 210, a second one in Los Angeles. We've been all across the globe. We do events in 50-odd countries, right from New Zealand up until Canada. And the way facades are designed, engineered, installed in all these countries are completely different. So every event is curated to that respective region, local market. I think today's program is also testament to that. Most of the projects which are being discussed here are from this region, California, Los Angeles, and the surroundings. So practical case studies. And of course, we like to go to new places. Albania is a new country we are going. Cyprus is somewhere new, and all these are like unheard of places. And I had never heard of Albania until a year ago, but the kind of projects Albania is having, it has 170 high-rise buildings over 150 meters under construction. So it's booming. And, you know, so these are the hidden gems. Uzbekistan is another place, jewel in Central Asia. You know, people talk about the Dubais, the Londons, the Los Angeles, but these are places where actually there's a massive boom happening. So we go to these kind of places and we organize these events. And again, these events are courtesy our event partners. All our associate partners have a tabletop display outside, so please do network with them. They're all going to be present until the end of the day. I'll just take a moment to mention all of them. Most of you know what each brand does. I'm not going to go into detail, but you know, if you want to meet them, they are all outside. AGC Interpaint, Alpolic, Arcon Glass, ATI USA, Boston Valley Terracotta, Building Blocks, Centria by Nuco, Cosentino, Dow, EJOT, Frameless Hardware Company, Forster, GKD Metal Fabrics, Glassworks, Hydro Extrusions, Janssen, Convenor, Keller Minimal Windows, Northwood, Momentive, Morin Viking Span, North Glass, North Tech Glass, Thermafiber, Porcelanosa Facade, PPG, Pioplus Freeform, Q Railing, Renner's Aluminium, SFS, Sherwin-Williams, Solar Lab, Styline, Viracon, Webforge Locker, YKK AP, and of course our agenda partners. So all your tables and chairs will have a booklet. That's our agenda. The agenda is courtesy dissimilar. You have their ad there. You can find their rep in the audience. Our other agenda partner is Pattison ID. Our lanyard partner is Island Facades. A Wi-Fi partner is Certified Enameling. So these are our partners for the event. And our next event is actually next week in Calgary. So it's the first time we're going to Calgary. We've obviously done events in Vancouver, Montreal, and Toronto. Calgary is our first time, which we are headed to next week. Another new location is Phoenix. Phoenix has never had a facade event, so we're experimenting with Phoenix next one. And of course, Vancouver is also next one. So these are our upcoming 3 editions in North America. And these events, again, as I mentioned, are courtesy our event partners. All of them who are an associate partner have an exhibit booth outside. And we have a full day's session, 4 sessions. We have networking breaks. We have a lunch break. We have tea, coffee, snacks being served in the breaks. And of course, this event is our second time in Los Angeles, as I mentioned earlier. And we've recorded today's event. So anyone who would like to view any presentation they missed, you can view it on the YouTube link, which will reach you a week to 10 days after we complete this edition. My role ends here, but I'd like to invite today's event host and convener, Stan Su. Is one of the leading voices in the facade space here in the United States. He's now heading the facade division at HKS Architects. So he's going to be our event host. Can I have you on stage, Stan? Stan's been a presenter at our events across the globe, and he's kindly volunteered to host today's event. It's just beyond timekeeping and keeping a check on our speakers. So I hope you do a great job. So I hope you all enjoy today's events, and over to you, Stan.
Thank you, Ahmed. Yes, for those that haven't met, I'm looking forward to discussing throughout the day and chatting with you all during the breaks. So once again, I am the Facades Practice Design Director at HKS. And HKS, we are a global architectural design firm, and with divisions in healthcare, hospitality, as well as sports. And we have a division that many of you are familiar with called LINE, which is the Laboratory for Intensive Exploration. And I think that really kind of is a linchpin in sort of thinking with the firm, in that design research and thoughtful design can really improve the environment and, make this world a much more better place to live in. And I think that's something that all of us share here. One of our projects here shown is the Commander Stadium. And a lot of the work that we do is sort of in support of the rest of the office, and looking at design research as far as materials research and innovation. And so really want to thank Zak for putting together this conference. I've been involved with this since 2019, and I know that this conference has gone much further than that. And so many thanks to all the people that have been volunteering their time for the conference itself. And just want to make that comment that, really appreciate that. During the coffee breaks and the lunches, please check out all the different vendors and have a chat. I'll be out there as well. We have a lot of really good, knowledgeable people out there that can really help you with your projects. And so without further ado, I'd like to introduce the first speakers. And that's Zhang Gralewski and Todd Thongeiam from Johnson Fain Architects. And their presentation is titled Century City Center, LA's premier environmentally sustainable high-rise office building. Nice.
Hello, welcome everyone. I'm John Gralewski. This is Todd. He'll be joining me in a second. So we are going to talk about the Century City Center in Century City. It's there we go. So that's me. That's Todd. And well, we work at Johnson Fain. They're a 30 office firm in Chinatown, so we're just down the street. We've done we've been in LA for a very long time, and we've produced a whole lot of high-rise towers across the globe. Wrong direction. Most specifically, in Century City, we've done 3 projects that you can see here. We got the Fox Plaza, which I'm sure everybody here recognizes from Die Hard. And we've done the 1999 Avenue of the Stars in 1990, and the Constellation. Well, you can see all of that. And in this empty spot here is where Century City Center is being erected right now. These are the towers that we just talked about. Our latest project was actually in Figueroa and 8th, which is downtown. That just opened. And this is what is going up now. If you've been down through Century City, you'll have seen this going up over the past year or so. So it's 37 stories, 101.6 million square feet of total space, 700,000 square feet of office tower. There is 4 grades of below grade parking. There's amenities on the site. We're really quite blessed to be able to be working on such a project, given the environment that we're in with commercial real estate as it is. It is let's call it 100% leased out. There's maybe 1 or 2 floors that aren't leased out yet, but we got an anchor tenant who's taken up half of the building, and then there's a couple of firms who are on the top. So the way that we cited this, which was very important being in Century City, you can see obviously it's not super dense, but we are kind of threading the needle here. This is the last empty lot in Century City to build on. So we started by looking, and in case it wasn't obvious, that's the site. And we looked at the different views that were still possible. So you can see the Country Club to the north. Yep, see Country Club to the north. You see Hollywood Sign Griffith Park to the west. Palos Verdes, and you can actually see SoFi Stadium from the south, and off to the west, the Pacific Ocean. So this really situates the project, just like that. So the tower goes there. You can see in all directions, and what we've done is put the tower to the northwest. And the rest of the site there is an elevated park that acts as an amenity to the entire neighborhood. So this is what we refer to as the Channel Garden here on the lower side. The tower going up, amenities to the right. Beyond this bridge that you can see in the background, there's a motor court, and beyond, outside of this image here, is the metro station. So the way that we organize the tower itself is by looking at a 5-foot grid. This is the planning grid that keeps it the most flexible for professional space, professional offices, which is obviously what this is going to be. We added core to it, so you got all of your elevators, stairs, egress, mechanical spaces, all of that. Structural grid gets added to that, and then the facade gets wrapped around this on these 5-foot increments. And then you saw in the images and the renderings that each of the 4 sides has these facets cut out of them, and the idea here is that we can add some variation to the interior space. These will clearly be the C-suites in these corners, so it gives a little bit of unique perspective on each of the floors where those chunks come out. And this is the line drawing for the entire tower. Going inside, we have a 3-story main lobby, and going upstairs, there's some amenity spaces for the as an informal mixing space. This is what we call the social lounge, which opens up out to that 2-acre park that I was talking about earlier, with it's got gym facilities and a conference center on site as well. So we are a LEED Platinum building, and you can see all of the different obvious points that we had to meet in order to achieve that. One of the main things about the site is for LEED is the transit system. And what we have is a metro station. The extension of the Purple Line is coming down into Century City. The stop for Century City will be on our site. So we've carved out an area in the southwest corner of the site to allow for different types of transportation to get onto the site, and add for easy access to all the public amenities, which is the 3rd floor, and the tower itself. Part of our strategy for managing the light in this area is to add the horizontals on the south. This isn't showing up, but you can see it. There's horizontals on the south facade and verticals on the east and the west facade. This allows the shading to work most efficiently for the hottest parts of the day. We variegated that even further on the eastern side, where you can see a sort of an egg crate structure that Todd will talk about in a second. And that's where you come in.
Hey, good morning, everybody. So I would like to start with sharing the a really thank you. So I would like to share the fact about that this building will be the first LEED Platinum high-rise in Los Angeles under new core and shell category, and we were very proud of it. Thank you for everybody involved, Arab JMB, Clark Construction, and our Dustin Fain team. So it's not been easy, but we were quite proud of it. So taking from John, this diagram is showing majority of the surfaces on east and west. You can see on the mid blue, we treat them as by having vertical shading, and then on the minority of the surfaces on the south, we have horizontal sunshade on the other hand. So, and then on the north, we kind of have a mix of vertical and just one that's light green over there is more like butt joint kind of glazing to make it as transparent as possible. When you're zooming in the vertical feature, you can see that it is helpful during the either early or later in the day, having vertical sunshade to block the sunlight from east and west. And then on the south, we have this 18-inch projection for the horizontal sunshade. So that's kind of block the low angle of the sun during the daytime. Sorry, high angle of the sun during the daytime. So the way we situated the horizontal fin is you can see the most projected one is 18 inches. Like I mentioned, it's at 8 feet from the floor. So that's a really nice position to be. So it can act as a light shelf, and with the 9'6" ceiling, so that will get plenty of the light coming above it. So the other feature we also added to the south facade is there was one little facade here there. We actually merged two features together, which is verticals and horizontal. So to add some dynamic to this south facade, which you'll be seeing a lot. So from Avenue and the Star and Constellation plates. So we worked with Arab for facade detail, and we come up with the vertical configuration that projected 12 inches. And what that means is will help with the performance of solar heat gain coefficient by roughly about 5%. So this is a good balance of getting the view from the inside and with the performance that we have. So for the horizontal, like I mentioned, is 18-inch projection, but we allow a couple inches of gap between the fin and the glass to allow water to run through. Also minimize the weight of the horizontal projection itself. So that helped a lot. And we just have only the meat of this horizontal to reflect the light into the building. So for the glazing that we use, you can see that the majority of the facade in green surfaces, we use double pane insulated glazing units, which is nothing new with low E coating. But what we really aiming for is to get a balance of performance that we need to meet and visible light, meaning that we can see through quite a lot with the latest low E coating technology. And last but not least, we also have a limit. We limit ourselves into reflectivity of the glass as well. So by studying with Arab on the surrounding and reflectivity relative to the past project that we want, we aim for about 18% at the very first round, and then we target it into 14 and 50%. Best depends on the face of the facade. So as you can see, the dark blue on the west, we try to also minimize the U value, so it will help to reduce the heat conduction from the surrounding during late in the day, which is the peak heat. For the faceted planes, we use the same IGU on the typical facade, but we add a dot fit pattern to differentiate and emphasize the slope planes, and also reducing the glare and so help with the comfort in the building. So you can see that actually two fit patterns that we use. For the dot fit patterns that I mentioned on the right, so that's for faceted plane. You can see that it's helped when the sun hits. It will reduce the frequency of using the lower shade inside the building, and also differentiate it from the surrounding. So for the vertical fit pattern we use is on the lobby, which is this one. It's the 3-story tall lobby on the ground level, which is providing this about 50% opacity fit pattern above 9 feet here. You can see that it helps reducing the glare on the west side, and also it gets some effect on the steel monument as well. As you can see, this you might be able to see some kind of a stripe of the shades going on the verticals, which is very nice. So this is a mock-up that we use the performance mock-up as an aesthetic mock-up as well. So we pick the most complicated corner, which is the southwest. So this is where the triple glazing meet the slope plane and also meet the horizontal route. So we get everything that we need to look at. So this is 2-story tall, a couple bays on the left, a couple bays on the right. So it's a really nice one to look at, and we were quite impressed with how it turns out at the time when we reviewed it. Only a minor tweak. So you can see that the one thing that we also try to treat the grid on the slope plane is to line up with the vertical on the west facade in this case. So getting really close to see the workmanship of New Hudson Facade, which is a current contractor, that did a very nice job of putting things together. So very minor comments there. Everything meeting nicely as we designed. On the right-hand side, you can see that it's the view from the interior, which is showing everything coming together, and you might be able to see a little bit of notice that dot pattern on the left-hand side of the photo, which is very subtle compared to the clear glass on the left, which is exactly what we want to see. So, so this one is showing the main lobby looking north, which we use the verticals on the west as AESS steel laser welded, done by Novum. They did a pretty nice job, and we have that as white. At the end of the lobby, you can see that it's more like the mid-gray, warm gray on the morning instead of white. So that helps to help you feel that this lobby is actually a little bit longer and add some depth to it. So there will be stone on the right-hand side, which is actually came out pretty nice. So on the middle, so that's the progress, and as you all know, there always we call the zipper units to build the curtain wall. So this one particularly, instead of one line of zipper units on the right, we actually have another zipper unit because of the crane. If you see at the lower level, that's the crane support, and that's being taken about a floor. So I think it's the fifth. So we don't have that many of crane in the in United States. John is like the.
Yeah, there's five cranes like this in the world. This is a luffing crane that can take a huge amount of weight, and there's just not many of them. So that's what was required for this, particularly for some of the ridge perimeter beams that were required. So we're looking at the platform that's coming off of level 5 on this plan, and then the kickstands come back to the ground to keep everything out of the public right-of-way. So it was a engineering feat in and of itself just to get the crane on site and operational. And then to the right, on the other side, is where the zipper was located. And then on the bottom right-hand corner is they're starting to install the lobby glazing there, which is already in now. But this kind of shows the coming together of two different worlds, where the unitized curtain wall above was installed, and then it marries up with a window wall system below. So it's a very complicated piece of geometry to manage, because you do have two different systems. The load bearings are quite different, and it's also on a unique geometry. And New Hudson, I think, and Novum were the subs for Novum was the sub for the window wall, and many meetings of coordination to get all of that to work together, and it turned out really great.
So I think this is the last slide, but not least. So you can tell that the projection on the west is quite actually it's quite unique in some angle view, and the photo in the middle of the merging of the two vertical and horizontal features coming in. I think it looks pretty good as we expected. So also want to mention about we also have on the right-hand side, we have anchor tenant CAA, which is occupy about 20 floors of this building, and they have this balcony projected on the east facade. So that's kind of like additional feature that we got from our anchor tenants.
That's a talk for next year.
And then and this one actually you can see the 1999, which is the building that we designed and it got built about over 2 decades ago. Right across the street from our Century City, which will be done in the next few months. Thank you.
Thank you, everyone.
Thank you, John and Todd, for a lovely presentation. You mentioned that it was quite lucky to get this project, your first tower, out in Century City. And I know that market is very strong in the United States for office. Was there any thought to the resiliency or concerns for that, and any little design features that you embedded that might speak to that?
So the Century City project, or this project in particular, has a very long and sordid history of getting to the point where we're at now. It was an office tower, then it was a residential tower, then it was an office tower. So it bounced around to a lot of different versions. And then when we were getting the permits, the world shut down, and there was a whole new conversation that was added to the topic of, we need operable windows, and how is that going to work with what we've designed and permitted and are already starting to build. So I think every question that could be asked about a high-rise tower has been asked about this project, and it's gone through a lot of different variations, a lot of different iterations. So I don't know if that answers your question.
No, absolutely. I visited the site. I've watched it go up, and noticed the very tight site, and probably the layup space was challenged as well. Mm-hmm. But I would just really want to commend y'all for really taking the initiative and pushing the performance of that building in every way. I just think that sort of attention to detail is the type of thing that we need to kind of keep pushing with our high performance facades. And hitting LEED Platinum, was there other, obviously the solar shading and the sort of reducing the cooling loads in our environment is a big thing. Are there other kind of components to the project that?
Sure, there's one of the big elements is a ice storage facility on the P4 level. There's 68 tanks that create ice at night when the electrical rates are lower, and during the day that ice melts, and that's how the cold water is provided to the entire project. So that's one of it's a huge space, and we can talk about that in another conference as well.
Very holistically thought out project, and look forward to seeing it complete soon.
Yeah, thank you.
Thank you so much. Okay, so we have some time here to introduce the next speaker, a good friend of mine, Gijs Libourel. And his presentation is entitled Facade Performance Beyond Operational Carbon.
Thank you, Stan, for the introduction, and welcome everybody. I want to start with a very simple framing or reframing. Facade performance is more than operational carbon. For decades, operational energy and by extension, operational carbon have dominated how we evaluate building enclosures. Let's test that again. Is this good? Yeah. Fantastic. The enclosure defines how a building exchanges heat, light, air, sound, and moisture, among other things. Historically, our profession focused heavily on producing heating and cooling. energy. That has led to improvements in insulation, tighter envelopes, and high-performance glazing. These improvements have delivered meaningful reductions, but the context has shifted. Electrical grids are decarbonizing, and mechanical systems are becoming more efficient and electrified. Consequently, operational carbon is trending downwards across many regions. As the grid cleans up, the carbon value of an extra inch of insulation begins to experience diminishing returns. We are hitting a plateau where operational savings are no longer the most urgent lever at our disposal. We must now look at the total carbon story and the total performance. On my left, directly, the Rice Moody Center for the Arts, clearly completely open, so no energy performance there, but essential for the building. To the right of that, the LeBron James building in Portland, where the soffit is very, very important to the architecture and the story of Nike, but it doesn't perform particularly well for operational carbon. This shift creates a fundamental change in carbon timeline. While operational carbon is emitted over decades, embodied carbon happens today. These emissions are locked in immediately. To understand the urgency, we look at California's climate plan roadmap to 2045, cutting air pollution by 71% and greenhouse gas emissions by 85%. In this environment, standard construction practice is synonymous with unsustainability. But we must also be wary of maladaptation, solutions that focus so narrowly on a single metric, like low carbon materials, that they create new vulnerabilities. For example, if we reduce the wall-to-window ratio to the point that we rely solely on artificial lighting, we've solved for heat, but failed the occupant. Our goal is low carbon resilience, a strategy that increases both adaptation and mitigation. We are moving away from solving for one variable at a time. Every design move must address thermal comfort, carbon footprint, durability, toxicity of materials, and many more. We prioritize impact through a hierarchy, start with demand reduction, move to active system efficiency, and finally, energy substitution. For the facade engineer, demand reduction is our primary playground. We manipulate window-to-wall ratios, shading, solar heat gain, and air tightness to drive down the baseline energy needs before the first mechanical system is specified. This hierarchy forces us to look at the building as a holistic system. Demand reduction isn't just about saving kilowatt hours. It's about downsizing equipment and creating a stable indoor environment that can coast during extreme events. If we fail here, we are simply asking the mechanical systems to work harder to compensate for a poor enclosure. This is where the true resilience of the facade is tested. Not the average hour, but the extreme peak hour. Let's look at the practical applications: glazing, shading, and peak cooling loads. In California, Title 24 provides the projection factor method to evaluate overhangs, but a compliance check for energy isn't enough. Title 24 is an energy compliance tool. It's about the average. But buildings aren't lived in the average. They are lived in the peak. We must distinguish between energy modeling for code and calculations for real-world equipment sizing. While Title 24 is rigid and generally does not allow you to take interior blinds into consideration for energy compliance models, ASHRAE 90.1 provides a different lens. For peak cooling load calculations, ASHRAE does account for them. This is a critical distinction for the facade engineer. When we talk to our MEP colleagues, they aren't looking for the annual average, they're looking for the peak load. The maximum heat the system must reject on the hottest day of the year. If we can accurately model how the facade manages that peak solar gain, we directly influence the size of the chillers, the diameter of the ducts, and the total capacity, total capital cost of the building. By providing that the facade can clip the peak, we allow for right-sized systems rather than over-engineered ones. This synergy between the skin and the mechanical heart of the building is where real performance is found. We applied this theory and knowledge to the new hospital on Parnassus Heights in San Francisco. Here you can see the solar heat gains and the compliance model. Beyond the compliance model, we looked at the functionality of interior shades depending on the material and color, specifically their solar reflectance and openness factor. Blinds become functional engineering components. A high reflectance blind reflects shortwave radiation back through the glass before it converts long wave heat into the room. This allows us to use interior blinds for glare control, visible light transmittance, and solar heat gain management during the most stressful thermal moments, the peak loads. The point here is that peak load cooling is often far more essential than the annual operating energy use associated with the facade. By using the ASHRAE framework, we can provide higher visual light transmittance glass that satisfies architectural desire for transparency while using the blinds to manage the peak load demands. This prevents us from being forced into over-specifying dark reflective coatings that make a building feel like a tomb on a cloudy day. We are engineering for the Goldilocks zone. Enough light for wellness and healing, but not so much heat that we blow out the HVAC budget. We need to treat both external and internal shades not as an afterthought or tenant fit-out item, but as a critical part of the building thermal performance strategy. When the shade material is specified with high solar reflectance, it acts as a secondary barrier that significantly lowers the effect of solar heat gain. This integrated approach ensures that we aren't designed for 2% extreme conditions at the expense of the other 98%. I'm now moving towards embodied carbon, which is roughly speaking between 7 and 10% of a new building, where 70% of it is primary structure. So we made a study where we compared mega panels with different materials. An aluminum curtain wall might have a footprint of about 40 pounds CO2 equivalent, while a precast panel sits at about 30 and a steel stub wall at 20. This is all without a rain screen. If you include that, the rain screen often doubles the embodied carbon. We need to look at the system holistically. The bracket, the sealant, the membrane, all of it counts toward the day one carbon lock-in. We also need to consider the durability of these assemblies. A low carbon wall that fails in 15 years and requires replacement is a carbon disaster. High performance means longevity. We are looking for the sweet spot where material efficiency meets structural robustness. As facade engineers, we have to look at the technical data sheets for every component and ask, is there a simpler way to achieve this detail? Often the carbon-heavy solution is just a result of habit, not necessity. Let's now look at an example that challenge our assumptions about R value. This is a hospital building in Houston with 3-foot thick concrete shear walls. And this is a perfect example of why standard logic doesn't always apply to high intensity buildings. The choice is between a bare exposed concrete wall and an insulated, same shear wall, but with insulation and a rain screen system. On paper, the insulated walls shows slightly less annual energy use because it resists conduction better. But hospitals are cooling dominated 24/7 due to the massive internal gains, medical equipment, imaging suites, and high air exchange rates. Even in the Houston winter, these buildings are in cooling mode. In this scenario, the bare wall is actually better during the winter. You can see that you can see that over here, the orange line, that is the bare wall, it becomes better negative than the green wall, that's the insulated wall. And crucially, the 3-foot thick wall provides so much thermal mass that it damps most of the effect on peak loads. The time lag of 3 feet of concrete is so significant that the peak exterior heat pulse hasn't even reached the interior by the time the sun goes down and the interior temperature drops. When we ran the numbers, both annual energy and peak cooling loads for these core walls were noise. Please note, this is not on the south, this is on the west facade. It's only part of the facade. This is not a general statement. It's for this specific wall, in this specific location, in this specific climate. So if the energy use and the peak loads of this wall are noise, what is important? The answer is embodied carbon, capital cost, and constructability. As you can see, the carbon payback time is, depending on what aluminum wall you spec, either 73 or 220 years. So important. Clearly not building a rain screen, an insulated rain screen, will affect capital cost, and not having to come back for a second time to build a rain screen will help with site logistics as well. And site logistics leads to the most overlooked performance criteria, and that is constructability. Facade is impossible to install safely or correctly is a failure. As seen in Houston, adding insulation to a massive structural wall increases the complexity budget without a performance dividend. If an assembly requires 50% more crane time or specialized labor that isn't available locally, the green credentials evaporate. We have to stop equating complex with high performance. Often the most robust solutions are the ones that are the most straightforward to build. The role of the facade engineer is to bridge the gap between design intent and real-world performance through what I call information continuity. Making sure that everybody knows what everything is, nomenclature, and being detailed enough in your details. Shout out to Tyler Tucker over there, who actually produced this graphic. The role of the facade engineer is to bridge the gap between design intent and real-world performance through what I call information continuity. Using consistent data structures and shared models allow information to flow from the architect's vision to the fabricator, and then to the shop drawings and the site. By integrating fabrication knowledge early, utilizing design for manufacturing and assembly, we ensure that the carbon and energy targets we set at the beginning are actually achieved. We aren't just drawing details, we're defining the sequence of operations. So a complex soffit like this, you start with the system design, then parametric design, and making sure that the details are parametric and are communicated clearly. As we move towards 2045, we must remember that building's performance is a symphony, not a single note. If the balance of peak loads that size our systems, the embodied carbon that defines our immediate impact, and the constructability that makes it all possible. But there's a final, perhaps most important metric, the enduring value of architecture. Operational energy is the floor, not the ceiling. If we build a high-performance compliance box that is uninspiring or fails to serve the human spirit, it will be torn down long before its carbon debt is repaid. Good design is a form of sustainability in itself. A beautiful, functional building is one that the community will choose to maintain, adapt, and preserve for over the centuries. Our task is to look beyond the annual kilowatt hour and start engineering and designing for the total life cycle, not just of the materials, but of the place. Let's stop building mere enclosures and start building high-performance, low-carbon instruments for living and healing that possess the architectural quality to endure.
Thank you, guys. That was right on time, and I think we'll probably just have to skip the questions for this one, but really appreciate the perspective on the notion of the total assembly, right, contributing to this, and that there's no slam dunk success when we sort of give a nice sort of package to the mechanical team, and we're dealing with peak loads, but really appreciate the notion of everything, the experience and wellness and durability. So thank you so much. Like to invite the next speaker, one person who I've collaborated a lot with over the years, and this is Andrew Pries, Director of Innovation and Technical Sales at Boston Valley Terracotta. And his presentation here is entitled Architectural Terracotta Innovations for Sustainable High-Performance Facades. Please help me welcome Andrew.
Hey everyone, thanks for having me here today. I'm here today to talk about an ancient, timeless material that contributes really well to high-performance and stable designs. But before we talk about that, I'm trying to. Oh, there it goes. Too much. All right, sneak peek. Our industry faces a lot of challenges today. One of the biggest challenges are these challenges present a lot of opportunities for us, though, and these opportunities give us means to look at materials differently and design differently to help solve those challenges. One of those challenges is the increasing heat index across the globe. cities are getting a lot hotter, and our material choices lead directly to the urban heat island effect. As you look across the United States, you can see not only is LA and New York City urban heat island, but pretty much every metropolis across the US is. You can actually look really closely and see basically our entire interstate system is a heat island. So how do we solve that? And when you couple that with the global CO2 emissions, it paints a really bleak picture. 42% of all annual emissions are from the built environment. 65% that's from building operations. So pair those two together, building operations and rising heat index, it paints a really bleak picture. So where does terracotta come into this? Well, terracotta is one of the lowest embodied carbon materials out there, and it's derived from one of the most abundant natural resources out there, which is clay. So a multinational team from Europe looked to take advantage of those properties along with many others to develop a new wall typology during Boston Valley's annual Architectural Ceramics Assemblies event in 2024. Before they developed that wall typology, they looked at existing walls to understand how much embodied carbon is in each assembly. And if you look on the right, you can see terracotta EWS04 as a rain screen. It's actually the lowest embodied carbon system out there, but they knew that they could do even better than that. So the system they came up with is a modular system that consists of two white terracotta that takes advantage of its compressive capacity and foam glass, its insulative capacity, to create a load-bearing system that required no additional support for up to 6 stories and minor post-tensioning above 6 stories. They also wanted to make sure that it could pass all the different code requirements across the different areas. So we had groups from London, Toronto, and Los Angeles part of this team. So they analyzed it and made sure it passed all those. And one of the other analysts that they did was compare it back to that baseline. And they achieved 40% less carbon emissions in this wall system compared to that conventional rain screening system. So that's an immense amount of savings. They did this all while developing a really beautiful terracotta wall that took advantage of its natural qualities. And they developed this really, to me, iconic finish that you can only achieve in terracotta, that you can't achieve in any other materials. So this was a really great proof of concept that they developed in our workshop. But how do we deploy that at scale? How do we make it to the mass market? What other problems can terracotta help solve? Everyone here is a creative thinker, and I challenge you all to think of how can terracotta help solve the next problem you're facing. For those who don't know about terracotta, terracotta is known for its malleability and plasticity before it's fired. Boston Valley employs 4 different forming methods to produce terracotta. Those are hand press, ram press, slip cast, and extrusion. And between those 4 forming methods, we can make pretty much anything possible that gravity doesn't get in the way of. A great example of that is Gensler's Reclad of the Macy's men's store in downtown San Francisco. They utilized all 4 forming methods on this project to tie in a very contemporary facade into the urban historic context. Terracotta also is known for its aesthetics. From an aesthetic standpoint, your possibilities are nearly endless. We have 14 standard through-body colors and the ability to customize that. And when it comes to glazes, the world really is your oyster. Every project we do is custom developed glazes for that specific project. It can be a single color that's in a dry satin or a matte satin or high gloss finish, or we can even layer them and create a lot of different looks that only ceramics are able to achieve. You can even put precious metals on ceramics. So this is a gold luster that KPF chose for the Pacific Gate condominiums. And this gold is actually permanently baked onto the panels and will last there for hundreds of years. There's examples like the carbon carbide in Chicago that has that same lustrous glaze on it. Terracotta is also known for its durability. It's known as a 100+ year material. It does not fade or in UV light, mold and mildew resistant, and also is able to withstand the harshest freeze-thaw conditions with ease. A great example in our backyard is the Eastern Columbia Lofts. This building is almost 100 years old. It opened in 1930, and we were recently part of a restoration campaign on this project. The restoration campaign was not because the terracotta inherently is failing itself, but that the supporting steel was actually rust jacking, causing the terracotta to fail. So you had to fix the rust and replace the terracotta. Terracotta, as I mentioned before, is known for its sustainability. As a manufacturer of terracotta, our terracotta production process is zero waste. We incorporate up to 30% of recycled content into each of our mixes. And following the circular economy, if in 50 years or so, you could border your terracotta facade, which I highly doubt you will, we can actually take those panels down, crush them, reconstitute them, and turn them into new panels that can go back up into your facade. So they say the greenest building is the one that's already built. Cornell University hired LTL architects and Perkins Will to redevelop an existing engineering classroom that was built in the 50s into a high-performance LEED Platinum building that is now a research laboratory. And the facade system played an integral role in achieving that LEED Platinum status. Another project where the terracotta played a role in achieving LEED status is the Harbor UCLA Medical Center, which achieved LEED Gold. This was a design build by Hensel Phelps, co-architects and HMC architects. The design team chose a combination of natural through bodies and glazed panels to really create this striking facade, and they won the 2025 Los Angeles Architectural Award. Sticking with the theme of sustainability is a really unique project designed by Arini Pontarini, Adamson, and BDP. This is located in Toronto. It's actually a 6-building complex, and it's aptly named The Well. The reason why it's called The Well is there is actually a 2 million gallon tank located below the development that is part of the N-Wave system, which is actually, they draw cold water from Lake Ontario to offer cooling systems to the well and other surrounding areas. They actually also just introduced a heating system in there too. So the well and other neighborhoods can use low carbon heating and cooling options from that. This project drew on the historic context of the neighborhood, and it actually features some of the largest terracotta modules that I've seen on a terracotta rain screen project. Typically, these sizes are more on the historic side. The team also chose a very intentional variegated facade of 3 different colors to, again, tie into that historic context and be able to blend the historic and the new really, really seamlessly together. Getting back to 100 Stockton, Gensler looked, again, to that historic context and traditional proportions when they were designing this building. They started off with the basics, actually a traditional brick module that elegantly graduated up to a very large module, about 24 by 30, with a facet across each face. When the sun strikes this, it creates a really striking facade that really helps activate this building. And then as you go to the upper portion of the project, there is an undulating header and the jammer turns return at different angles, again, to create a really active facade that replaced that old brutalist building that I showed before. So as you can see, terracotta can do a lot, and those projects really do a great job of exemplifying what terracotta is capable of, but it's also capable of doing a lot more. So I just want to quickly go through some projects from some of our past ACAW workshops. The first one is Henning Larsen and Thornton Setti teamed up to create a carbon positive facade. So they create a module that actually promotes moss growth to capture the carbon, and that moss grows on the bisque portion of our body, and it was designed in a way so that the moss doesn't actually break down the terracotta. Tuesday Studio, which is a small firm located in Miami, wanted to design a solar shade system that also helped redirect rainwater into planters that would be located on a parking garage. If anyone's been to Miami, you know the rainstorms that happen just inundate their sewer system, so they wanted a way to redirect all that rainwater into planters so it didn't have to go into the sewer system. And then finally, this is Eric Perry Architects. They're a London-based firm. They wanted to design a feature wall, a green wall, that actually promoted lichen growth on the terracottas. So some of the glazing is actually meant to emulate the lichen, and as it grows more and more, the building will actually transform. This is for the fishmongers, hence the shape, if you guys can see the correlation. And it's located in a really dirty part of London. So that's why they wanted this green wall, is to actually help capture carbon and clean up and beautify that area. So as you can see, a facade can be so much more. Terracotta can be so much more. Beyond aesthetics, beyond visual appeal, terracotta can transform functionality. It can reflect sunlight, disperse heat, capture rainwater, and create habitats for bird, bees, and plants. The potential is immense. Our industry just has to embrace it. Let's reimagine a facade as a dynamic element of the built environment. Imagine terracotta facades that do more. What new innovations can we unlock? How can these advancements shape high-performance facades that actively support a sustainable future? The possibilities await. Thank you.
Thank you, Andrew. We have some time for some questions in a few minutes here. And just out of curiosity for the Eastern building that you guys did here, and you mentioned some of the more traditional assemblies that kind of fail more from the attachments.
Yep.
Did you guys incorporate more of a rain screen logic in all those different systems, or did you actually go back to like maybe something more traditional and
so
ties?
That went back to a more traditional method using typical stone anchors, but because now we have stainless steel and galvanized steel, they replaced the typical mild iron, which is what typically was put in the buildings in the 1930s or late 1800s. So it will last a whole lot longer. There are some studies. Actually, WJ was a part of that project, and they've actually developed this modular rain screen cornice that can actually help replace and reduce a lot of the weight of old terracotta cornices. Typically, they're understructured. So it's a really interesting project that they're starting to explore more and look for possibilities to use it on other buildings.
Fantastic. And I think you showed quite a few different ways where you could sort of challenge the notion of terracotta. I remember this old chart of the sort of like the what's evil and what's good materials as far as carbon. And, I think, a lot of materials got the bad rap, but I think what you've shown is that you could really look at the whole assembly and the sort of the entire life cycle. Right?
Yeah, it's absolutely about the whole assembly. I mean, terracotta, it's a wonderful material. It's got super compressive strength. Its tensile properties are really not bad. But you can't build a whole building with that. If you were, we're going back to mass masonry and huge walls, which just are not practical in today's environment. So it's, looking at that whole assembly and how does it actually contribute more to the built environment.
Mm-hmm. Okay, yeah, we got time for a question.
Yeah, Grace in London Park, all in your presentation, you talked about the structural terracotta system that
Yep.
What was that black material?
The black material is foam glass. So it's a recycled glass cullet that they then mix with, I believe it's sulfur, to create a pumice-like material that adds some super insulative properties. So they were able to basically, in a 1 foot cavity, typical kind of cavity wall that we all deal with, achieve super insulative properties with that system.
Would that come out as assembly, or you built that at least?
The idea would be that would come out as basically a modular block. So you'd have the two terracotta pieces with that foam glass in between, and then that would be able to, that's a manageable enough size so 1 or 2 people on a crew could actually assemble that and put it in place.
Thank you so much.
Thanks so much.
I'd like to introduce the next speaker. This is Werner Jager, and he is the managing director at Keller Minimal Windows, and his presentation is entitled Sky High, Limitless Transparency.
Thank you so much. Thank you so much.
How is it going to choose?
Good morning, everybody. It's a pleasure to be here. Of course, you can immediately feel it, the sound. It's the best German English I will present to you in the next coming 25 minutes wasn't it? 10 minutes, of course. She will shut me down after 10 minutes, so that's pretty okay. So it's a lovely pleasure to be with you here today, and it's an honor to present Keller Minimal Windows, a company coming from Luxembourg. I mean, those who don't know where Luxembourg is, it's Germany, Belgium, and France, and in between, it's a lovely island called Luxembourg, and this is where we come from, okay? Let's bring the next 10 minutes a little bit what we are doing, and we are doing it out of a perspective where we are in our major segment, which might not fit 100% to the audience of today because we are in the high-end residential market segment on minimalistic slider and pivot door solutions. But there's something more in for you at the end of the presentation. I hope so, at least. Okay, so let's see a little bit down the road how we go for. I just named it Sky High. The feel-good factor or comfort is everything. And our major contact person when we talk about our products, our solution is hardly the engineer nor the architect. It's the interior designer. The interior designer is very close to the decision maker, and the decision maker comes from the inside equipment, furnituring of the building with a view to the outside. So this is a little bit where we come from. So maybe it's also a little bit different from that perspective when we go for. Let's try to find the right ones. Who are we? We are 50 people in the north part of Luxembourg, German-speaking area of Luxembourg. We belong to a multinational group of 1.5 billion revenues, 2,000 employees. We are 50 engineers and 50 craftsmen. And we are pretty proud craftsmen, okay? We are really doing things with our hands, and we bring it more or less on our side. Innovation and craftsmanship, this is something you hopefully detect during the presentation. If not, then come to our booth at the very end of the room. Also, Matt is here from Craftsman being with me today to present more or less the LA office. We are made in Luxembourg, and we have a legacy of more than 40 years in that segment and activity. When I start to prepare for this presentation, everything is a little bit, what is our major activity? Our major activity is, together with the interior designer, to present to the end client something which is not a product, which is not a solution. It is something which makes him emotionally binding to his house, to his facility. So this is a different story than just having the norms in hand and everything like that. So it goes a little bit beyond that one. So the feel-good factor is composed out of three very important stuff. Subjective, comfort. Every one of you knows this pretty nice ISO 7730 Olifanger stuff. 10% will always disagree. Okay, 10% of the audience will not like my presentation. This is a matter of fact. Okay, we can't do anything against it. Some guys are too old, the others are too young. It's too hot, it's too warm, it's too cold, it's too much fresh air, it's too less fresh air. So 10% will not be satisfied with the conference at the end of the day anyhow, okay? So that's a matter of fact. Nevertheless, the comfort and the positive perception is something you have to convey with the product, with the solutions you're doing. And this is where we are working on. And I'm not using this famous pointer. I still use my finger to punch out the pixel from the wall. Emotions. You have to try to find people emotionally bound into the solution. Otherwise, you will not be successful in that kind of activity. We are facing on the development and also on the consultancy on 8 major parts, 8 major bullet points to really consult our end clients to the thing. I will just start on 2, 3 for today. If you want to have more, we can come back for more than 10 minutes for the next presentation. Okay, daylight and transparency I will start with. Thermal comfort is very important because we work with with large glazed, the jumbo glazed solutions. And glass is perfect if the sun is not radiating at the outside. Otherwise, you might have overheating without having shading devices. Very well explained during the presentations in the morning. Acoustics, extremely important. If you want to stay inside a house, you don't want to feel the traffic at the outside. So acoustic comfort is extremely important to have these large glazed units installed. Visual comfort and design, minimalistic, is going into this kind of answering the question. Haptics, which means what is the material feeling like? Is it plastic? Or is it solid material? And this is more or less the distinct factor when you go for this kind of projects. Easy to use. I have some project ideas on that one. Safety and security, which is, among others, resistance against high wind loads, which might come due to the climate change discussions to all of us. In addition, sustainability and health, very important. Sustainability we define not only from the CO2 footprint at the very beginning, but about the longevity of the product. When a product can be used for 50 years, it's a different story than for 10 years. So this is a little bit the discussion we are really focusing on. When it comes to the daylight, it's the visual connection to the outside. This is the definition, to the nature, to the city, to the sky, to something which is moving at the outside. And what you see down there is a small video about a villa in Austria, showing more or less how easy it is to fix the panels up to 2,200 pounds of weight by a small crane manipulator. Nothing very dedicated or sophisticated, but it's very easy to be fast installing this kind of large-scale panels at all. Research done especially here in California is really helping us also to convince the client that large glazed areas is really good for the well-being, for the health, but also for the recreation of people sitting inside the house, enjoying the views to the outside. Very, very important to understand that this kind of studies are existing, helping us to convince that larger scale areas is helping more or less for the comfort reason. Of course, then you have the heat coming in, you have the bird protection on the other side, you have to take care of if you have this kind of glass, but all of this is a kind of structural discussion with the end client and the interior designer. What is important when you have these jumbo glazed units, sliding panels with minimalistic frames, the nature is that the human eye is trying to eliminate the small frames. So for the human eye, it seems to be one transparent wall. And this is also giving comfort and peace to the people inside. Minimalistic is sorting your brain. Being minimalistic, you concentrate on what is important. This is a little bit also the philosophy in life to some extent. Okay? We have pretty good recipes in the world. The lead, the bream, a lot of others are existing. You see here, for instance, what is important when it comes to the occupied areas, when it comes to the view distance on the different things. So these kind of recipes are perfect for us to consult this kind of projects to a very important step. And what is important according to the lead is multiple views. So if you can have a corner transparently on the one side and on the other side, this helps to really open up the comfort when you sit inside the building. The visual comfort, haptics, and easy to use. I will now make a small shift to a project we have just realized together with the Rochman Group last year in New York called Harlem Meer, northeast of Central Park Cultural Building. This project was pretty important for us because we never did it before. This is a little bit what we are. We are craftsmen and engineers, and we are bored to do the same stuff again and again. So we love to have challenges. This is a 4.2 meter, which is roughly around 14 feet tall, pivoting transparent wall. The end user asked us not to make a pivot door, because a door in your American standard is something very particular when it comes to safety. It's a transparent, openable wall. The wall is opened once a day in the morning, 23 doors, and in the evening it is closed again. And in between, the people come in and out, and there's a pool area during summer, it's an ice rink during winter time, and it's a kind of dressing room, just to change more or less the dresses. What you see more or less on the next slide is what we do. You see our craftsmen kneeling at the floor. This is the bottom track, because it was not only 23 pivot doors in one track. Every track had a 0.5 degree angle to the other one. So at the end, it was a kind of facaded solution. And what we did here, you see here, I also use my finger to pinch out. These are the gearboxes for the pivot doors. And we measured the distance, because if you have the distance proper, the door operates in a perfect manner. So we do this craftsmanship in-house. And also for the very first time, the architect said, I don't want to see any handle. We never did it before, so we developed a non-visible handle which can be locked, and this was the solution also for that solution. For that kind of door, high wind loads, 1.2 kPa, was needed to make it happen. A lot of things has been done. We have even had to change our metric screws to imperial stuff, because the engineers had to simulate according to the European or US standards. So that was a challenge for us as well, to make that kind of engineering together with the Rochman Group and the engineers involved. Safety and security, very important, is not only the safety and security when it comes to burglar resistant, bullet resistant, blast resistance, but it's also about wind load resistance. And this is for all of us, because wind loads are getting more and more. And we are just recently together with Lindner Group, and Mario is in the backhand from the Lindner Group, together with Epsilon in Miami. We installed together a project called Surf House. And for the Surf House, it's a condo building. We also made a panel which is 10 feet by 10 feet, 1,100 pounds, one leaf to be operated. And it was a double slider, a triple slider, and a fixed field. For us, at least, pretty impressive was the 80 PSF of load, which was requested to go into the testing. For us, it's insane when I just look on the kilometers per hour, which is close to 300 kilometers per hour. I don't know, maybe it's 160 miles an hour, something like that, in wind speed, which is massive. So we also did it for the very first time in this, and we passed more or less a test 1.5 years ago, and now it's an installation phase. The challenge here was, to survive the cycling tests after the impact. I mean, you know it by heart. The timber beam is breaking the glass is coming to a kind of towel. The towel is pumped 9,000 cycles up and down, and we have then seen our interlock is rotating, because the frame is bonded to the glass. And if the glass breaks, and if the glass behaves like a towel, then the situation is going into the worst situation. So we developed a special device to avoid this kind of twisting. But major challenge was deflection. I mean, we are working with millimeters, you work with inches. There's a kind of 25 factor in between. And the biggest problem we have here is a minimalistic slider door is unable to bear any structural deformation. Why? The frame is bonded to the glass is rigid. If the frame is sacking, the panels are moving, okay? So the challenge was also here, how to accommodate this half-inch movement. Otherwise, if the half inch is coming, it does not work anymore. You cannot open close. You have air leakages. Everything is a nightmare. I have 11 more seconds, so I will be fast on that one. Give me 5 more seconds on top of. So we developed a header detail for the top, so that the top frame can accept the movement of the ceiling. You see it here with the screws. You can readjust again the height of the top frame profile. And at the bottom, we have developed adjustable screw of the bottom frame, together with the Rochman, with the Lindner guys and Epsilon. So you screw every 10 inch, 2 screws up and down if the deflection is coming. This is more or less to keep it more or less on this tolerance level, what is needed to make it happen. Also developed in parallel for that kind of very interesting project. Last project I want to show you is a project in Israel. We have also just finished this one together with the client called Alumeshet. It is not the tower, it is on top, penthouses, duplex penthouses on top. Corner solution developed here as well. Wind load 2.8 kPa was requested for that kind of solution. Speciality here was that the panels bring double weight to the aluminum frame. And to avoid that the aluminum frame is bent to the outside due to the wind pressure, we had to insert exactly in that area some additional parts. And this we did in our workshop. First, we did the simulation ourselves. Then we put this into the workshop. We produced everything in Luxembourg, so it's out of a crate. You install that kind of slider. So this add-on part is just in the area where you have the two leaves meeting each other, and you have a plate of steel reinforcing the complete activity. Witnessed by the client in our own test lab, and finally, happy customers on the building site. And this is our guy here. And he said it was so nice. There was people who are not believing anything, Muslims, there have been Buddhists, and he was the Christian, and Jewish people, and it was working. So I would like to finish my presentation. Hopefully, we all find this peace in mind in our future. Thank you so much.
Thank you, Werner. That was a wonderful presentation. Yeah. Really, the minimal nature of your product is just belies all the
Just 2 minutes in addition. Sorry for that one.
Thank you. So we have the networking and tea and coffee break coming up. I spared you all the housekeeping at the beginning, but I'll have to go through that now. And so if any of you are looking for credits for continuing education at the end of the day in the expo, there's a sign-up sheet, and we'll need a signature to send that through for you all. As you go out for networking, make sure you circulate and look at all the nice vendor tables that we have, and rub elbows with those that are really hitting the dirt out there. As you come back, tea, coffee, drinks, and snacks are welcome back here, but we ask that you don't bring the lunch in the venue, organizers. And so before I release you, if I could have all the speakers that spoke this morning come to the stage, we have a photo op and a small gift for you. And so we'll see you all back here after the break. Okay, thanks everybody. We're gonna start the second morning session here. And for those who weren't here in the morning, if you want the AIA continuing education credits, just need to sign up in the expo at the end of the conference here. And so to kick off this session, we have Lisa Rammig, director at Eckersley O'Callaghan, and her presentation entitled, Can Circular Be Beautiful?
Thank you, Stan. Let me find the thingy. For anybody who doesn't know me, I'm a material lover. We're facade engineers. And it's Climate Week in LA this week. So I thought, as seemingly everybody else, we should talk about circularity a little bit. Perhaps what I'm going to try to do is show a little bit of a different perspective than the technical perspective we've seen so far, and I'm very happy to talk about opinions and emotions afterwards.
Wonderful presentation, and so nice to see all the different examples and to see the challenges and what people like you in research have been pushing past and getting this into industry, and really impressive stuff. So now I'd like to introduce our next speaker. It's Bob Zhang, Commercial Director for Tianjin North Glass, and his presentation is entitled Advances in Curved Architectural Glass.
Good afternoon, everyone. Thank you for Zak World of Façades having us here today. And also thank you for everyone joining this event. My pleasure to be here too. So today we're going to talk about something about curved architectural glass. We have two topics to talk about. First of all, we're going to share two job references about multi-curved glass. We've been complete and in processing. And next, we will talk about some new generation about the good quality of the curved glass as well. First project, the Cotta Miami flagship store was designed by DSR. We've been complete this project by end of 2014 to early of 2015. A couple very interesting thing here is this is all multi-curved glass, and also the project we have concave and the convex panel on the facade. This is not a huge scale of the project. The entire project's only like 5,000 square feet. And we most likely we made around like 25 to 30 pieces of glass for the project. But the interesting thing is if you look at the glass, at the top and the bottom is all curved surface. And actually in the middle of the facade is meeting in the middle as a flat piece. So if we move into next page, you probably get a better idea from here. So the top is curved, the bottom is curved, but actually the glass was, the radius was getting slightly bigger and bigger until it's being the flat and meeting in the middle. So like I said, the glass is not super complicated on the glass makeup. We have totally 4 layers of glass, and we do have on the surface number 1, we do have the side one freight, which is printed by the Cartier's logo, and on the surface number 4, we do successfully apply triple silver low-E coating, like with hand transparency. This is the most challenging part because you can see we have the glass bent by the both concave and the convex surface. And the size of the glass, we put something wrong. It's supposed to be like 23 feet tall, but the width is really over 10 feet wide. That could be one of the challenge to bending the glass over 10 feet wide. And also the radius of the glass is around like 10-15 feet. Yeah, on this page, you probably get a better idea on the right top corner about how the glass shapes and how the glass been bending. And also you see some corner conditions at the bottom as well. So this is something we call like multi-curved glass, or we call it 3D bent glass. Next project, so a very big project. The entire facade is over 800,000 square feet, designed by Zaha Hadid. The project is for Opel, a company in China, which their headquarters in Shenzhen. This definitely is the biggest project in the worldwide have curved glass right now. You see how the entire building was covered by the glass facade, and we do have multi-curved glass a lot. We do have over 20,000 pieces glass, which have different size and shapes. So as a huge project, I mean, a lot of people get involved on that. People all want to do the big projects. The key point for us, for North Glass, to getting this project is really by a lot of points. First of all, if you look at the dome and also the setting of the project, it's all multi-curved glass. We may call it double curve sometimes, means each piece, the glass on each panels have more than one radius on that panel, you can see there's 1, 2, 3, 4, four towers combined as one building, and all the dome and all the siding is multi-curved glass. So for North Glass to winning this project, one of the important things is we really have to minimize the dizziness of the curved glass, because traditionally, thinking about the previous curved glass, people are saying, like when you walk around the glass, you actually see a lot more distortion than the flat glass. It's really because of the technology of how people manufacture, fabricate the glass. It's create a lot extra roller wave, makes a distortion. And another thing is, like I mentioned earlier, this is more than 20,000 pieces of glass on the project, and each piece of glass, the size is different, the radius was different. So minimize to control the tolerance of the size tolerance of the glass is another challenge. And also, like we also have to work with the glazing contract. We have to give them like we have to control the tolerance, the radius tolerance, the size tolerance as minimum as we can to helping the glazing contractor can successfully put a glass on the building. So far we finished more than 50% of the project, and our in-house standard is really having to control the glass, the tolerance within like 3 millimeter. That's just about over like 1 inch. Sometimes, okay, give me some idea about the shape of the glass. Some of the shape of the glass, and I mean, there is no rectangular glass on entire project, on entire building, and that's something we have to work in-house to improve our efficiency, improve our processing to make it quicker and make it on time. So, yeah, some idea about how the shape of the glass and how the glass being curved. Should be one more video here. Yes. So more idea about the geometry of the building and how the glazing contract being assembled and install the glass on the project. So talk about quality control. So when we talk about quality control, we not only talk about the size, we also talking about the visual quality, means how much distortion we get, and how we can control the glass, the concave and the convex glass. When people look from outside, how we make sure people have same appearance, same color on the facade. That's something we offer to our client. For example, you see here, we often have our client team, the owner, the general contractor, the subcontract, consultant, architect, people coming to our shop. We put the glass outside, we put the glass side by side for the project, and also we set up the benchmark we've been built for the project at the very beginning together to show people how consistently of our quality. So after that, talk about something about curved glass quality. Yeah, rough idea about the size we can make. We can do up to 80 feet, 80 feet as one piece right now. Talk about something about the quality, visual quality control. So for the curved glass, even for the flat glass, we often talk about two topics. First of all, we talk about the distortion. And the second of all, we talk about the anisotropy, which is quench mark, which is coming from the cooling processing when we temper the glass. So on this page, we really want to show something about how we improve the distortion of the curved glass. So on the left-hand side of the picture, this is by the old technology of the bending furnace. You probably didn't see that much distortion right now, but if you follow through the factory line here, you will still see some little bit waves on the transparent image of the factory. But on the right-hand side, you definitely see a new machine, which the line of the factory roof is much more straighter. Yeah, a video here just give a better thought how the distortion being improved, especially right hand side. You see almost nothing changed when you move around even by a small angle. Next page, anistrophic cringe mark. So we took a picture at the same day, same time, and trying to give people idea about how we achieve the cringe mark. The newest machine technology compared to the another two picture on the left-hand side, you see a lot less cringe mark. We would like to call this is 50% less. It's probably not that clear when we have a projector here. It's more clear on my laptop, but you can see all here, all the vertical lines is a cringe mark, and on the new glass we been make have a lot less. Yeah, even worse condition. We're taking some pictures under the polarized light, which means people wearing sunglasses. A lot of sunglasses have polarized light. And you see, originally we see a lot of like rainbow colors on the glass surface, which is really coming from the cooling processing because it's a single light, I believe. And the new made machine, actually you see a lot less, only at very top of the panel, you can see a little bit, but with the original one, you see the entire panel, you can see some cringe marks there. I think this is almost the last page. Put some videos here, and also we like you to see at the edge, especially the edging area of the glass. You see, one of the panel have a lot better one. I'm not. You can pick which one your favorite, but really really this is what we are achieving right now. So again, like we've been visit couple architects' office recently. We've been often asking about how people can identify, how people specify the tolerance for the curved glass. I mean, we've been thinking about this for a long time because in the standard, you cannot measurement the roller widths on the curved glass. So from our perspective is we always suggest our client when you design a project have curved glass, or when you design a project have a lot of curved glass. We highly recommend it. By the time someone have to make a decision to choose the glass, we will be suggest to do a full-size mock-up. If you like to order a couple pieces of full-size mock-up from different glass manufacturer fabricators, and you put it side by side, you walk around the glass, you get a better feeling of which glass have better, less distortion or better quality. Yeah, that's pretty much everything here. We have a little booth outside, and if anyone have any questions, we are more than welcome stopping by our booth, and we can chat. Thanks again.
Thank you, Bob, for that nice presentation. I think it was pretty impressive, the sizes that you guys are achieving and the level of quality control, which was kind of pretty mind-blowing how you guys are striving for perfection there in the glass. So our next presenter is Dana Getman, principal at SHOP, and her presentation is entitled Habitat, a New Vision for Living in Los Angeles. So please help me welcome her to the stage.
Oh, thank you. Just to get the clicker. Hi, I'm Dana. I'm a principal at SHOP, and I'm going to talk about habitats. This would be more of a case study of a specific project here in LA. Quickly, because I know it's lunchtime for everybody, but SHOP, if you're not familiar with us, we're an architecture firm based in New York City, about 120 people, multidisciplinary, but I'm personally from LA, and so really excited to present our first built work here. The client and builder on this was Lend-Lease Development, an incredible partner to work with through the process. Nippers Helbig was facade, home structure, Steinberg Hart for architect of record, and Realm for the all-important landscape. So we started this project in December of 2020, which is a fun time to start a mixed-use project in the world. And this was the original site. So it's about the size of a Manhattan block in in Los Angeles, right next to Culver City. So it's 800 by 200, but it's surrounded on all sides by walls of the Metro, the Expo line, Seas Candy, not a bad neighbor. But really, La Cienega is our only main entrance. But the amazing part about it is the bike lane access, the metro access, and all these things urbanistically that you wish for in a project in LA. And so zooming out, we were thinking about, and I know this is a facade conference, but it all comes together. But the project site is really in La Cienega. It means like the valley or the marshland. And so we're thinking about how we can reintroduce the incredible landscape and the things people love about LA into this project. And the other key piece is this like nexus, like Culver City and LA meet in this like halfway between downtown and the beach. And so that legacy and that history of this as an intersection was really important as we conceptualize a building. So this was kind of our initial sketch of how can we merge this idea of landscape, history, and transit into a new type of mixed-use development for LA. And so at SHOP, one of our where we start with a lot is that it's not about the building as an object, it's about the space we create and how that informs it, and then how the facade and our details grow out of that. And so if this is the site, the 200 by 800, and we have those kind of boundaries on all sides, how do we really think about bringing people in and integrating them? The first thing we did, and this might be the New Yorker mixed with the LA in me, was push all the vehicles to one side so we could really free up the ground plane for pedestrians and for bikes. And then creating what we call Cienega Square as this great mixed landscape in the center, and weaving that with paths both through and both through the building and exterior, almost like a campus. And then the buildings grow from that network. The office buildings is about 500,000 square feet, over 500,000 square feet of program. Half is office, which is the building to the right, and then half is residential, which grows up to the left or the west. The buildings are then shaped to really take advantage of what I miss so much about living in LA, the sun, and this incredible climate. So the resi building folds, so the deck and the amenities and the terraces all really face that south solar exposure, and then the office folds down as well. And the other key piece about building here in the valley is the views. And so to the south, we have Baldwin Hill, Kenneth Hahn State Park, and to the north, we have the Hollywood Hills. You can see downtown LA, and so really shaping the buildings to start to prioritize that. And so they kind of weave together in this mixed-use ecosystem, and the enclosure becomes a key part of how we moderate between the form of the building and that landscape. So while we've worked with Realm to do this incredible landscape that builds up through the project, really thinking about how that folds vertically up through the project. And so the facade is really conceptualized as an extension of that landscape. The buildings all fold and bend in to really draw your eye through and create that great space. And so going back to a sketch in our early days, when we were thinking about the detailing the facade, it's really, again, in like leaning into LA architecture and why people want to be here, is that it's that indoor-outdoor connection, that the buildings aren't a glass wall, that we really want that porosity to bring people in and out, and the facade is how we modulate that. And so our priorities were the parts to whole relationship, connection to nature, and also, as I mentioned, this was 2020, 2021, we really wanted to be cost sensitive and work with the client. So how can we achieve something that's high design, but using standardized parts, not a lot of, unfortunately, kind of following the curved glass presentation that wasn't quite in our budget, but we could still achieve the curves we were wanting to. But really, we kept leaning into this idea of the landscape and how we could bring the colors, the textures, the light, the shadow that we love so much about walking and hiking through our parks here. And also the legacy of architecture here, even thinking about, I know it's a very different design than Craftsman, but the Craftsman houses with the color of the shingles, that blend into the landscape instead of stand apart from it. And so we developed our palette, again, using standard materials, painted aluminum, glass, to really reflect that love of that landscape. So the residential building, it's all window wall, so fairly simple, standardized, again, system, but through using a scalloped metal panel and through working with AkzoNobel and getting custom paint with a mica embedded, we were able to get some of that dynamism in that color. So the palette is a bit lighter on the residential. And then on the office, we went a bit darker with a larger scale panel. So they're almost, so they have this kind of complementary relationship. And what's great about working with both shape, shadow, and also some of the material of the paint with the mica embedded in it, is you get a huge range of color, almost like you would on the leaf of a tree. And so these are photos of the same panel, just in different light. And so the idea was these two buildings would weave together and be complementary, almost like you would see an oak and a eucalyptus in a forest here. And so these are photos from the site. It's opening soon, so these are still some in progress construction photos. But you really see that dynamism from the sun to the shade, from like the witching hour to late afternoon. And also that relationship, how it changes. This is an olive tree, not an oak tree, but still for the residential building, and how that color really picks it up. The other piece was the really key to the massing was the curves. And we didn't, again, have the budget for curved glass in this project. And so we really focused on rationalizing and using our digital model to rationalize both the number of panels and the curves, so that we really just have curved slab covers, and then everything else is made up of straight pieces. And so that really starts to draw your eye through and break down that block into these parks and shared spaces. And so these are some photos of, again, under construction. You can tell from the orange vest, but how that is starting to shape up on the site. And then the last piece, again, going back to that indoor-outdoor experience, and it's fun, like following Lisa in our Atlassian project that we worked on. But that one thing in a lot of both in our office and residential work, that connection to outdoors, and especially in LA, to take advantage of that. And so the facade really opens up on those terraces to be able, with using nanowall systems, to create that indoor-outdoor experience. This is the office looking to the south to Baldwin Hill, and that opportunity to have that grow up the building and through those steps to really create both a social and a environmental ecosystem. And then also on the residential, where about 96% of the units have private outdoor space, but also that extensive terrace, which has totally porous amenities that open out to the exterior. And so this is opening soon. If you haven't seen it already, it's, I think, the only green building off of the 10. But it's we're really excited and hope everybody can come by and enjoy walking through the garden and the project we're creating here. Thank you.
Yeah, well, we have some time for some questions. I don't know, Gamer, if you're willing to take some. We should open it up also. But our office, HKS, we've moved to Culver City, and I've seen this building, and it is really inviting. If you're in the neighborhood, really check it out. It's a really nice addition to the neighborhood. And I think here in the Southern California climate, we have a lot of leeway, right? But sort of a lot of.
So I was trying to go quick because we were going behind time. So
yeah, well, performance-wise, yeah. I mean, I think, the way that you've sort of created all these indoor-outdoor conditions is really inviting. And can you speak to sort of like the balconies? I think those are the only thing that someone might be curious about. If you went through some exercise that certainly break those, or is it just that we're fine sort of in the climate? And
you mean the balconies, the steps were a key part of the design, and especially on the heels of, so our Uber project up in the Bay Area opened, and that importance of that one features a kind of third space, or a naturally ventilated space, which is has been really important to our approach to office design. And so here, because of the climate, we really wanted to focus on those terraces. So every office floor has space to move outside and have that kind of indoor-outdoor connection. There's also a vertical connection through the lobby that links you through there. And so that was a key component to the design. And then the residential balconies, and this is always, if you've done residential work, everything wants to stack and be vertical. But with the emphasis on the landscape, we really wanted your eye to move horizontally. And so we worked with the unit mix to get a shifting of the balconies. So the facade has a shift and the balconies have a shift. So it doesn't read as a stacked vertical facade. It's more of a kind of horizontal play that, again, carries your eye around the building instead of stopping on it.
So even the segmentation is designed to really like some attention to the panelization.
And that's always a fun one to coordinate, but that's okay. That's why we do everything in digital model. So it was great.
Fantastic. Anything from the audience? I think Dana's been generous enough to get us back on track, but if you've got a question, let's hear it.
Okay.
All right. Well, thank you so much.
Great. Thank you.
Thank you. Okay, so now we have a presentation by Thomas Miller, the Global Head of Projects at Forrester Profile Systems, and his presentation is entitled Framing, Safety, and Style, Best Practices for Steel Curtain Walls and Fire-Rated Openings.
Wow, that's very artificial. Hi, Thomas Miller. I oversee the Special Projects Department at Forrester in Switzerland. Our world revolves around cold-formed steel profiles and systems for doors, windows, our DNAs, and the fire rating. I don't want to talk about all that. I want to talk about what motivates us, and this is what I mean with a modern approach. How do we, what drives us? How do we take responsibility for carbon footprint and what can be done? And from a fabricator, from a system supplier standpoint, in order to cater to the modern use of a traditional, I don't want to say old, but a traditional product like steel. Basically, in addition to what Lisa was talking about earlier, the recycling, the circular part, but more granular on how we develop new systems. There it is. Oh, that's the, yeah. Yep. Okay, but first start with a question. You are designers, you're architects, and you're responsible for specifying the glass, windows, the doors. What product would you use? Would you use a big bulky aluminum profile? Would you use timber, which is very high maintenance? Would you use plastic, vinyl? Certainly not. So this is why I'm advocating for steel today. This is, like I said, an old product, a historic product, which is a great fit in historic, but also in very modern buildings. Just one slide, some facts, who we are. For those who never heard about us, we are a Swiss-based company. We're more than 150 years in the market. We're producing about 2,400 miles of cold-formed steel per year. And in 2024, and this is where my real story begins, we built and started working out of a new campus, which is according to my knowledge, still the only structure in Switzerland which is LEED Platinum certified. And on the top right picture, you can probably see there's a lot of photovoltaic elements on the roof, 3,400. It's almost 2 football fields. And as a result, we're completely self-sufficient on an average sunny day in Switzerland. See some of the coils. This is our products. But again, if you want to know more about our products, we have a table here, and we're going to teach you everything we have. Our vision and our responsibility, and this is what I really want to focus on, we have a green steel agenda. Well, there's debates about green steel. What does it really mean? Let's just call it low carbon emission steel. We are heavily thinking and anticipating how do we reduce and what can we do and how can we contribute to a low carbon future. And we have a goal. Our goal is to reduce our CO2 emissions in 2030 by about 55%. We do this in a very holistic approach. But it starts with the whole fabrication, with the production. I'll get into more details later. We're using low carbon emission steel. We're using recycling. We're using the recycling potential of steel. This is a product, and like I said, it's old, but it's at the same time it can be used again and again. You can have 100% recycling content. We're using currently about 85% in the steel we're selling to the market. This cannot be done with most other products, and I think this is a very important part. And durability, which is another portion. 50 years, not a problem. You just got to think about the right coatings or the right use of steel or stainless steel. But then this is a very durable product, which you can hardly get with the modern, more chemically based products or used in our industry. We're trying to avoid testings, or we're trying to avoid testings or surprises at tests. So we do simulations. I think we're the only company in the world who can do simulations of fire ratings. So fire rate testings, simulated first, and then we have one go, we have one finished test, and we're not facing any surprises. This helps. Sustainability across the entire company enterprise. Our main suppliers, by contract, have to use electric trucks. Lisa said, hey, it needs to be from local suppliers. Yes, absolutely, local suppliers, but also here with right contracts, you can force them to use electric trucks. Our own fleet of cars is all hybrid and electric. We have a paper-free office. It's all small things, but this helps. And of course, full transparency to the market. You can download the EPTs from our webpage, and that gives you clear transparency. And of course, back to the product. Steel is a product which is just very robust in comparison to, let's just say, aluminum. And because of that, we can use smaller profiles. We can use smaller geometries, which adds to extra leasable space in buildings. So that is also with the thermal breaks. This gives you a lot of advantages. Green steel, low carbon emission steel, as I said before, about 85% is what we're using. This is the primary energy consumption compared between aluminum and steel in general, primary steel. It depends a little bit on the furnace, but that gives you an idea. It's about half. And also smart design. So one of the product designs is, okay, we need thermal breaks. We need lower U values in the frames, in the door frames, window frames, facade systems. We're not using any plastic. Talking about recycling content, we're using stainless steel because it has a lower energy transmission rate compared to carbon steel. So this all helps to basically get to the goal, to the target. We still do testings. We still, don't get me wrong, we're still doing mock-ups for certain architectural challenges on the right side. This is a classic 1970s French design high-rise in Paris. So we do these tests in order to show the architect and the investors, okay, this is a sealed system. It matches your specification values, but we love to avoid all that. We love to do simulations. This is a fire rating simulation. Basically, you have two buckets. One bucket on the top, it fills up. Once it's filled up with energy, it releases into the core. It's a simulation of a 120-minute fire-rated profile. Or we're simulating welding. We're trying to avoid any mistakes once hands-on work basically kicks in. We also simulate gaskets. Why is that important? Because here we can show this is a part of a hurricane testing, which is currently going on in Florida. we're trying to show and find out what geometry is the best in order to seal gaskets, windows and doors. And at the very end of my short presentation, I give you 2 or 3 examples, references. I very much love this design. It combines everything which we stand for. It's a reuse of an old factory building in Switzerland, a paper factory, converted into living and workspace. The architect insisted on having an industrial look. At the same time, they wanted a high-tech system. So, which it is. You have a triple laminated IGU. You have a thermally broken but still very slim window system. And the coating, the finish is hot dip galvanizing, which you can only do when you avoid any plastic in your system. You can't dip a plastic system with plastic separators or whatever into hot dip galvanizing bath. This is possible with that system, and I just like the design. Another system which has a high sound insulation specification value, and at the same time fire rated. It's a nursing facility also in Switzerland, and basically you have the courtyard, and we're avoiding any corridors where people with Alzheimer's might get stuck and can't find their rooms. Here they start spinning around, and we can see them and basically help them back to their rooms. The architect's intention was to use honest material, steel, glass, timber. That's it. Southern California airport, private airport. On the right side, of course, you have a fire rating here under 20 minutes, and you can zip your champagne, and they load the champagne on your plane. And the final project is a very famous department store in Paris. And from one day to another, they realized it doesn't match with the current fire requirements and fire police requirements. So they shut down the entire department store and reopened it. And of course, back to the beginning, the hotel in Belgium, steel, of course, is a perfect combination. Fire rating, very strong, very slim, the perfect match for an historic building. Thank you very much.
Thank you. Thank you. Thanks for the presentation, Thomas. That was really, really nice to see all the advancements you guys are pushing with steel. So slender, and now the high performance aspect is so nice to see. So we're just setting up some of the stage here for the next presentation. It's going to be a panel discussion here. But as we're doing that, I'm just curious, we have such a diverse gathering here, and just curious, like how many of us here are architects? If you can raise a hand. So that's a pretty good split here, about half. How about specialty contractors? Are they all out in the other? All right, we got good representation. Engineers, always very good. And actually, we have like the whole supplier and sort of industry arm of it here. What's even more kind of, I think, encouraging is I see a lot of more young people at these events, and I think it really points to sort of the way that the facades industry has matured over decades. Now we come to a place where we're so sort of close with all our collaborators as far as process, right? So technology, I think, is one thing that at HKS we really leverage a lot, and we really try to do that to cross-pollinate. But I think that's the way of the world now, right? All our tool sets, our processes, even the sort of pool that we hire from is almost the same nowadays. So I do think that facades in many ways has really closed the gap on things, and I think all of you are part of a community that I'm really proud to be part of. I've been, attending these conferences for the last couple of decades, but yeah, it always just seems to get better, and it's a great learning process. So without further ado, I'd like to have Nathan Witasek come up. He is the fire protection engineer and investigator at SGH, and he will be moderating this panel. entitled Building in Fire Resilience in Multifamily Public and Commercial Facades to Respond to Catastrophic Blazes. Hey, everybody. My name is Nate Vidasek. I'm a fire protection engineer, and I'm partner and principal at Simpson, Gumpertz, and Hager. We are also fire life safety in addition to facades and closures. It's a pleasure to be here today. We're going to introduce and bring in our panel today in just a moment. So while we're waiting, we'll just bring up our presentation. Okay, so today what we're going to talk about is intended or unintended fire resilience. And we often think about, when we think about wildfires, we of course come back to the recent fires that happened here in Los Angeles in the last couple of years. But in reality, these fires and these conditions, not only do they expose residential structures, but they are in fact exposing commercial multifamily buildings as well. Facades are the last word, and they are risk systems. The important thing to think about with facades is that they're not just individual components, but they behave like a system, and that's true for all kinds of purposes that we already use them for. It's especially true for wildfire resilience. Last year in January, we lost 16,000 structures, and there was $250 billion of economic loss. The insured loss estimates range from about 50 billion to 160 billion at present. When it comes to wildfire and the types of threats we're dealing with, there's a couple of frames of reference I want to kind of bring to your attention. The first is that 97% of the losses happen in about 2 to 3% of the events. So you have to think about that. The next bit of this is it's kind of simple. There's really 3 mechanisms that drive these losses when it comes to facades. And it really truly is at the envelope of the building where the rubber meets the road. The first is embers. And the way to think about this is that embers find any gap, crack, anywhere they can go, a stagnation point, and those embers will actually then ignite the structure behind it, and that can lead to the external borne ignition, which is something we can't really control. The next factor is radiant heat. Radiant heat is what you think about when you're at the campfire and you're roasting marshmallows and you build that fire just a little too big, and next thing you know, your sneakers are melted, right? So this happens in structures, and radiant heat, I'll get into the mechanisms in a moment, but it is one of the dominant factors in structure-to-structure loss once you have an ignition that typically starts with those embers. And of course, wind and geometry. These fires don't happen in isolation. The fires happen in the context of dry conditions and high winds, and that complicates things. It opens up many, many different possible avenues by which you can get structural ignition. Radiation is really a function of what's called a view factor. And there's this inverse squared law when you think about how heat is transmitted via radiation. It's a wave propagation. And what you have to understand is it's a function of distance, but also the exposure, the view factor itself. The kind of exposure you get in a structure-to-structure wildfire is very different from the kind of exposure you get from the wildfire itself. And this is what results in the kind of conflagration that we saw last year. Convection is the plume. And in the plume, we carry with that the embers. This is just a mechanism by which you can start 10,000 simultaneous fires, as we saw in the Eaton fires.
And those fires only need to find 1 or 2 willing candidates to ignite the buildings. And conduction, we think that the Palisades fire was originating with conduction. Think about a fire can live underground for a very long amount of time. A fire can move through the structure. So this conduction shows up in a couple of ways. It's propagation through a fuel, or it's one fuel that is next to the other, and that fuel heats through the facade system, and then everything on the inside is vulnerable. So many of you here might be thinking, well, I'm not really a wildfire person. But I think the challenge and what we want to talk about today is that if you manufacture, design, install, specify facades, you are de facto a wildfire person. So, quick question, opener. When you think wildfire-resistant facade, what's the first thing that comes to mind for each of you?
Who wants to go first?
Sure. Why don't you go?
Well, I'll jump in. I think about I really think about cladding, and I think about how long that can last before, embers get in and these types of things. But I also think about, and I'll give you more on who we are as USGPC of California. I think about the occupant, and I think about like the comfort somebody has to live here in this beautiful place, Southern California. How confident are they that this is going to hold up? It's not just resilience isn't just about like once it's gone now, how do we rebuild? I know that's a big part of what we're talking about here. But how can I be comfortable that where I live is a wonderful place that's going to be resilient to that thing coming and taking away whatever lifestyle, or life that I have? So I think about the occupants a lot.
Okay, thank you.
I'll keep it running down the line. Is my mic working? No. That's good. I'll just project. Hi, I'm Isabelle Borderies. I'm subbing in for Nathan Bishop today. I'm an associate at Koenig Andenberg Architecture. And the first thing that comes to mind for us is really context. As you were just mentioning, we take wildly different approaches depending on if we're thinking through an urban, suburban, exurban context. So context. Like you, I think, right, we start with people, we start with vision. We don't start with the worst case scenario, even as we're designing for it. And so contextually, what makes sense for this building, for its program, for its occupants?
Thank you, Rain. Tom?
Well, when I'm thinking about a fire resilient facade, especially for a multifamily project that I'll be presenting in a little while in a dense urban setting, I would be optimizing for really limiting the exterior spread, because that's really where the failure mode is between a contained incident and a catastrophic neighborhood event. So limiting the spread, I think, is going to be one of the most important issues.
And this is why we have these people here and not just an engineer who likes to talk about radiation. So. Okay, so today you are going to hear the perspectives from Colin, from Rain, from Tom. Tom's going to lead us off in the first segment with the idea of performance-based design in the many forms that it comes. And then Colin will talk about materials, carbon, insurance, but he has a very interesting perspective that I think we'll find entertaining and actually somewhat heartening. And of course, Rain will talk about this notion of how design imbues everything and how it's a system of one. They're not necessarily something that have to be competing.
All right. So first, thank you, everyone. I'm Tom Silva. I'm an architect, and I work for Webcourt Builders, a large contractor in the Bay Area. I've been doing design management integration for about 10 years with that company, prior to which I was working in architectural firms as a director and so forth for many years. But I'm here to present an interesting case study that involves a student housing project at UC Berkeley, located on People's Park, if some of you know that. This project is quite large. It's 1,100 beds, and it has a very complicated multi-material facade system. The project, as you see in the rendering, is located in a very dense urban infill site, and it's surrounded by residential and commercial neighbors on all sides. Now, one of the constraints that we had is that this is an 11-story building, and so that really precluded us from using any scaffolding. So that meant that the facade had to be unitized, pre-assembled in a factory, and then craned up and piece by piece into the structure. Oh, yeah. There we go. All right. It's a T-shaped building. The architects were Letty, Maid, and Stacy from San Francisco. Very great firm. The components for the building is primarily a rain screen. And it's very unusual to have a rain screen panel on such a large building that's installed without any scaffolding. So the trick was how do you make a unitized rain screen system? So the design provides for what is called a mega panel. So these mega panels are essentially large, 1-story high by 1 bay wide prefabricated panels that includes the rain screen within it. The design was originally non-combustible completely. So it had mineral wool insulation inside the cavity, which is what we'd expect. However, the problem was that once we got the trade partners involved to do the engineering, it turned out that the shear strength for the system the architects designed was not sufficient. And so what happened is that we had to substitute the mineral wool insulation for basically a structural insulated board. And that led into another issue, which is that particular product had EPS insulation, which you all probably know is a flammable material. That meant that this project had to undergo a rather rigorous fire test called the NFPA 285. That test, by the way, is an assembly test. It's not just a material, but the entire assembly gets tested. This diagram shows the construction process for manufacturing a mega panel. It is built in a temperature-controlled factory. It's assembled in about 8 or 9 different stages, and then it's transported to the job site and craned up. Each panel integrates the framing, the sheathing, the insulation, glazing. There's precast on this project, fiber cement cladding, and these panels are installed on top of each other with these slip track joints that kind of resemble a tongue and groove connection. So once the decision was made to proceed with this fire test, it took about 8 weeks or so to develop the mock-up shop drawings and then to finalize the testing protocols. The size of the test is 2 stories, and it was about 15 feet wide, 18 feet high, and that replicates the actual 2-story condition on the project. This detail shows an enlarged section detail of that particular joint. It's kind of a tongue and groove slip joint. And the green is the highlighted portion that caused the fire test. This is this called a rock-on structural insulated sheathing with a 2-inch EPS core sandwiched between 2 layers of magnesium oxide panels, which provide the shear resistance for the entire assembly. And this detail kind of shows this horizontally, but normally it'd be vertical, but this shows the actual slip joint. As you see in that detail, the tube steel is stuffed with mineral wool, and that serves a couple of important, it solves a couple of important issues. One is, obviously, it breaks the thermal passage through the system, but it also, because of that, it also reduces the rapid exterior flame spread, just because it's going through an insulated material, and that the heat point is much less. What you see here is a kind of a paradigm of the fire test, showing a 2-story chamber. There are several variables that need to pass this test, and they all have to pass. So one is no flame propagation on the second floor. The second is that the thermal couples that are installed onto the mock-up cannot exceed 1,000 degrees Fahrenheit. The test is for about 35 minutes. And then externally, the flames can't reach 10 feet above the window opening or 5 feet laterally, horizontally from that window opening. So there's a few other criteria on that test, but those are the main ones that we were focused on. This shows the completed mock-up. As you see, the window is on the bottom. On the right, we see the gas rig at ignition with the test fully underway. And again, this is about a 35-minute test. We all saw this on Zoom. The testing facility was located in Oklahoma. And this is really what past criteria looks like in an NFPA 285 test. So what you see here are flames that are, they are fairly well contained at the opening, and they're not traveling up the facade. If you see the numbers on that left side, that's really your measurement scale. And what we found out that at the midpoint of this test, those flames reached a maximum height of 8.5 feet. If you remember, if we hit 10 feet, we don't pass the test. So we did pass, but there wasn't a whole lot of room to spare. The building is now rising in the Berkeley skyline. You can see the mega panels on the facade, and it's now tested, permitted, and quite buildable. The kind of learning lesson for all of this is that when we're dealing with a design, build, delivery, you can create a gap between the architectural intent and structural reality. And so on this project, that gap kind of produced an unbuildable assembly, a material substitution, and a fire test that nobody really anticipated. The test did pass, fortunately, but the real takeaway is that the path to a resilient facade isn't always a straight line, and sometimes resilience can be a thing that you prove when you're really on the way to solving a completely different problem. Yeah.
Thank you, Tom. So just a couple of questions there. First would be, what's the tripwire that you think should tell someone, hey, we need to evaluate a facade? If you could give some advice.
Yeah, let me get my notes. Sorry about that.
And while you're thinking about that, then the other question would be, was there any surprises that came out of this testing process for you?
Okay, so first the tripwires. The first tripwire is really code related. The NFPA 285 comes into play whenever you have a combustible material in construction types 1 through 4. And those materials have never been tested in an assembly test before. So that's really your first tripwire. The moment that you introduce any new product or material, like a new insulation or a weather barrier, or even change the geometry of the cavity, then you've really stepped outside of that tested condition, and so that becomes a trigger for validation. Another tripwire is really interface complexity, which we have heard in the previous lecture. The risk there often hides at transitions and slab edges, window perimeters, and of course joints. If the facade is relying on multiple manufacturers with layered systems and no one has tested the exact combination of those systems, then you should assume that the burden is going to shift to you to prove performance. The third tripwire I see as responsibility. If no single party is willing to warrant that wall system, then that's a big red flag. And that actually happened on this project. We had trouble actually finding a trade partner to undertake this. But that usually means that the system hasn't been validated as a whole, only as parts. And that's the gap where failures can also occur. And finally, timing. If the NFPA 285 is coming into the picture late, say during permitting or procurement, and that alone is a real signal that the team has been operating on assumptions. So at that point, you really need to pause and move from assumption to an evidence-based solution.
Yeah. Well, thank you. Yeah. There's just a quick show of hands. How many people have either commissioned or witnessed a 285 test? So we got a couple. Yeah. It's really interesting. And the key here is little changes, for example, in air gaps, things like that make a huge difference. And this relates to something that applies, again, for normal buildings, but also buildings in this wildfire context. So thank you very much, Tom. Appreciate it.
Oh, sure thing. Oh, I didn't get to your second question.
Surprises?
Yes.
What do you got?
Well, actually, since this product really passed the test, there wasn't any change in the documentation or the design. But what it really gave us was the elimination of uncertainty. And so that allowed the test to move forward really with a foundation of evidence rather than with an assumption.
All right. Thank you. Okay, so now we're going to move into our second segment. And I'll just start off by introducing Colin. And Colin is with the U.S. Green Building Council. And this council covers defensible space. The guide that we were talking about today in part covers defensible space, cladding, envelope. But when I spoke to Colin, he was very clear that while that's all good, he said the real deliverable isn't a checklist. The real deliverable is confidence. And with that, I'll pass the torch to Colin.
Thank you. So the first thing is that I'll say I crammed for the exam a little bit here. Ben Stapleton, our CEO, was going to be here today, and then and I stepped in. And so what I did was I revisited this guide, and first audience interaction. First person to raise your hand gets this free guide. Nobody? Right there. Okay. 20-pound bond, laser printed at home. This is going to be good for you. But so we created this guide. There'll be a QR code for it, et cetera. And so over the last couple of days, especially in talking with Nate on some of these things, I thought, wow, we really did some fantastic work here. I'm here to promote, I know. But then I went to bed last night. I woke up this morning. It was like 5:23 a.m. and thought, I really need to walk the perimeter of my house. There's work to be done here. And I didn't realize how much there is to be done. So the fact of the matter is that we're trying to educate people, even like myself. I'm swimming back into the shallow end of the pool after all this time because it was fantastic. But just like, how do you start with things? How do we as a community begin to address these things when there's trauma and fear? You know, what are the tools, the very basic tools, the screwdriver, the hammer, as far as like knowledge gaps to help people? And so what we've done here with USGBC California is in 2024, we started taking some of those tools that we developed as USGBC LA for 22 years, training, workforce development, et cetera. And we looked to unify the state of USGBC chapters up and down the state. We have 10 different regions, and say we've had success with this program and this thought leadership series and this best practices guide. And in that, we would say, let's share with your group, and let's take, shipping beats perfection. That's the entrepreneurial way. Let's get it in your hands, let you customize this and move it out to your regions. And so what we've done is we've moved up and down the state, up and down and across, and provided best practices. Now, not all of California is susceptible to wildfire, but certainly a lot of it is. And so what we've created here is something that we hope is at least top level, an introduction to how to be thinking about all these different things. By the way, it's residential more than commercial and multifamily, but all that's really, it's a similar perspective. It's just about bringing it to scale and bringing in economics, which I can talk to as well. But this is who we are up and down the state. Can I go to the next slide, or that's you? Great. So this is really interesting. And Nate, we talked about kind of like, the fact is I've worked a lot in biomimicry and nature-based solutions. And what I said to Nate was like, if we didn't have buildings, we didn't have 4 walls and rooftops, we wouldn't last very long out there. And in the biomimicry realm, it's a lot of like nature. She's so beautiful and sophisticated and elegant, but man, nature will tear you up if you stay outside of buildings. And so that's why we have buildings in the first place. That's why we created these things to survive and thrive as human beings. And the fact of the matter is, if you look at pre-disaster up to reconstruction, what we need to do is just say, okay, well, nature's going to be a little tougher on us as we move forward. So what do we need to do now to get up to this next level, and kind of level up things, right? And so where we exist and where we best contribute value as an organization is really, there's this heroic element where everybody says, all right, we're all together. And suddenly it's big news and everyone's coming together, kumbaya, and we're giving away, we're bringing clothes to shelters and all this kind of stuff. That drops off. And then suddenly people are forgotten. Homeowners are forgotten. Residents are forgotten. And then that's at the point where they most need the support. And so that's what we're trying to say, come in here and once you work through the grief up to this new normal, how can we help you? How can we still be here from you? Over a year later, we published this in April 25, and now we're putting together a new one, updated, of course, from 51 authors, contributors, and a whole bunch of partners that are weighing in and saying, all right, what do we need now? But we as an organization want to be available to people to say, all right, you got this. And let's also not give you I know this is 65 pages, but you don't want to be overburdened with a whole bunch of lists of things you have to do. Like, what is the one thing I could do? And I think, Nate, that comes around to what we talked about, just iterative development. I work a lot in innovation. You don't need to cross the chasm. You don't need to retrofit or build the home of the future here, but you do want to be more considerate and know what options you have and slow down a little bit. This is really a permission slip just to slow down and consider what options you have for building stock that we hope will be here for a long while. The most sustainable building is one that stays in place.
You said something to me the other day, insurance forces innovation. I'm wondering if you can expand on that.
Yeah, it's the fact is, when we have to pay higher insurance premiums, then we're like, okay, how do I get that down? And it's like some of the best creativity, some of the best innovation comes about when you have constraints and pain. And so I don't fault the insurers for that. In fact, I think we've been paying less than maybe we should have, given all the different risks that we have here. And so this last event really kind of broke the bank a little bit. I think rates will come down, but they're going to come down when we have innovations. We say, how do we go about that a little bit differently? And again, not quantum leaps and chasm crossing, but how do we actually just do the little things? It's like what's it, safe driver discount or something. Well, I did these things, my defensible space looks good. How do we do the little things to be able to bring the rates down? But until you feel a little bit of pain, you don't always want to move.
Yeah. All right. Thank you.
Is this me too? Oh, great. So if you go here, this is the wildfire guide that you've won, good sir. And if you go to the next page, actually, because I could talk about all these different things, this is what it's all about. Again, I mentioned April 2025. If anyone here, architects, designers, etc., if you have any inputs on how we take this residential view or single family home residential view into more of a scaled, artifact for more multifamily property owners, facility managers, etc. That's kind of where we are right now. And I really do think that the difference is between what you'll read in these pages as a homeowner that goes out and walks their yard and says, all right, well, I can do this thing and that thing and the other thing, is that we have to really bring in not just the risk reduction mitigation, but also the economics. So if you own multifamily real estate, you're looking at net operating income, and you're looking at operational efficiency, and you're looking at building stock lasting a certain amount of time. You're looking at resident retention, things that would be attracted to them. And the safer they feel in that space, the better they'll feel about staying there. So this is what this is all about. And again, we're a community-based organization. We want people to come in and help us build these things, but what we are is a catalyst for conversation.
Yeah, no, I think that's really important. And again, one of the things that I keep thinking about is there's no one right way to do resilience. And, your concept of resilience is iterative. It's kind of brilliant. And a book like this, a guide like this, gives you just a whole set of tools to try things. We have concepts, we have ideas we use in practice, but no one has a monopoly on that. So thank you very much. Appreciate it.
Thank you.
Okay, so we're going to move on to a discussion about a case study with Rain.
Hi, everyone. Again, I'm Rain Laboratories. I'm subbing in for our partner, Nathan Bishop, who unfortunately couldn't be here today. But I am so excited to be here and meet you all because when I'm not at Koning Eisenberg, I also teach undergraduate architecture studio at USC, including their first exposure to facade and tectonic systems. Part of why I love being involved with our education projects like Malibu High School. So Malibu High School is a public high school for the Santa Monica Malibu Unified School District. And this building was in every facet really designed for resilience, for learning, and for fitting into its coastal hillside setting. It was a partnership with NAC Architects. And if we go to the next slide, I'll give you a little overview. So Malibu High School hosts 400 students, can grow to about 500, 70,000 square foot building here inside the perimeter walls, not including under the PV solar canopy. And it's located in a very high fire hazard zone in Malibu. Buildings no longer sit in a benign climate, as we all know. So historically, architecture in Southern California, and Dana from Shop was just talking about this, right, has embraced the outdoors. California modernism is so much about that indoor-outdoor connection without needing to think about defensiveness against the outdoor, and that's what's changing for all of us right now. But to us, addressing that change isn't solely about hardening buildings or retreating indoors. It's about rethinking how architecture can live with that risk as we continue to enjoy the indoor-outdoor relationship. So this is a time of innovation and invention where we're trying to balance protection and openness, where we're seeking to maintain those connections to landscape, but perhaps in different ways now, and where we're seeking to create a safe but engaged environment, particularly true when we're talking about high school students. If we could go to the next slide. So with that, the goal here wasn't to bunker the school, though it also, I should say, serves as a community center in case of wildfire. It's actually, the goal was to protect it while keeping it open and connected. That was something that we drove, that NAC drove, but that most importantly, the client drove. This was a key priority for them. It's also a net zero building, and I would say many of the similar decisions and trade-offs and weighing of different material choices that comes from that also impacts how we think about resiliency. We're looking for materials that are always doing more than one thing, right? It's not just that they're sustainable. It's not just that they're resilient. So the building combines passive and active strategies. The PV solar panel canopy that you're seeing here is shading the glass, solar bond glass, and producing energy. We also have a DOAS, dedicated outside air system, to maintain a high degree of air filtration. And in every way, it's designed to work with the climate. On the next slide, the educational vision for Malibu High School was really to keep students engaged with the world. This is a project-based learning school. And so our goals were to encourage curiosity and wonder and inquiry for learning to extend beyond the classroom. Really, what is going to enable these kids to do what we're sitting here trying to do today, right? Care about their world, about the future, be invested in resilience. So the ambition then is a lot bigger than academics. It's about getting them engaged and connected to their broader world. On the next slide, that starts actually with landscape. We kind of see landscape as the first facade in this project. Fuel modification zones are key in enabling this kind of setup. So before the fire can get to the facade, that first line of defense becomes the landscape. Of course, there's ideas of reduced vegetation near buildings, but we want to go deeper than that. We want to think about instead, how can we use waterlogged materials, etc., that are also indigenous plantings. So designing the character of the landscape to not feel empty rock garden or pad, right? To still feel like this resilient, rich landscape is as important as designing the building and creates the character of the place, especially when we're trying to protect against climate threats, to achieve that energy responsibility, and to maintain that Southern California lifestyle. That then is what enables this campus to become a hillside learning lab, where there are visible water filtration systems, where students see power being routed to their classrooms through these PV panels, where indoor and outdoor spaces are interconnected. The art studio fully opens up to the courtyard, and they pull out their kilns for ceramic classes, because if you go to Malibu High School, you get to have a ceramics class in high school. And it becomes this place where learning happens everywhere. On the next slide, maybe it's not surprising, actually, that a material strategy that was rooted in place, in a place that has burned and does burn, is in itself resilient in certain manners. So that material strategy for us was rooted in the textures of the hillside, the beach, the geology, the plant life, to really get the building to feel connected to the spirit of place. On the next slide, what does that actually mean? It means poured in place concrete shear walls, which were actually pretty great to watch go up to. It became a sort of community moment because the shear walls came up first, and so you had this sort of Stonehenge of a high school emerging on the hillside. There is the steel superstructure and the PV panel armature, which is sprinklered under in the exterior areas as well as those enclosed areas. There are perforated copper rain screens, which will be patinaing over time, and corrugated cement board panels to form that cladding system. On the next slide, these materials are chosen both for their durability and fire resilience, but also for the way that we were able to assemble, engage, move them to make the building feel airy, warm, comfortable, and rich in texture and light and shadow. And it is local copper and concrete makeups as well. On the next slide, so the building overall is part of the hillside and really meant to embrace its setting while guarding against wildfire. And on our last slide, I think the most important thing for our team and what will carry forward to other projects remains that resilience does not have to mean retreat or bunker. Social resilience matters too, and that does mean staying connected to place, to climate, and to each other.
Thanks, Rain. I'm curious, from your perspective, what is the biggest false narrative around resilience that you've seen? What kind of makes you angry? And this is a question for everyone here, I guess, but we'll start with you.
Yeah, I mean, I think about, the pictures that came out after the Palisades fire, and, we all initially had the reactions of horror and compassion, and then it went to, well, that sort of fortified concrete house survived. Why are we all not just building that? And, the reality is, beyond that social resilience aspect that I just touched on, and which is probably the most important thing to me, it's also not sustainable, right? To build in the most extreme way all the time. So to me, it's a balance between that. And then I grew up in New Orleans. I was displaced by Hurricane Katrina. And there was that big narrative of, well, why are people building below sea level anyway? It's their fault. And so I think being really careful about how we say who should live or learn or be where and why.
Yeah, I really appreciate you saying that. This whole idea of guilt that is out there is ridiculous. What do you think, Colin?
What was the question again?
Just in terms of what's the kind of the biggest false narrative around resilience?
Yeah. I was kind of stuck on New Orleans because I'm from Shreveport.
Oh, nice.
Okay, sorry. We'll talk later. So I think the false scenario is that it's too much effort and too much cost. Resilience in nature's definition is multiple strategies to achieve the same goal. And what I invite people to do is just be conversant around a whole bunch of holistic ways you can go about being more resilient. Don't try to do it all at once. That's where we're losing people. They think it's too costly, too much time, and they just blank out, you know. But do a little thing. And for homeowners, I'll even say, like, before you do solar, and I love solar, I own solar, think about just putting on, you know, mesh screens. Think about, oh, maybe I will trim those trees 5 feet off the deck, and it doesn't look too bad. And then you get into habit formation, replacing bad habits with good habits, and you get on a move here. So we just want people to just take a tiny action and like, okay, now what else can I do? You know, so don't think you got to eat the whole meal at once.
Yeah, this is where the left hand can help the right hand. You know, Rain had mentioned that the first facade was the landscape. This is really critical. You know, there's so many things you can do that cost almost nothing. And we have to start thinking about the whole of the system, even as we design the facades. Tom, what's your thought?
You have to be careful, I think, with the word resilience. It can be seen as an end-all, be-all, but, you know, we have ancient structures that are still occupied. Go to Europe, the pyramids. So resilience, I think, is more of a mindset, honestly. And I think it's about a project that just discovered it has a fire test. Well, nobody expected that, so we didn't resist it. We looked forward to solving that problem. It's really, I think, it's really more a mindset issue.
Yeah. Well, thank you. Yeah, and I will point out the pyramid is non-combustible construction. So, anyways, thank you so much. We appreciate everyone here, being a part of this, and thank you to this wonderful panel. At this point, we welcome any questions. We demand questions.
I think the audience demands lunch.
Okay, yeah, that's true, lunch. All right, well, we've got one question.
Just one quick question that I spoke very handsomely, and I think it would be fun to take a look at. And the public kind of park there, walk around our weekend.
Absolutely. So there are shared use facilities north of the pedestrian spine that separate the middle and high school. So that means that the pedestrian campus is really open on the weekends. It also incorporates a 5-acre environmentally sensitive habitat area that has now walking and horseback paths. So you are welcome up, and my understanding is there's also food trucks in the fire lane on weekends as well, so you can get a little snack while you're there.
All right, thank you very much, everyone.
Yeah, thank you so much to our panelists for that wonderful discussion. As we break for lunch, just a reminder that the venue would like us to keep our lunches outside of this room, but please enjoy, and we'll meet you here after the break. If we get all the speakers that spoke this session to come to the front, we'll get a photo and a little photo op and an award for you. Okay, thank you, everybody. We're going to get the afternoon session started here. And the first speaker this afternoon is Olin McKenzie, design partner at SOM. And he's going to give a presentation entitled Drawing on Restraint.
Thank you. Thank you. Great to be here. As he said, I'm a design partner at SOM here in Los Angeles. And I thought I would talk a little bit today about our design philosophy. I promised to talk about facades a little bit, but as a table setting, I wanted to go into how we think about design. David Byrne, in 1980, the Talking Heads released a seminal album called Remain in Light. And on that album, there was a wonderful song called Seen and Not Seen. And in it, Byrne tells the story of a man who's able to gradually change the shape of his physical appearance by keeping a desired image focused in his mind. And over time, this protagonist does just that. He's literally able to change his face to suit this more desired look. As the song goes on, it starts to get darker, and the protagonist wonders if perhaps he has chosen his ideal vision based on a whim or on some wrong idealistic idea. And towards the end, kind of terrifyingly, he wonders if he's made a mistake. And this has always reminded me a little bit of the designer's anxiety. As designers, we have our own personal histories and education and moral and kind of ethical grounding, and we feel pressured to coalesce all of that into a design philosophy, into a point of view. And I think we too need to commit, and at long length often wonder if we've made the right choice. I grew up in South Florida and was exposed to the weird and kind of beautiful ecology of that part of the world from a very early time, mostly because of my father. And from a very young age, he instilled in me this notion that nature was something to be cherished and protected, or abandoned and abused. And so then later, in my own education, I went to UVA, and I was maybe surprised by my own reaction, where I found that so-called green architecture at the time kind of left me cold as a designer. I found some of it on the nose, a lot of it overly driven by performance and data, and apologies to engineers, although I talk about those things all day long now. And it kind of eviscerated the open-endedness of the architectural product. And so for a long time, sustainability and myself were like two strangers at the cocktail party of my early career, exchanging glances across the room, occasionally bumping into one another, but really paying precious little attention to each other. Then here in Los Angeles, I went to UCLA for grad school, and a very important mentor of mine, Mark Lee, who was then a professor there, was starting a burgeoning practice, and it resonated with me. And for those of you who don't know Mark, he is this kind of incredible walking encyclopedia of architectural theory and history. And he's able to sort of channel all of that great knowledge and somehow distill it into works of clarity, where other designers might sort of fall into a kind of manic paralysis. And Mark made things that for me performed big, and still does, he and Sharon's practice, with a modesty of moves. Things that are simple, things that are clear, and things that I believed were founded on uncanny restraint. And so that word restraint embodied, or started to embody for me, an ethos that seemed like a noble aspiration. Channeling the restraint, I thought, had the ability to augment focus and intention, and it allowed designer and audience to kind of go deeper together. And as a scaffolding for any creative process, I thought, and I still think, that it held the promise of true clarity. I think you see evidence of this around us today, where things like digital fasting and silent retreats, minimalist lifestyles, even some of the kind of pared down architectural movements afoot today seem to be cultural trends that, to me, amount to a kind of refutation of the excess and distraction that is slowly taking over all of our lives. And maybe a kind of nostalgic counterpunch, but it's one that I think ultimately says that we can do better with less, and that we can actually thrive in restraint. And so these many years later, leading a studio for SOM, first in New York and in the last few years here in Los Angeles, restraint and its cousins, clarity and economy, have become the kind of guideposts for our architectural practice. Today I'm going to share 3 projects at very different parts of the country. And I hope by the end of it, you feel like I've fulfilled restraint in our design moves here. So the first one is 1245 Broadway, which exists in kind of the south part of Midtown in Manhattan. And an ex-SOMer come developer approached us to do, in the kind of wake of the pandemic, a trophy office building. It's on 31st Street and Broadway, and maybe its most notable feature, other than being in that kind of special neighborhood, is that it's on Broadway, the kind of lone, rogue, diagonal street. we embraced several pillars when we started this design. The first was to embrace the wedding cake. For non-New Yorkers, that's what we call the kind of result of setbacks for light and air as a result of the intrinsic zoning. And here we would do that along the kind of horizontal and diagonal lines of 31st and Broadway. But we had ambitions that we could produce a cake, but one that seemed a little surprising and lyrical in the way that it rose up. The second pillar was this idea that we could convince the client to not do an all-glass building, and maybe foundationally that framed views were as romantic and maybe more romantic than expansive horizontal views. And we convinced, he was an SOMer, so maybe it wasn't so hard to convince him to do a grid, but we convinced him that this was the way to go. And it also is a bit of a nod to the vernacular, the historical vernacular of that area. And then the final pillar, which is perhaps most appropriate for this talk today, was a notion of, could we take all the cladding off of the building? Could we not clad this building and use the structure ultimately as the architectural expression? That's an exercise that's not so rare in smaller buildings, and towers harder for a lot of reasons, and freeze-thaw cycle places harder yet. What this resulted in is a gridded building that then, if you see in blue here, changes the depth of perimeter beams dependent on what it's doing. So where you see these blue strikes, there are kind of double and single cantilevers that those are contributing to. There are several, although not many, column transfers. And so the kind of lyrical, slightly esoteric quirkiness of the grid is just literally a result of what the building needed to do structurally. The building was a window wall, and so it was kind of frame and infill. And of course, in the end, the cast-in-place concrete was going to be our expression. We were very nervous. SOM's done thousands of projects, but in recent memory, we had not done an architecturally exposed concrete building. So we felt like the stakes were high, and the client told us as much. What we wanted to do was create a very subtle texture and amplify everything that was great about the environment there, the kind of reflections off of the glass and the change in magical light of Manhattan. Two things I would add that are free. So we put on all of the vertical surfaces, which is to say the columns, this pleated pattern that you see. And then we even racked the columns along Broadway into parallelograms and racked with it that pleating, a kind of anal geometric exercise that no one but us would ever notice. But what it did was it carried this very subtle grain around the building, and we did mock-ups, of course, and you start to understand these kind of special moments that animate the building in different ways. We had a yard set up in the Bronx and did months and months of testing. We wanted a lighter concrete and had a really incredible team there. And the result is a building that is maybe a little bit like a hot rod, where at first glance it looks like a traditional New York City building, but on double take you see that there's a kind of riffing that has happened. In some views it's very stately and maybe even static, and then in others it kind of tangos and plays with light and shadow. We also found, maybe surprisingly, that it kind of hides in plain sight with the context there, and then at other times it kind of pops off the page by fitting in. So the second project is in Atlanta, and MARTA, the main transit agency there, has set forth a very ambitious plan to improve the infrastructure of their line and a lot of the kind of corollary public sites. And we were asked to look at 5 Points Station, which is really kind of ground zero of that system. This is a very large network that ultimately kind of spokes out from the center. And the station here at 5 Points is unsurprisingly located in an old historic neighborhood of Atlanta, and one that actually many moons ago thrived as a kind of mixed-use pedestrian urbanism. Sometime in the 70s, this station was built and is not uninteresting at the level of kind of heroic, brutalist space making, but it unfortunately kind of put a plug in Broad Street, which connects neighborhoods north to south through here and was really a kind of thoroughfare at the time. And so it has become a kind of symbol of blight and of actually severing communities off. So our main thesis when we started this was to kind of undo that ill if the station and plaza could attend to it. So we kind of came up with this mission to create a station that was as radically open as possible. We started, of course, with the existing station. It is being decommissioned as we all stand and sit here right now. When you kind of blow up that canopy, there is a hole that brings light and air down to the concourse. And we kind of stretched that hole to about 6 or 7 times the size of it, east to west. And then we instituted these pedestrian bridges that would cross over it and reconnect Broad Street north to south. And in that kind of tartan arrangement, there was an idea that passive, longer dwell times could happen to the north. To the south, there's a bunch of active accommodations, and in the middle, you descend into the transit hall. And then and this will be the focus of the latter part of this project talk, is we put a floating roof on top of this, a kind of outdoor roof. This gives you a sense, this rendered site plan without the roof on it gives you a sense of what I think is really a kind of civic scale of opening up the concourse down below, and then this is it with the roof on top. The organizers of the conference took great pains to tell me that this building doesn't have any facades, but it does have a 5th facade, and the 5th facade has to maybe do extra work in the absence of its absent friends. This is a section, and for those of you who have worked or frankly just visited any typical transit facility know that most of the architecture is below ground, and what sits above ground is usually something that welcomes people into the system and sits as a kind of symbol for transit. And here, this idea of a timber canopy that almost appears to levitate over this chasm, you approach from different ways. So this is kind of coming up through the eastern side of the site, walking under it along its southern edge. And then it snaps into a more kind of central Beaux-Arts approach to the east and west. And then maybe most importantly, from the north and south, you can see straight through it. And it somewhat disappears a little bit and reinforces the connection between these two neighborhoods that were severed at one time. When you descend into the concourse, it will be filled with natural light. The breezes that will cut through at grade mean that you will have a lot more air circulation down in there. And at the level of safety and security, it's a place that will be seen by more people and pedestrians. So this is a kind of typical section of this canopy, which was mostly opaque, save the middle sort of third of it from one side to the other. And it was there that we did more rigorous sort of simulation to understand. Atlanta's hot and wet. I have family there and have been many times. And it can be, frankly, in the summers, brutal to pedestrians. And so we wanted to balance the need to harvest natural light down in the concourse and not roast people. And so we went through a series of sort of different frit patterns and ultimately landed on a kind of 30% VLT that allows for that to happen while reducing the insulation heat loads dramatically. The last project is much closer to my new home here in Southern California, and not long after I arrived, our studio was lucky to win this really massive housing project at UC Santa Barbara. It's a truly absurd place to go to college. It's like paradise on earth. You go and visit and you kind of can't believe that people go to college here. It sits just north, actually, of Santa Barbara proper, in a town called Goleta, and it kind of juts out on this little peninsula. And our site is kind of towards the back, adjacent to some wetlands. What was special about this site is that it was adjacent to these historic wetlands, and that those even kind of stretched into the site a little bit. There were what they call environmentally sensitive habitats that rung the eastern and southern periphery of our site. And so the poem that we kind of wrote for ourselves at the very beginning of this project was, how could we create a huge amount of density? We're in this is the first phase of a two-phase project, and we're going to put, as they say, about 1,500 heads in beds here. So that's a tremendous amount of new people living on this site, and really a unprecedented amount of density for this university in terms of a capital project. So how do you do that and come out the other end with something that seems human and is weaved into the ecology? And it seemed like a very difficult and worthy challenge. So we developed this idea of these bars that were oriented east-west, and they kind of chevron in and out. They're oriented that way to channel the dominant breezes, which throughout the year mostly come from the west. And then the other thing we did, and you can see it in this image, is created a series of gardens in between the bars that went from somewhat formal in their center to slightly more wild as they approach these Esche areas. You approach the building on that bridge that you see in this image, and so you actually cut the height of the density in half experientially, and you kind of arrive to the front of each of these buildings at the second story. And our goal was to create something that was spongy, that's the word we kept using, filled with kind of pockets of light, air, and incredible flora. At the level of facades, we knew that they had to participate or the project would fail. It's a lot of facade. And so we developed what we consider a very restrained palette of a precast facade system, mega panels on the left, which cover most of the building. And on the right, there are a series of stair towers that are done in perforated corrugated aluminum. About 90% of the accommodations happen in this form, a kind of typical 4-bedroom. And if you step outside of that, you can see an example of how cladding works. And our idea was to work with this mega panel system. We were not able to do scaffolding for, maybe thankfully, for scheduling reasons. So this all had to be craned into place for speed. And so we worked with Clark Pacific out in Adelanto to do these at times 30-foot mega panel systems. And we fought with them lovingly about getting more than 3 inches of depth to the facade. We lost and got 3 inches. And so we had to convince ourselves, and I'll talk a little bit about how 3 inches was enough. But this is a typical panel where it's ultimately the prefabricated cementitious wall, and it attaches to the building in embeds. And if you exploded that, there are window cassettes by others that get plugged into that, insulation, and then a steel frame that gathers the whole thing together. We developed this sort of alligator's back pattern, and the idea was that the upper reaches of the building would receive more direct daylight throughout the day than the lower reaches. And so in a kind of organic way, there's a fractalization where the scales of the alligator back get more dense towards the top. Our team worked very hard to develop a discrete number of panels. There's only, Nico's here, I think there's only 4 or 5 discrete panels. And as you go around the building, you're challenged to see any repetition in it. It appears quite organic. And the result of it is that throughout the day, there's this kind of change in impression of the wall, where sometimes it seems quite vertical, other times the texture seems to fade away, and other times it's kind of lit up with this series of kind of fangs below the window line. And then because it's a spongy project, there will be all of these magical moments where parts of the project are spotlit and color both the diaphanous surfaces and these precast materials. Precast, we love precast, and it's always so fun because the rocks that exist here are not the same rocks that exist in New York City and so forth. And so we worked to develop a sort of cocktail of aggregate that would read very excitingly and kind of the place up close. And then we tested the 3 inches with a 2x4 and convinced ourselves that the shadows could work. And these are some images of some of those mock-ups. The team out in Adelanto are incredibly rigorous and have a very high control process of producing these, and indeed have taken over most of their yard out in the desert to accommodate this project. We also decided that the bottom 2 stories would have a slightly different shade of precast to kind of ground the building and kind of also divide up the bulk and height. These have just started going in. It is frightening how fast they come together. I think they're doing a building every couple weeks at this pace. And these are some images from last week of that wall going up, which we're really excited about. So these 3 projects, my studio and myself would submit, are obviously very different in nature. They're from different parts of the country, but we think that they all embrace a kind of modesty of means and a restraint, both in palette and in solving problems with the grammar that you invent for a project. And restraint is important to us. It's not the whole story, restraint. It was my own personal path into a story and an embrace about sustainability as it relates to architecture. But it's maybe also a timeless way for humans to design things beautifully, and one that points towards a much more sustainable future. Thank you.
Well, like what people are thinking, I mean, I just want to commend you on the sort of thoughtfulness and sort of, being a technical guy myself, there's no slouching as far as the detailing there. I mean, you notice a lot of the continuous insulation and the breaks that you guys are performing, even on this exposed structure building. Were there challenges? I mean, there were kind of surprises, I guess, on some of the other projects that you talked about, the limitations of the constraints of the depth on the one project. And were there other things that you kind of, it sounded like, the cast in place was a daunting thing. And were there, what were some of the things that came up?
I think the cast in place at 1245, the goal, and you probably saw it in that detail, some edge detail of the building has to insulate between the kind of structure and then fascia. And so there are parts of it that you actually do get a kind of doubling up of concrete, is our sad truth to that. In other climates, that may not have been the case. And there's actually a lot of that building that didn't have to do that as well. But that was a kind of, it's an experiment. And I think we learned a bit from that. And our client, frankly, loves the building. And it's been a great success, and he said he would never do it again.
Yeah. Well, even as you break that and actually have a cladding piece, right? Like the intention is very, very much about the structure.
Yeah.
So that's great. Yeah.
Thank you.
Well, thank you so much. All right. So thanks so much, Olin. We have next Joseph Schettino, who's the Assistant VP Building Enclosures Department Head in Los Angeles for the sports as well as sports venue leader at WSP. And his presentation is Achieving Reliable Facade Performance Through Detailing, Testing, and Installation Verification, an Enclosure Consultant's Perspective.
Hey everyone, how's everyone doing? Full after lunch. Excellent storytelling on the last presentation. Mine's a little bit different, that has more of an emotional appeal. This is kind of the process and technical appeal that the enclosure consultant might bring to the table. So I want to start, again, I'm Joe Schettino. I'm the department head for our building enclosures group for WSP, based out of Los Angeles. And we have a group here. We're in San Francisco and Irvine, and we've got groups across the country as well. And what I want to bring to the table here in this presentation is I want to talk about really what this presentation is not. It's not a checklist. We're not rewriting specifications, and I don't want to claim that I've solved all the issues with facades. But I do want to talk about how facades can succeed and fail in the real world, and a few deliberate steps that can be taken throughout the process, whether we're starting at analysis of a building site, all the way through the detailing, obviously, testing, and visual verification. So my perspective today is from the enclosure consultant's perspective. I'm not a facade designer. I want to leave that to folks like SOM and others, but we do want to inform, we do want to help, and we do want to guide. And so we want to try and keep performance intact from concept through installation. So let's see if we can. So we can talk about why facades still fail. I think there's a lot of high expectations. There's complex interfaces, multiple delivery methods, and of course the fragmented responsibility through all the team members. Most facades, they don't fail because teams don't care. I've never been on a project that said, let's design a facade that leaks, or let's not, that's silly, right? But I have been on lots of projects where intent, the construction reality, and verification, they never fully connect. There's plenty of factors. I mean, cost is a huge one too, but just the teamwork, the coordination is such a huge piece to that success. And so, and over time we see the same patterns repeat. And it's not necessarily a material failure. Obviously, there's tons of vendors here with great materials, great products. They've internally tested them. They've had testing agencies, and so we do expect those to function. I think it's the interfaces. It's kind of that verification on top of testing that I think really informs making a successful facade continue to work. Again, key message here: we want to talk about design. We want to talk about testing. We want to talk about verifying. This is just a pretty standard process. It's easy to remember, easy to repeat, and we want to make sure that it carries throughout our process. And so the first thing we really want to dive into is analysis and detailing, and of course coordination. So in analysis and detailing, we want to understand how performance intent becomes a buildable solution. We want to review the mock-ups. We want to look at testing. We want to see what tests are going to allow these facades to perform well. It's really where assumptions meet reality. And third, installation verification. The best detail in reality still needs to be looked at. We're looking at 3D objects. We're looking at movements. We're looking at a lot of factors that come to play, and how can we test and verify, and how can we be on site to observe that installation in person. And not only that, how do we effectively communicate what we've seen and ensure that the recommended solutions are carried out. So now, before performance and detailing, performance starts really before detailing with analysis. And this is something I'm not going to dive too much into, but I think there's a lot of factors at play when it comes to how an environment can affect a facade can influence and shape the way that a building responds. We've got climate exposure, geometry and different interfaces, of course, system selection, as we talked about, and then the continuity of control layers. And so here, and I'm not sure if this is going to play, but we've got obviously windrows. You've seen these before. These are kind of our pre-design programming processes that designers go through to understand how our buildings are going to work in a climate. Some additional factors like a rain simulation. And this could be a facade, this can be a roof, but how do we look at the way that rain can accumulate on a facade? And it's something that enhances the building and the performance. And so this is, again, kind of a model that can determine that. And then you can see how you take that model and you can work through different iterations and shapes to create something that's not going to inherently be a problem through design, and kind of solve that before you get to the physical testing. Let's go. And as we move on, we do go into detailing, right? And we want to talk about understanding the building. One of the first things we look at, obviously, this is a designer or architect's intent. We want to understand what this building's going to do. Sometimes you can't get the full view of a building through plans, elevations, sections, and so renderings are super helpful. They're very valuable to see the ins and outs of the walls, and they're not just technical, but we can see those complexities, setbacks, corners, fins, projections, the things that make a building interesting. Those are where the complexities create problems as well. So we want to be able to really get an idea of what the architect is trying to convey in a building through those. And so moving through that, we'll take the next step, which would be the plans, elevations, sections, things that we typically look at to understand. Again, those geometries, one level deeper, coming up with a legend, which would come up with wall types. We don't want to leave any behind, and make sure that we can tell a story about what this facade's going to look like from start to finish. We move into beyond the aesthetics. So these are some of those details that we really want to look at. We want to make sure the continuity is there between air, vapor sealing, water management, and thermal continuity. And facade systems, they don't fail in isolation. So looking at a single detail is difficult to do again. So one thing we also like to do is look at those 3D models. We like to even rebuild them, tabletop mock-ups, things like that can really help us understand what this unique condition might do and how it can fail. I almost want to create a failure or create a way it can fail so that you can solve that. So detailing is not just about the pretty drawings, but we can all appreciate those. I think it's about where the performance intent can survive, again, from something that's put on a page to something that's constructed in in a lab or in the field. We look at some annotated details. Again, this is something that's pretty typical as a consultant. You get a lot of these. When we review the details, we want to start broadly and then we get very focused. So this is a little bit more of a focused still detail. How can we isolate those control layers? What can we communicate that needs to be resolved for the architect to now create a detail that's going to be that's not going to allow those control layers to have gaps. Again, I'm not diving too much into what we look at and what we do and what we talk about technically, just more about process and show some of what we go through, in that middle detailing stage. Again, this is probably my most text-heavy, boring slide, but it's really important to understand, again, that process that we have not only typical walls and things that come from a factory, come from a manufacturer, but we have non-typical walls, we've got features and we've got interfaces. And I think, again, the features and the interfaces that add complexity, that's where we want to spend the dedicated time. After we resolve the big picture items, we want to really focus on how a vertical fin or a penetration, where is that penetration going to be placed? And is that going to be allowing moisture and water to enter into a space that it can't get out? So I think performance is earned in dealing with the complexity. So once we resolve those typical wall sections and even some of the non-typicals, we want to focus on the features and the interfaces that make buildings unique and interesting. So we jump into mock-ups and testing. You know, we're big proponents of mock-ups. Not every project has a budget for it, but certainly a project like this. The project here is UCI Medical Center in Irvine, a project we worked on with co-architects. And you can see this was at a lab. And what it really captures here is how we think about mock-ups. And so you can see we've got different interfaces. This is not at full scale. We want to be able to look visually. So, you know, it's a visual mock-up, but we also want to make it perform. And being able to go to a great testing group to have the apparatus that they have here and be able to put it to the test, try to create a failure. And I think those are where the successes, again, from performance will come out of. As we talked about, allowing us to see those assemblies, how they're going to behave, and help us validate the detailing, confirm the constructability, create a process that goes from page to, workmanship. Someone is physically going to be out there putting this together. They might be having a bad day. You know, they're people. Everyone's people. So we want to make sure that that process is followed, but we also understand where workmanship failures can happen and occur, and again, with that, the next third phase of this process we talk about is that verification, that review of what's on site. So this is a really good opportunity to be able to see these mock-ups, to see what we're constructing, to try and create a failure and create some success from that. Some typical tests, again, I'm not going to go through all of them, but we'll have air tests, air leakage testing, ASTM 283, and we actually do the water penetration testing, E331. We also have some other tests which we'll go into on some of our other projects. So this is just... Can never get enough of being out on site and watching what they're able to do at these labs and these facilities. Let's see here. So this one is interesting, and you might ask what that is. That's a propeller and an engine from an airplane. But again, that's how they're able to get enough wind speed and power to really function and create some potential failures in a building. Again, this is what's showing the performance mock-up in what it would look like in a lab. We have here, oh, let's go. What we want to talk about here is obviously the not just the thing that sticks out, which is that incredible propeller on the prop there, but it's a mindset. It's a mindset of, again, creating an opportunity for failure, which would bring success. This combined curtain wall system with a prefabricated rain screen and multiple other systems, multiple interfaces, all tested together as one. We observed the testing in the controlled lab environment where the system could be pushed, observed, repaired, retested. And so some of the tests that were conducted here down at the bottom. Now, unfortunately and fortunately, as we talked about, we do get leaks. And so it was kind of funny. You could see that photo up on the top right there. third time's a charm, but then you also see someone wrote seventh time is a charm. This was at the facility. Someone wrote it on one of the steel members that you can anchor your facade to. And I think that's what's important. It's, you go from the page, you go to what's in the field, you create something, you understand that, again, hey, someone put a fastener in the wrong place. Where's that fastener? Let's find it. Let's observe. How can we place that in a different, we're just not going to dab sealant over top. Sealant lasts for a short period of time. How can we create something that systematically will function without kind of a solution that is not going to produce something that has longevity in our lifetime and the lifespan of a building. We want to create something that's long lasting. So we're not just going to add sealant over top. We want to create something that's inherently a success. But I did find that one image pretty funny there. So now we want to jump into verification. So one thing we talk about is being on site, and I think it's incredibly important to understand what you're looking at, and be a part of that. So you're there during the mock-ups, you're there creating solutions and retesting and looking at those passes instead of a failed mock-up that has to then go into construction because of schedule. You want something that's going to pass, that you can get now on site, start putting on a building, and then eventually we'll go through testing again. But verification that we've created a new process. We've stepped it up from just shop drawings to, hey, the new protocol is going to be adding a fastener here, putting this fin in place prior to the subsequent panel below or above. And so again, sequencing changes, and then making sure our installer variability is limited. We want to make sure that we've got consistent installation techniques that have been fine-tuned in that mock-up process. But again, we have a first install that sort of in a way becomes a in situ mock-up that we can observe visually. We can start to see performance. We can start to see how that glazing, is it going to have any glare issues? It's going to have any ins and outs and bending, and are those glazing panels still going to function as they're intended? Effective observations. So this is, again, important. How do you communicate what you're observing to your client, which might be, in our case, an architect, and how can you then explain that? How can you accompany them and support them to explain it to a contractor who feels that they've installed everything perfectly to the drawings, and say, well, things have to be modified occasionally. And so this is a kind of a mix where a panel sits down. These are prefabricated panels that mix with a on-site fabricated panel over at UCI, or sorry, this one's at City of Hope, in Duarte. This was the new cancer hospital called Hope Plaza. And it's not just the fabrication of the facade itself, but then the interface with the roofing material and your adjacent assemblies. And how do we marry it all as one? We want to make sure that continuity is consistent. But being on site, you're not going to see that in a drawing. Even in a mock-up, you can add sealant behind there and fake it, which we don't like to do. We want to make sure that it's going to function in place as intended. That design intent stays clear from start to finish, and ultimately we get a high-performing building. And so these are some on-site observations that ended up coming up with a modified detail for I would consider some great success at a building that is going to do a lot of good for humanity and as a cancer hospital. And then, of course, we've got now our in place. So after construction or during construction, but after we get to a point where the building's in relatively closed up, we want to take some sections and we want to do some additional testing, that final verification. So we've observed it, we understand that it's been installed, and to the best extent and closest extent possible to mimic that design intent and the details we've come up with. But then we want to, again, try to force a failure, put the system and the details to the test, no pun intended, and understand. And so in this condition, we don't tell them where we're going to test. There's some variability. We want to make sure that, hey, we're going to choose 5 windows and you don't know which one they are. So the contractor can't be prepared and kind of fudge it. They want to make sure all these systems that we've put in, there's some randomness to it, and you can really force their hand in creating a successful building. So bring it all together, again, design, test, verify, a pretty simple concept. But there's a lot of ways to kind of see that process out. We like to bring that to our clients, and of course, you could talk forever about the design aspect or just testing. You can have hour-long presentations on that. But I wanted to be able to cover that full process because I think the process is what's most important. So if we can fine-tune a process, we take out some of the variability that of maybe a failed component, and we can bring and add the most value to a project by fine-tuning the things on our end procedurally. So that's it. That's some key takeaways.
Thank you, Joseph.
Thank you very much.
Thank you for that presentation. I think Joseph really showed the amount of consideration that goes into detail design in a high-performance facade. And having worked with them in the past, it's no mistake that they go to that extent. And so, just introducing the next speaker now, and this is Mark Matusow, who is the regional facade sales manager at Cosentino. Okay. And his presentation is entitled Sustainable Facade Design with Ultra Compact Stone.
Perfect. Thank you. So that's what we're going to talk about today. And the goal is basically to talk about these topics. So we're going to walk a little bit about who Cosentino is. Hopefully many of you in here know who that company is. Circular economy, sustainability, what we do as a company to stay carbon neutral and basically be good to the environment. What is ultra compact stone and why is it different than other materials on the marketplace? Whoop, that was quick. And then who we are, basically. So this is our factory in southern Spain. It's in Cantoria, near Almeria, between Malaga and Barcelona. Sorry, is that me doing that? Sorry, okay. About 3.5 million square feet. Sorry about that. Geez, I'm not even touching it and it's moving, so can I go back?
We missed it.
Yeah, okay. All right, sorry about that. So this is our factory in southern Spain, 3.5 million square feet. You notice the solar plant at the factory site. It's the largest privately held solar plant in Europe, and it basically provides power for all of our production. We produce approximately 2,500 square feet of our Decton product every single day. That's the equivalent of most quarries in a year. We have 6,000 employees in 120 locations around the world. So our company is extremely large, and we have the ability to basically deliver products any place on the planet. Those kind of the key components of who Cosentino is, and then Decton. So this is a little bit about those locations. So here in the United States, we currently have 47 centers. Each of them has inventory, so you could actually come out and see a full slab at one of our centers. We also have hubs, and we have city centers close to the downtown areas, so you can get a really good feel for our product. And as you can see, we're in pretty much all of the world in terms of operations. Jeez, I'm sorry, this is not good for me. So we are a carbon neutral company, and our product Decton is carbon neutral. And what that means is sorry, I'm not touching anything, but this is magic. It's magic. And I always thought that Cosentino was magic. So hang on, I'm going to go back. Won't even let me go back. Okay, carbon neutral. So what carbon neutral is no embodied carbon. When we manufacture our Decton product, we make sure that all of the mineral components in our inorganic
product set, doesn't have any carbon in it. So it basically leads to our carbon neutral capability. And so no embedded carbon at all. And then you can, with our product, basically build any type of facade you want. Sorry, I'm touch layer, but the slides are going. So I'm not certain what to do about that. It's like, I didn't put in a cue or timing or any of that. So, okay, sorry about that, guys. I can continue on. I can talk about this product all day long. So what's unique about ducted ultra compact surface is it's all inorganic. What that means is it doesn't interact with the environment at all. So you might have UV, you might have freeze thaw, you might have a wicking of, say, fertilizer or salt in an environment. Because the material is zero porosity, nothing wicks in. And in terms of ease of maintenance, it's extremely easy to work with. How we make it is we quarry material out of the ground. It's pulverized into a fine powder. A panel is created, basically, goes along a production line. So you can see the contamination of those materials. And then we hit it with a 25,000 metric ton press. That's the equivalent of 2.5 Eiffel Towers. So we apply that amount of pressure to every panel. And what it ultimately does is it begins the process of atomic contraction in the product, and it removes all of the moisture that's in the product as well. So that literally happens every 10 seconds and allows us to be able to produce so many square feet each day. And then the next step is we're going to basically sinterize. And what that means is we're going to basically bond and cover. Sorry, guys. We're going to apply basically our finish to the panel, and then it's going to bake in a 2200 degree oven. And it's basically about 300 meters going down the line until ultimately you get a panel that, for all intents and purposes, is indestructible. And what that means is it's UV stable. We warrant it for 25 years. It's non-combustible, means NFPA 285. It doesn't propagate flame up the side of a building. It's non-porous, so in a freeze-thaw zone, it can't freeze. Therefore, it doesn't contract and expand as a product. And it's large format, so we can produce panels as large as 5 foot by 10 foot to eliminate joints and seams on your projects. Abrasion resistant, graffiti resistant, stain resistant as a product. So it's an amazing product for a facade because it kind of meets every potential failure that you could have in the field with a product that's going to basically respond back to that. And again, we're carbon neutral cradle to grave. So from a certification standpoint, we have HPTs, EPDs, Declare, pretty much anything that you might be looking at in terms of testing globally. We have North American testing, we have Asia testing, we have testing for Europe. We can provide written documentation on the product to make sure it's going to perform in the environment that you're after. And again, those are all readily available. Large format, I mentioned earlier, we can go as large as 64 by 130. Again, the opportunity there is to eliminate seams, which eliminates potential penetration of moisture into the building. And it also allows us to be able to cut more pieces if you're going to do some sort of a segmented look or stacked type look, more pieces out of the individual panels. They're extremely lightweight, so your structure of the building can be lighter in weight.
Wow, I'm really causing a problem today.
It's me. It's totally me, guys, for sure. Basically, we're like 5 pounds per square foot. So your structure building can be lighter. The saving in structure can probably pay for your facade. Color. So right now we have approximately 75 standard colors in the product line that you can pick from. They tend to lean all the way across the board from marbles to granites. A lot of products that are concrete based and look like travertine and that type of thing. So there's a whole wide selection of products that you could use for your facade. But we also have the ability to do custom colors. So we could take a pattern that you might see, a stone that you might see that is limited in supply. The quarry doesn't have the capability of producing the amount of material that you need in the time frame, and we can actually match that material. And it allows you to be able to use our product basically to kind of sustain that construction. We also have the ability to print interesting patterns and designs on the material. So if you want to have something that's very unique and different, you can print on the product. And again, we're a rain screen product, so ventilated rain screen, the advantages you're probably aware of, energy, acoustical, thermal, etc. We're a ventilated rain screen, so that's step one. We also do curtain wall, and we do a tremendous amount of direct adhere. So basically, if the building allows for you a thin set application, you can thin set this material onto the building. You do have some limits though. Typical curtain wall integration, so give you some idea what that looks like. And then here's an Appel project in Munich, Germany that we did, which was undercut anchor in association with the curtain wall application. So these are readily available solutions. We'd like to talk about how the product performs. Many of you are aware of the fire that was in the Pacific Palisades this last year. This is a home that was built in that area prior to that fire that actually survived the fire. And that's because the decking material on the exterior of the home does not propagate flames, so it didn't burn in the fire. Now, I will tell you that the areas all around it did, and the neighbors all did. It's a project that we did in Israel, a large format project. Basically, interestingly, the bottom 7 floors is where the architect wanted all the infrastructure because they didn't want to have any sound at the higher levels. And they created this kind of X-panel look detail to exhaust the heat coming out of the infrastructure that was down on the bottom. I'll give you an example of that. Basically, project in Missouri. So this is University of Missouri. Sorry, I'm on a huge time frame. They're counting me down. Okay, Rafael Nadal Academy. This is in Minorca, in basically the middle of the Mediterranean Sea. Very difficult climate, maritime climate, high salt content. And this product is a curtain wall project that was done there as well. 7 West Street. This is what we call an overclad project. The existing limestone on the building failed after about 60 years. The customer was looking for a way to basically reclad the building, and we were able to basically take our ultra-compact surface, go over the existing stone, just attach directly to the studs. Because of its lightweight nature, the original structural design allowed the ability to be able to overclad. And in summary, we'll get close here. These are the key elements of ultra-compact material. Large format, variety of different thicknesses. The flexural strength of the product basically means if you're in Miami and we meet Miami-Dade NOA and a tree gets picked up by a hurricane and gets launched side of the building, there's enough flex within the material to allow that tree to bounce off and not damage the panel or and have it basically dislodge from the building. Freeze thaw, so if you're in a colder climate, there's no moisture to freeze, doesn't thaw, so holds up really well in a freeze thaw environment. Again, UV resistance, we warrant our product for 25 years for change of color. And then impact, graffiti resistant if you're doing buildings basically in urban corridor and you need buildings to respond back to anti-graffiti, the product is inherently that way. Never needs to be treated or retreated down the road. And then easy cleaning, it's just power wash. So you can clean it with soap and water or power wash it. And that's an unlimited design application. We tell the architectural community, if you can draw it on a napkin, we can build it. Yeah. So thank you for the time today.
Thank you, Mark. That was a nice presentation and pretty impressive sizes there. And with the lightweight capacity, you can really see the versatility of that material. So next we have our presenter from EJOT. It's Natasha Appel, and she's the business development manager there at EJOT. Her presentation is entitled Stainless Steel, Preferred Material for Rain Screen Attachment.
Thank you so much.
Good.
Well. Good afternoon, everybody. I know it's not 5 o'clock yet, but I'm going to start off with a joke. 2 brackets walk into a bar, and aluminum bracket looks around and say, "Is it hot in here?" And the stainless steel looks at him back and says, "Well, I don't know. You're the one responsible for all the thermal exchange." I'm a facade nerd. I love facades. I've been in facade industry for quite some time, so hopefully you guys would find it not so boring. But today we're going to talk about preferred material for rain screen applications, and it's ventilated facades with stainless steels. Today I want to walk through a couple of very important things. What the rain screen attachment system really does, how it controls performance, and how many different material choices that you have and what is going to essentially affect your system. The topics tend to be very interesting in this, and just to kind of start you up with who we are,
EJOT has been around for a very long time. We're about a 100-year-old company with a global presence, thousands of patents, hundreds and thousands of people. But that's not really an interesting part. What is interesting about this is we focus on connections. And I don't mean just connections between people, but connections with all the components and parts of the facade design. Because when something goes wrong in a facade application, it is rarely the panel, it is rarely the aluminum subframe, it is rarely a frame. Most usually it's the smallest element that's first going to cause failure. And when they fail, those performances are very public and very obvious. And by that time, there's nothing you can do at this point. And every facade project has this moment when somebody says, the subframe, it's standard, right? And that is usually the moment when the real problems begin, because everybody expects somebody else to be responsible for this. So today, let's talk about what the standard is. And the rain screen systems are, your subframe is very deceptively simple. As you guys can see it on the screen, we have all the different components from screws to brackets to rails to panels. But it's responsible for a lot of different things. It's responsible for the transfers of loads. It creates the air gaps. It allows adjustability. Sorry? Did I switch? Sorry? But it also does something much bigger, much complex. It's allowed for the system to move while remaining static. It's a system that needs to be corrosion resistant. It's a system that needs to be non-combustible. It creates a lot of different parts and points that are very essential for health, safety, and welfare of the people. And the system controls structural performance, fire behavior, thermal efficiency, durability, and sustainability. So this is not a background component. It is one of the elements that's going to be responsible if your facade performs or if it fails. And what's interesting about facade design specifically is this is one thing that everybody in the industry agrees, from the architects and the engineers and installers. They all agree on one thing, that subframing is somebody else's responsibility. So when we talk about facades, there are a lot of different things, and the most smallest things are usually the ones responsible for the biggest failure. We want to make sure that our facades not just pretty, not just able to accommodate an ease of installation, but they actually do what they're supposed to do. They transfer the dead load, they transfer wind loads into the structural system. They allow us to withstand seismic activity. They are resistant to fire, and so on. And speaking of fire, fire has a very interesting thing. It can reveal a poor decision very quickly. And ventilated facade creates a chimney effect. And as you probably have heard many presentations today, that chimney effect is responsible for fire spread in the building. And the fire doesn't spread very slowly. It spreads quite fast. We have 8 meters per minute. If anybody is not familiar with metric, it's 24 seconds per a foot, so it's quite a lot. So how do we deal with the fires? Well, there's a lot of different things, but how do we prevent catastrophes? Following building codes. There's a lot of building codes specifically deals with the system, not just materials. If you have individual rating for different materials, it is not going to guarantee that you have a system that's going to withstand fire. And this matters because facades are not isolated. It is responsible for a lot of different things within the building. So when we're talking about resistance to fire, aluminum begins to fail at about 1200 degrees Fahrenheit. Stainless steel begins failing at 2600 degrees Fahrenheit. And we're not talking about just the melting point. Those are the points at which material will melt. Your facade is going to start failing way before your aluminum is melted, way before your stainless steel is melted. We want to make sure that when you design in a project, when the brackets, all the components are spaced properly, they hold material in place. We want to make sure that all of those pieces and parts are not going to start failing one after another. And again, if you think about what fails the quickest, the fast, is those small connections, small little anchors, small little screws that are holding it all together. Let's talk about energy. That's another one thing that's everybody always concerned about. It is less dramatic as fire, but it is nevertheless more expensive problem to have because every bracket is a thermal bridge. And when we think about just one individual bracket, it doesn't seem like a lot of energy can go through it. But imagine hundreds or thousands of brackets on the same build, and each of those is losing your thermal energy every day for the rest of the building life. When we talk about stainless steel, even without the thermal pad that everybody loves to see on every bracket, stainless steel has a 15 times less thermal transfer than aluminum. Even with the best pad, aluminum is not going to do the same job as the stainless steel. If we're looking at carbon steel is 3 times more able to convey this energy. So again, my joke about 2 brackets in the bar does seem appropriate now, doesn't it? The other great thing is, unfortunately, we do not build facades inside of the buildings. When they are outside of the buildings, they're supposed to do what they're intended for. They're supposed to prevent building from all of the active elements from the outside getting inside. And that usually comes with moisture. Moisture, condensation, pollution, salt, and all of the smallest elements are typically going to be responsible for being affected by that. By the time corrosion is visible, it's already too late. The systems are typically concealed, they're typically in the difficult places to see, so by the time somebody notices it, your building is already failing. So having a proper material that is specifically designed for those heavy applications, marine application, chemical proximities, is very important.
Wow.
So why stainless steel? Well, one of the biggest things, it's corrosion resistant. It has a very low maintenance. It has a very long history. It's been used in architecture for over 80 years. And the other thing that stainless steel has one ingredient that nothing else does. It has a chromium oxide inside as a part of the mixture for stainless steel. And that layer essentially provides self-healing properties, which makes it very different than material that is powder-coated or finished in any ways, because it is a part of the material. So what happens to the material when it's scraped, when it's scratched? It self-heals. It does not spread this corrosion further. Sustainability is probably our hottest topic in the last 15 years. And sustainability is no longer an optional. Construction industry responsible for about 39% of the global emission. So here the question is, what lasts and what does needs replacement? Long life and sustainability usually not always considered together. We're looking at the materials typically from the standpoint, are they recyclable? Do they have recycled content? But we're not looking from the standpoint of how often those materials need to be replaced. And the stainless steel is one of the materials that does not need to be replaced very often. So increasingly, we evaluate materials not just on their initial impact, but on the lifestyle and the lifetime performance. When it comes to stainless steel, it can contribute in several ways. One of the biggest things is 100% recycled material. And what's more importantly, it has a very high recovery rate, because we know the aluminums are just as any other metals. They are very recyclable, but not always they have the 1-to-1 ratio when they are recycled, when they are melted and produced in something else. Stainless steel is one of them. Chromium is the other one. We don't build with chromium, so it only leaves you guys with the stainless steel. It also requires very minimal maintenance, and it has a better performance as a part of the material performance itself, which means lower operational costs, not just sustainable material, but sustainable lifestyle. So one of the key advantages in efficiency over time, its performance does not degrade rapidly, which reduces the need for replacement. It makes us compete with the material that are highly recyclable, recycled content, but this is the material that's really is as sustainable as any material can get. So to step back to the attachment system, the systems may be invisible, but it really defines the performance of your building. It defines fire resistance, energy performance, longevity, environmental impact. And stainless steel is simply one of the material choices that covers all of those. And well, parts of it may be hidden. It is the most influential component of the facades. So going back to the ideal standard, maybe we should reconsider this and not use this word so freely when it comes to standard applications. Because buildings are judged not on the way they look on the day first. They judged on how well they perform, how long they last, and do they actually do what they intend to be. And the attachment system, well, that's one part that nobody ever sees. Because nobody notices the bracket until it's too late. And typically by then it's way too late to VE. Thank you guys so much for your time.
Thank you, Natasha. That was really enlightening sort of arguments for stainless steel. I think there was a time when, you would only be able to specify those stainless steel fittings if you had a really aggressive, sort of corrosive environment, or there was some high desire for durability at the highest quality, and just all those arguments as far as performance and longevity, I think are a good thing to consider in the future. So our last presenter for this session is Jan Krymsky. He's the principal and design director at the US West Stantec, and his presentation is Facade as Frieze, Buildings That Tell a Story.
Good afternoon. As he said, my name is Jan Krymsky. I am the design director for Stantec, US West. I want to talk to you today about facades that tell a story. Where's my clicker? Here we go. So these are some of the projects that I've worked on over the last 15 years. A lot of the big steel and glass projects, so very much a story about buildings that really responded to performance. So this is with Yazdani Studio of Canada Design. This is CJ Research and Development Center in Korea. And then in the middle there, we have the address. And these are apartments and a hotel in Dubai. And then 1811 Sacramento Street in downtown Los Angeles. And so it's really this sort of evolution of these building facades, which on the left-hand side, you have CJ really responds to building performance and comfort. In the middle, you're starting to see something that resembles more of the program inside. It's being programmatically driven. By the way, we have the PA in the audience here. I was thrilled to see Sal Hidalgo here. So he's here with us. And then on the far right, we get into a point where the building scrim is actually telling a story. It's talking about downtown Los Angeles and its sort of rail history. And so the idea of rail yards is really being picked up in the way that these fins, which are also there for performance, start to be articulated. And that idea is something I'm really interested in, is can facade do more than just perform and create a comfortable space for the occupants? Can it tell something about the people, the communities, or the owners of those buildings? Can it speak to that? So I wanted to talk to you about a project called Corazon del Valle. This is permanent supportive housing in San Fernando Valley. I thought this was an interesting case study because unlike those other buildings, it doesn't have the big team of engineers. It doesn't have the facade specialist. It doesn't have Zahner doing pre-con and the design assist. It's more the projects that we do every day. But I think it's also an interesting evolution of this technology and the process and how we transfer the knowledge we get on those other projects onto some of the work that is so important to these communities. So before I go on, this is a great team of people. We had a wonderful owner in Holos Communities. We actually have Christian Amuda here, who leads Holos Communities. It tells you how much he loves what he does and that he's willing to attend the Facades conference for us. So awesome to have him here, along with a bunch of other great partners. So the project is located in the San Fernando Valley. For those of you that are from out of town, that's over there. This is a diagram of the weather in the region. I actually grew up a little bit in the valley, so it's pretty accurate. It's hot there. It's very, very hot. And so we're dealing with climate. We're talking about creating space for people in a place that has those kind of challenges. This is the site. This is located near San Fernando High, Panorama High, if you're familiar with the area. It's Lanark and Van Nuys Boulevard. It's a county-owned site, county-owned building. So it's that sort of beige building there. It's an unusually large site, 300 by 300. So that gives us quite a bit of flexibility to sort of shape these buildings and create more of a campus. And so that's actually exactly what we started talking about. If we're talking about architecture that tells a story, the story we're trying to tell is, it starts with like the wonderful 20s, 30s, and 40s courtyard apartments of Los Angeles that are so wonderful in terms of the way that they individualize people there. Every entry is special. The gardens are really special. It's so different from a lot of the high density housing that we have now, which is sort of about uniformity. So we started thinking about those outdoor spaces, and we started thinking about individuality. And that was also something that we noticed as we moved from, the luxury apartments we were doing in Dubai to housing in LA, which was the conversation shifts from, how do I customize something? How do I make it personal? How do I tailor it for how do I anticipate someone's needs, to how much does it cost? How fast can I build it? How many beds are there? And so we wanted to have all of that be part of the conversation. And so that was really the story that we started thinking about, is how do we create these garden apartments? How do we create individualized, personalized entries? And so really it was a study of these courtyards. And should we do big ones? Should we do a bunch of little ones? Should we do ones that open to the street and pull people in? Should we do a bunch of clusters of little ones that are all connected? But we really got interested in this one on the bottom right, your left, which is this idea of the canyon. And the reason for that was obviously the climate. And we were we became enamored with this idea of passively conditioning the community outdoor space just by the way that we shape the buildings. So taking from the kind of slot canyons, and also just giving credit where credit's due. I had visited this project right at the beginning of the one we were working on. It's the Environment and Natural Resources at the University of Arizona by Richard Kennedy. Obviously it's a beautiful building, but I was really impressed by how well it performed. It was just incredibly effective at cooling its space. It was like several degrees cooler than everywhere else on campus. It was shady, it was breezy, the evaporative cooling was working, and it left an impression on me that you could create this kind of passively cooled outdoor community space with lush gardens, and those are the things that kind of inspired us. So we started with this collection of smaller buildings. Again, it's a 300 by 300 site, so this is much bigger than you get for typical permanent supportive housing. This is actually 2 projects. It had to be funded that way to be able to build the project. So phase 1 and phase 2 are left and right. And so we started to develop the concept. We worked with the community. I'm still sort of infatuated with the colors. I keep it in my presentations, even though it's an all-white building. But we tried. And then, this sort of idea of this really lush landscape that's somehow integrated with the facade. It's really part of the design, and you'll see how we did that in a moment. And then the other thing is this idea of breezes. And we've seen a bunch of windrows. We really got into this, and how can we potentially accelerate breezes to truly cool that space, to make it like a couple of degrees cooler on the hottest days. And so we actually had pretty good weather data because there's an airport nearby, and it was about the same altitude. It was about 10 miles away. So pretty reliable weather data. We have prevailing breezes coming from the southeast. And this, by the way, we're just filtering for the hot days. We're not just giving you the full year. But you can see that as we started to do some CFD analysis, that the building form was making those breezes go faster, right at the mouth of the building. And I admit, some of that was luck. We had a lot of things driving the design, but we could see that with our concept, there's a lot of potential for it. And as we went through multiple iterations on the project, the final being the fire department asked us to add a fire lane, which changed the project significantly. But as we had to make those changes, and so that's phase 2 there on your right. That went from a type 5 to a type 3. We added a story. We actually shaped it and created more of an intentional funnel to get those breezes to more actively cool that space. And the thing I would say now, looking back on it, going back, is that we don't just want to make wind go faster. Actually, what we want to do is create options for people, because outdoor environments are ones where people are actively engaged in controlling their climate, right? If the sun hits you and you're sitting on a bench, you scooch over and you stay in the shade, right? That's something we don't even think about. And so the best thing we can do for outdoor spaces is create options. And so when I see this diagram now, I see a place where it's breezy and I see a place where it's not. And so I have options. I have places to go on a hot day. I have places where I can go on a day where maybe it's windy and I don't want to stand in the breeze. So here's the part that connects to the projects I showed at the beginning. Is this sort of a way of working using Grasshopper and using scripting. We built a lot of tools to facilitate the challenge of getting our unit mix and incorporating that within the tight constraints of unit mix and state funding. But hey, we're making these potato-shaped buildings. So how do we do those things and have them informed by what we will know later, what we will have to figure out, which is how do we accommodate all those different factors. So this is a simple tool where we're just adjusting curves, and those curves will tell us, yes, you're hitting your unit mix. No, you're not hitting your unit mix. So it's basically a guide for us to sculpt. We built another tool. It's just there on your bottom right, and that is the thing that translates our splines into tangential arcs. So if you're an architect, you know that if you're documenting old school, you need tangential arcs. So that was just a tool to do that. And then that produced our template. And so our template brought that into Revit. We planned it and developed it as usual. And the other thing we were doing simultaneously was developing the facade. And you can see that there's this kind of vertical vines that run with the facade. And that isn't after the fact, or that actually wasn't even part of the landscape package. It was part of the architectural package. So we very much were thinking about how to make this landscape feel really lush and integrated into the architecture. So the concept here is that the windows actually slide from one end of the room to the other. That's, again, creating that variation, non-uniformity, but also integrating those vines and using them as vertical shades. So the vine trainers, they're doing that. The entire building envelope, the shell, is scripted in Grasshopper and we were using Convenor at the time. So that was brought into Revit as native components. And this one stayed that way all the way through CDs. So it was not built in Revit. It was built in Grasshopper. And that enabled some of these plan evolutions that you see where the building went from 4 to 3, and then we had a tall one. All of that is being facilitated by our process. And then you can kind of see how we build simple tools like we move these circles around, and then that tells the script, here's where the living rooms are. And then that generates the building envelope. So again, we're trying to create this kind of environment, which is all about this garden landscape at the center, where it feels like the architecture and the landscape is completely integrated. You can't see where one stops and one ends. And that's not the only thing that we did. Holos is super committed to sustainability in all of their projects. So we have 288 solar panels on the roof. That's what we were able to fit. That's about 22% of demand. 333 kilowatts of on-site battery storage, which is fantastic. We are recycling 72,000 gallons of water. That's mostly the washing machine. And that feeds all of the landscape. And then 24 trees planted. So the building's old enough now where it's on Google Earth, which is great for presentations. You can grab an aerial whenever you want. You can see it there and the way that it relates to the street and the high school across the street. No special tricks. This is a type 5 stick-built building. And the other side is type 3, but also sticks. And that actually gives it some flexibility because, there isn't an inherent cost in doing that. You're just organizing the sticks in a different way. And we couldn't put shear wall on the outside of the building. It actually happens on the inside because of the way that we staggered the windows. But essentially what they did was the surveyor just mapped out points and they generated the curves from them. In phase 1 of the project, they asked us for traditional architectural drawings where we actually called out radiuses. We dimensioned the curves. By the time they got to phase 2, They didn't want those. They just wanted the CAD files. So I thought that was interesting because we're talking about a residential contractor, albeit a larger residential contractor, but they're with it, right? This isn't something that threw them for a loop. They were able to really run with this and then produce this kind of sculptural outcome. So this is what it feels like as you fly through. On the bottom right, you have the San Fernando Clinic. They're not moved in yet at the time that we did this photography, but they'll be there on the bottom right. On the bottom left, you have the counseling offices. There's the front entry, so you enter into a sort of a courtyard that takes you up. The rest of that level is all parking, one level of parking above grade. And then it takes you up to our garden level. And, obviously the plants are babies here. They just got planted. Like when we're doing the photography, they're like 2 or 3 months old during a heat wave. So they were really struggling. That's Nathan coming in on cue. He did CA for us. All the orange spaces on that ground floor are the community spaces. So you have the community rooms left and right, and you have laundry rooms beyond. So these are the activators for our community garden. And you can kind of see the canyon-like environment that this creates. The community loves it. There's some people I see every time I visit. They're out there hassling me about stuff. But the ones that complain the most are always in the garden, so they must like it. This is the entry, and just walking up the stair as you come in. This is kind of the floor plate, and you can see what I was talking about there with all the orange spaces. Those are all the community spaces that activate that ground level. The vines are growing fast. Last time I was there, they were up to the first floor. I don't know if they're going even faster than that now. It was quite a while ago. So they'll have those elements. Obviously, a big part of this idea is the landscape. So can't wait to go back and reshoot it with all of that in there. These are the connections into the interior courts, and then those interior courts are where all the entries are. So again, that idea of that corridor of undifferentiated entries, we're trying to get away from that and give people that identity that you have from having this kind of more unique geometries. And that's the story we're trying to tell. It's not as concise as maybe like a nature metaphor. It's not really so much about the canyon as it is about individuality. And emphasis on these different individuals and families. So this is another shot, and actually those bridges take you to someone's door. So I'm jealous of those. I've always wanted a bridge to my door. And then you have the outdoor play areas on the roof. And this is an example of one of those. So lots of options for outdoor spaces. Some images of the exteriors. Every unit on a floor is different. So that was a lot of planning and a lot of extra effort that it took to do that. But again, it was something that we were committed to. That's the story that we were trying to tell here. View of the other images, and then that courtyard space. And then this is what the building looks like from the exterior. So this is 180 units. 90 of them are family housing. So that's 2 bedrooms and 3 bedrooms. And the other 90 are permanent supportive housing. So these are studios and 1-bedroom apartments for people that are either currently homeless or coming in from interim housing, and they're coming in and they're being housed. So that's something that Holos is really committed to doing, which is mixing and not creating sort of pockets of concentrations of people who are all homeless. And so this building does that in a really awesome way. The next project I want to talk to you about, and this is my second project, is a building in Watts. It's called Kaiser Watts. It's the Kaiser Permanente Medical Offices and the Counseling Center. So this is the team. This is another Perkins & Will project with Swinnerton as the builders. And what I really want to talk to you about, I'm not going to talk much about the whole project. I want to talk to you about this mural. Because it was this funny moment where Swinnerton said, this is during construction, they said, look, you guys, we don't have a specialty person who's going to come do this mural for you. Like, we're building this like a regular building. You need to show us in the drawings where you want every single tile. So that was quite different than what we had imagined, which was we give them a lovely piece of art and then they figure it out from there. So I want to show you how we did that and the process that we took. A little bit about the project. It is this wonderful counseling and learning center that's been there since just after the Watts civil unrest, so since the late 60s. It was established by Kaiser for the community, and they are being joined by medical offices from a nearby group. So these are doctors and counselors coming together for total community health on site. And that's where the building design comes from. It's a celebration of this coming together. As we got to know them as clients and we're walking through their hallways, there was this picture that you see on your left. It was a framed painting on one of the walls. And I asked them about it. I said, that looks like a Rose Parade float. And I said, yeah, that's from the 2016 Rose Parade. That was our float. I said, well, very cool. Can you tell me about that farmer's market stand in the middle of it? And they said, well, we're really proud of the fact that in like 2007, 2008, when Watts was this notorious food desert, we had the first farmer's market in Watts. And so we brought fresh produce to the neighborhood. And that's just a story that we're so proud of. We want to tell that story. So when we were designing the building, we thought, well, maybe we can help you tell that story. And so we did some research into who are the residents of Watts over the past couple of 100 years, and what is the food that they're cooking with. What are the ingredients in their recipes? Because the idea was that food brings people together. So using that as a narrative, Sia, who was the designer on the project and created this piece of art, after finding out which of the ingredients we wanted to work with, went to the grocery store, bought a bunch of fruit and vegetables, chopped them in half, and took these pictures and created the icons on the right. We went through a design process with the client and started to generate and create this mural. And so this is the point. One more thing. We also wanted it to connect to the Watts towers. And so the Watts towers, if you're there, when you get up close to them, it's all mosaic, and it's found mosaic. It's this really kind of rough mosaic. So we wanted it to connect to that too. So it wasn't just a digital print on tile. It is really this idea about creating something so not like this, but more like this, where we are creating these islands of tiles. And that was important to us. So something that we had specified in our drawings is we want it to be like this, and here's the artwork. Please help us figure it out. So then, as I said, Swinnerton came back to us and said, no, we're not going to figure it out for you. You guys have to tell us exactly how to make it. And by the way, here's the dollar per square foot of what it's going to cost. So you can use Dow tile, and you can use colors from their Group A, and you can use some of the colors from Group B, but only 20%. And that's your budget. So that's a really tightly constrained problem that, thank God, we had our computational tools, because we went about it just like we do a giant facade, where every single tile was it had a dollar value and it had a color value, and we did our best to simulate or create the artwork. And it's it's the reason why the avocado is blue, actually, but you don't really notice that because of the way that we've adjusted the colors. So this is actually the set of drawings that we produced for them and that they were able to build a mural off of. We're extremely proud of it. The counseling center has a preschool, so this is the facade that faces the preschool. It also is the facade that faces their civic plaza. So it has this really civic feel to it. It is nothing very technical. It was more about just managing the complexity. That was the thing that got us over the hump, and we were able to pull this off. And I just want to be clear, we're not against art, public art. There's a beautiful mural on the north side of the building that's by community artists. It was orchestrated by the Watts Towers group, and then there's all kinds of great art on the inside that there's a curator for. This piece was architectural. It was part of the facade design, and so it's funny because it became so figural because of the storytelling. But we would always thought about this as a finish, not necessarily as this mural. So it sort of lives in this sort of gray area, and it's this gray area that I'm very interested in terms of facade development. So again, my name is Jan Krymsky. I'm with Stantec. That's my info. Reach out on LinkedIn if you want to. I will say one more thing as I part, which is I'm showing you a lot of scripting, a lot of stuff that was cool 5 years ago, but maybe isn't the hot topic anymore. I actually think that AI makes this even more interesting, because now you can have the AI build the script for you. It makes this even more accessible to more people. So I think that as the parts of buildings get more sophisticated, and as our means of managing all of that complexity becomes more sophisticated. We have the ability to start to tell really rich stories about the people and the places and the communities where we build these projects. So thanks again.
If we have a few minutes, if we got some questions from the audience on these lovely projects. I mean, I greatly impressed by sort of the process and sort of using the construction methods to really express some of these solutions. And my curiosity is with the space that you did in the valley. That's a mixed housing sort of thing. Did the curtains of the vines, did those come into play, maybe buffering some of the wind that like kind of accelerated through there maybe?
We were thinking about those as vertical shades. So, and actually the building department was like, you guys got to have shades because it's one of the, I don't know if it's our fault, energy, right? But it was written into some of our funding requirements that we'd like you to have shades on all your windows. And we said, well, you say like, you don't say have to. And so we're using these vines as shades. And they said, fine. The next time I read that code, it said, you shall have shades. So it's been changed. It's been amended. I don't know if it's all our fault, but they were performance-based. There was a question out there. Yeah.
Housing project. And I think that simple listening or she would find it more.
No, I would do exactly the same. I mean, that's our process for most projects, especially with that level of complexity. Because of what I said, they change. They change so much. You'd love for architecture to be linear. Sometimes it can be, but in many times it's just not a linear process. You get information later on. You have a bad review. The fire marshal has a bad day, and you get some bad news. And so how do you adapt to that, especially when you have a building that's non-repetitive and non-linear? Unless you have a good way of doing that, you're gonna over-rationalize it. So I would absolutely go that way.
Okay. Thank you so much.
Thanks.
Cheers. Okay. Yeah, so this is the last presentation for this session. We have a little networking, tea, and coffee break now. And so if I could just get all the speakers again to come up front and take a last photo for this session. Thank you.
That is great.
Okay, everybody, we're going to start the last session here. And our presenters now are Maya White-Turre, Senior Associate at Gruen Associates, and Isabelle Paparo, who's a Senior Engineer at Arab. And their presentation is entitled LAX Metro Transit Center Facades.
So most of you have probably heard of this project if you're from Los Angeles, but you'll hopefully learn something new about it. LAX Metro Transit Center began the design process in about 2016, 2017, started construction in 2020 and opened in 2025. But really it's the manifestation of decades of urban planning and about 50 years of planning by LA City, decades of planning by Metro to bring transit to LAX and sort of shift our city to a less utopian vision. It connects the Crenshaw line and Green Line and is also a multimodal transit hub. In addition, there's a bicycle hub and bus plaza with electric bus charging that helps Metro to transition to an all-electric fleet. And in addition to the bicycle hub, there's also a bicycle path, so we did a lot of street work in front of the station. It's a net carbon sink, as is the entire Metro system. And in 7.5 years, it's anticipated that the greenhouse gas diverted from the project from private transit, people taking their own automobiles, will offset the embodied carbon of the structure and the facade. So that's a really big accomplishment for a building of this size. And it's great to think of Metro as something that helps our city in general as a carbon sink.
Oh, you know what?
The project was done with Gruen, Grimshaw, Arup. Our facade subcontractors were Aragon and Enclosed. But we really looking at the site, those of you who know the airport area, it's very industrial. There's a lot of documented toxic waste sites in that area, and especially on our site in particular, there are contaminated groundwater plumes and contaminated soil. We remove the contaminated soil, and we have active soil vapor extractors that help to remediate the groundwater plume that is there. So we're helping the local air quality, but also helping the air quality of the region with the increase of public transit versus private transit. We thought of the site as sort of an oasis in this industrial landscape, and a place for travelers to decompress, but also like a local urban center for those who live there. It is in an equity-focused community where 40% of the households are low income and at least 10% don't have a private vehicle. So looking at the floor plan, on the ground floor, you can see that only about 8% of the project is actually enclosed conditioned space. It's 500,000 square feet in general, but only a small portion of that is air conditioned. There's a mezzanine level that brings travelers safely over the railway and busway down to the platform. There's also photovoltaic panels that offset half the energy use of the interior spaces, and there's a 20% additional regional energy credit that Metro purchased to further offset the electrical demands of the station. Beneath the garden spaces, there's a series of cisterns to gather stormwater and reuse it for the landscape, and we're also connected to the purple pipe LADWP recycled water line, which we brought over a few blocks. It wasn't originally planned for this project, but because our landscape would have used a lot of water, it was worthwhile to bring it over. You can see those electric bus chargers there and the bus plaza. Looking at the overall resiliency framework for the station and how it helps to benefit Los Angeles, we talked about things like the heat exposure. We talked about reducing greenhouse gas emissions, but that leads to things like improved public health, reduced cases of asthma, reduced cases of lung cancer. And when we start taking our public transportation, we know that we're less reliant on fossil fuels. We have energy independence, and high gas prices like we have right now don't affect us as much. So looking at the facade and how it sort of tied in with our overall vision of sustainability for the project, we wanted to maximize daylighting. We have a series of daylighting sensors, and we wanted to make sure that daylighting got into the project. We wanted to maximize natural ventilation because most of the project is not conditioned. We wanted to ensure thermal comfort because we do have heat exposure risk at our site, and it's the largest threat to metro system in general from a climate perspective. We wanted to ensure acoustic comfort because of the flyover of jets in the area. Make sure that the site was energy efficient, especially since Metro has so many specialty emergency systems that have a large energy demand, and we have a lot of vertical circulation for passengers with luggage. And we wanted to mitigate the urban heat island effect with our facade and with our roofing.
Thank you. And surprising, only 8% of the site is an enclosed space. We did have quite a few facade types to design. So you can see on, oh, never mind. What can I say? Oh. The metal rain screen systems, it's a perforated stainless steel rain screen. It's pretty large panels, like it's an impressive scale for the panelization. Then we had multiple kiosk storefronts done there. This is the one enclosed space. It's an IGU used there. Then we do have enclosed elevator pitches, and A large portion of the building is actually consists of a skylight assembly with a oculus in the center line, and then the main facade is actually just a glass screen with canopies that would run along the entire length of both ribbons and shelter the unconditioned interior space. And then the only more traditional facade that we actually had on the project is this single multi-story building. It's the bicup at the end of the facade, and that one is executed with a typical storefront.
Okay, so right now you're looking at the mezzanine level, and we have a mesh soffit system by GKD Metal that we're using to conceal some of the overhead infrastructure, piping, conduits, etc. Above that is also acoustical pyroc to help with the reverberation times in the station and improve speech intelligibility of the PA system. And you can see on the right a detail of the skylight system, which is not unitized, but has sort of a custom steel substructure supporting it. This is a shot of the main facade. You could see the PVs and landscape in the foreground. Above the main facade, there's an air gap between it and the roof. There's also an air gap between the two glass panel rows, and the entire first floor is open. So you could see how airflow moves freely into the station. Going up to the mezzanine level, you can see the perforated stainless steel rain-clad system again. These panels were by Lindner. You can see a sample detail of an expansion or seismic joint. It's a long station, so there are a number of seismic joints. It's rain screened with mineral wool insulation behind, and that also helped with our reverberation times, introducing more perforated surfaces. Another shot of what we refer to as the ribbon roofs, these long roofs that go throughout the site and help to guide circulation throughout the space from the mezzanine to the bus plaza area. These are diagrams from our construction documents to sort of walk the contractor through it. We used tensioned post-tension device by McAloy, which were adjustable and allowed for some field adjustment of the support of the metal mesh facades. Due to construction tolerances, we did have to adjust some of the angles during construction, which was a challenge, but having an adjustable support system did assist us so that changes were minimal. As far as combating birds, roosting, we did have a number of strategies. One was a system called flock off, which is sort of an electrified metal wire, but the point is not to shock the birds. Before they come into contact, it generates an electromagnetic field that throws off their navigation, so they don't land there to begin with. So that's in the cove, and it's also on the ribbon roofs above. The ribbon roofs have a built-in gutter system on each side, and then also a catwalk system and tie-offs for access. You can see another example of the diagrams that we prepared as part of the construction set to complement sort of standard 2D details, describing some of the panel systems. 1 second. So you can see here, these are horizontal panels done by Armstrong that were between columns. Here's the actual curved cove. Here are the mesh panels, and here are vertical panels between the mesh panels to stop entry of birds. And in addition to that, we did have some hawks on board before opening day to help us clear out some pigeons that seemed to have done the job.
Alrighty. Okay, and as every project, we obviously had some challenges that we, as the facade engineer and the structural engineer on the project, were helping to resolve. And one of the main challenges we had were actually the sizes of the glass panels, and the design intent didn't really match with the manufacturing abilities. So we had to redesign and reshuffle a little bit the sizes in order to actually find a manufacturer who was able to produce those glass panels. Another problem we had was we have round edges at the only enclosed spaces, so we don't go around the corner in a sharp 90-degree corner. We wanted it to be a round edge, so we have an IGU that is laminated for safety reasons on the ground floor, and it had to be also bent. So that was one of the other challenge. This is a public station. The design intent was to draw an attention to the interior of the space. We wanted it to be transparent. On the other hand, it's not a conditioned space, so we also wanted to keep out the heat. So basically balancing the high visible light ingression into the space, but also keeping out the heat. So basically having a high SHGC value was a challenge in the beginning to find the coating and the glass makeup that would comply with that requirement. Another challenge for those people who work in LA is four-sided structurally glazed units. Not necessarily something that you can go through the code. Permitting processing is not going to help a lot. Most of the times we revert to have it captured on two ends. However, being a transit station and falling under a different legislation and jurisdiction, we actually were able to implement the four-sided structurally glazed units on the elevator pitches, as you can see in the back. Another item that we weren't fully aware in the beginning when we started the facade designers, this is a tunnel, more or less. The train station, the train enters on one end and basically exits at the other end. This creates a tunnel effect where the wind loads significantly increase at the entry point, at the exit point. So we had normal wind loads about 30-40 PSF, and the entry wind loads actually went up 70 to 100 PSF at those 15 feet entry and exit ways. So that was something that only throughout the design and working with the structural engineer came to surface, and also we had to deal with it. And then lastly, it is a train station. We all have this experience that we go into a train station, we're trying to listen to the announcement and we don't understand a single word. We were trying to prevent that ahead of time by integrating acoustical design with the facade elements and to help to actually reduce this vibration noise and have clarity in the announcement system. This is the not so often seen four-side glazed glass unit in LA. Okay. The main facade Maya already mentioned is split up into multiple panels in order to allow for natural ventilation and airflow through the vertical enclosure. And is a simply laminated glazing glass that is mechanically attached to a steel bracket, like a steel T-molin, and then basically back to the primary structure. We did test that unit. It's not necessarily required per code to run a 501.6 dynamic testing. However, we wanted to verify the design. We wanted to make sure that nothing is going to fall off during a seismic event. It's a public space. We were erring on the side of caution. For those who are not familiar with the test, what it does is basically the setup is a couple of units wide, and we're trying to introduce the drift that you would receive from seismic ground motion. And then basically the test is run until either the glass is falling out, or the second scenario doesn't happen as often for large units. The drift is about 10% of the drift index is about 10% of the height of the unit. And lastly, if neither of the first two occur, it's proceeded until 6 inches, and if the glass is still in place, then the test has passed. This is an image of the test in progress. You can see it's lifting up quite significantly. The load is introduced through a crescendo testing, so you can see the load diagram on the right-hand side, and then the silicon joint before and after. Nobody expects that the silicon joints remain in place. And also, for those who have really good eyes, the glass is actually broken in the bottom right corner. However, nothing fell off the building, so the test passed. The other scope that was quite big on this project were the roof systems. We have a really long building, so we had to break up the systems and introduce seismic joints. We have about 100 feet spanning between the seismic joints that I tried to very poorly indicate in red. You can see a seismic joint on this image. It's in construction. The final product shows actually a flashing, which kind of conceals the seismic joint, so it's a little prettier. The other large portion of the roof was actually a skylight, and the skylight is spanning over the entire mezzanine floor, which is quite a challenge because we don't have any columns supporting the mid-span. So it was a collaboration with the structural team to design chamfered beams and basically achieve the high spans to then be able to have a glazed skylight spanning the entire band, I want to say, above the mezzanine floor. One of the highlights, in my opinion, is the round oculus. I think you saw a picture in the beginning. It's in the center of the mezzanine floor, and obviously the design intent initially was to have a 24-foot-long glass panel spanning the entire length. However, we had to introduce a few joints because there were some cost restrictions and, the typical ones. We did help with because we had structures and facades on the project, we helped with the structural design of the framing systems as well as the glass design. And ultimately, I think it's quite a nice centerpiece of the roof design. On the left-hand side, you can see our preliminary schematic design sketches. It's a toggle fixed system with a pressure plate at the front. And then on the right-hand side, you can see the custom steel section. These are the shop drawings. It's pretty similar to what we had envisioned in the very early design stages. So that was good. This is the only building that I mentioned earlier that is actually enclosed space. So here we do have an IGU. We tried to go around the corner. We could not maintain the original radius that we wanted to implement. So basically we had to kind of widen the radius and try to work with what the manufacturer's capabilities are to achieve a laminated curved IGU for the corner units. Because there's very limited ability of taking out any differential movement in a full glazed corner, we basically had to take the differential movement or seismic drift out adjacent to the corner unit. So we have the vertical strip of a seismic joint, which is a stainless steel metal panel that can pop out and pop back in the case of a drift event. And lastly, I did touch upon it a little bit. I was not on the acoustical team, so I will probably mispronounce some things, but we had a very intensive collaboration with the acoustical team, and the goal of that was to, and I'm just going to read it out because I don't know exactly what we were doing, is the acoustical absorption of the underside of the roof was meant to reduce the reverberant noise from trains and people. And this helped both to create an appropriate acoustic environment and also support the clarity, and I cannot pronounce this word, of the paging system. However, I know what we did. We put in perforated metal ceiling tiles. We also, Maya showed a couple of nice pictures of the metal mesh. Behind the metal mesh is a backing structure, which is basically creating the sound absorption. So we had quite an intensive layout of acoustical measures that were concealed by soffits, by metal panel, to help with the clarity of sound absorption in those spaces. And then lastly, we have the airport next door. Obviously, it's the airport connector. So we have a lot of noise coming, not just out from the trains, but also noise wanting to travel into the spaces because the airplanes are quite loud. So we have a metal standing seam roof, which is not helping a lot. So basically with the skylights, we're also a mean of introducing mass into our roof system to basically mitigate with the noise that is coming inward into the station, not just train noise and noise that's generated by the occupants.
Moving through the construction process, we worked with Aragon and enclosed. And even though we had a complex series of details in our projects, obviously you guys know in the shop drawings, they take things to the next level. Enumerate each panel of glass and look at the connections in more detail. So you can see a slotted bolt connection here on the main facade. On the main facade, the mullions actually protrude through the face of the glass joints, creating kind of like a knife blade, and it's a unique aesthetic that compares to what we see in the retail kiosks, where it's more of a minimalist look with just a silicone butt joint between glazed panels. One moment. Our largest panel of glass is about 17'6", so we sort of maxed out what several manufacturers could do. We did have to redesign the facade because they were initially too long, but we did that before construction started, so it wasn't an issue. Here's another example of the shop drawings of the skylight system.
And as Maya mentioned in the beginning, no project goes without any construction challenges. The main challenge for us was the steel erection tolerances. We had, unfortunately, pretty much in any location, a little bit of a larger tolerance that we would have anticipated in our joint. So basically, this is just one example of actually an RFI. The steel was installed with like almost 2.5 inches offset, which is a little difficult to kind of make up in an all-glass facade. So the lucky part for us, this is not a facade that ties into any building layers. Like we don't have a function other than existing in the space. So basically we were able to, as Maya mentioned, adapt and allow for the glazing paint to move a little bit to accommodate for the structural deviation from the actual grid lines. Oh, that was me actually, sorry, my bad. And we have heard that earlier, testing, we want to design a system, we want to verify the system, and we do a lot of on-site testing. So pretty much we had a very rigorous testing procedure with the AMA 501.2, a nozzle test. We went and tested a lot of the skylight area. We tested pretty much every joint of the facade on the storefront to ensure that we do not have any leakage due to workmanship or anything that might have happened on site. This is a video that's going to play in the background, but you guys can ask questions if you have some. Or you can just admire the video. That is alternatively.
I'll mention the team. We had a great multidisciplinary team, and it's won awards in landscape, urban planning, architectural design, and engineering as well. So, and we have a couple people in the audience that also worked on this project. So shout out to them. Yes. Yeah.
I just had a question on the issue of tolerances.
Yeah.
If there's a certain range that I would consider acceptable, at what point did the subcontractor say, that's how much you get at doing better? Was there any effort I can get thing to get within a smaller?
There are always efforts, I want to say. Like, there's nowhere that you go and, like, say, build whatever you can do. But I think there's also a little bit of a limitation. The design team, as a part of this, what are we going to do? Like, we're not going to say dismantle the structure, because then we are in trouble with the general contractor, with the client who also has a timeline. So basically, in the end of the day, although it may seem that we have a lot to say, it's like we just try to make it work around what's happening. And unfortunately, I think that's a reality in a lot of times. If reassembling and fixing it correctly would impact the schedule, I think there's very little we can do. And in this case, again, I think it was lucky that it's an outside structure. We don't have to maintain building function. So being out of tolerance by 2 inches didn't really had a ripple effect. It was just not where it was meant to be. And visually, you can't see it. It's a really long structure. Like, as I said, 150 feet, so like 300 feet, you're not going to see it in the space. We just know.
Right. So for Metro, they were more concerned with the construction timeline. For us, we were evaluating function and aesthetics. I think mainly it put more stress on the design team during construction, because we had to figure out what the new angles of the facade and the panels would be as a result of construction tolerances being much larger than anticipated.
No.
And often when you have, I think it's redesigning as we go, it's sometimes a little stressful, because you have thought of everything and you submitted it, and then you have to make sure that you think of everything again. And sometimes that's just a little stressful in the moment because everybody wants to know an answer within like 5 working days. And I don't know, with no machines.
I think also it being a very long structure, as you guys have seen, just a little bit of an error starts to trickle out throughout the building and compound itself. So I think that also contributed to some of the tolerances being off.
On a different note, has anybody seen the structure already in person?
Yes.
Perfect. I'm very glad to hear that. And one day the people mover will also be operational. So.
Oh yeah, I should say that's by others. We weren't part of that design team, and the client is LAX and not Metro. But it should be open towards the end of the year. That's what I hear. Thank you.
Thank you.
It's such a nice presentation, and I've been to the project, and I was absolutely shocked that it really is like an oasis in that area, and the level of thought is apparent, and the complexity is there. So, thank you. Our next presentation is by Frank Zhang. He is the AETS Application Engineer Technical Scientist at Dow. And his presentation is called Design with More Freedom by Engineering Less Impact, Carbon Neutral Silicones for Facades.
Thank you.
Thank you. I know everybody's tired, but and I'm the last one, I'm tired too, but I appreciate you guys sticking around. It's gonna be interesting. I mean, hopefully my presentation is not too boring, I promise. Try to do this in 10 minutes, but let's see. Okay, so I want to talk a little bit about, designing with freedom by engineering less impact, carbon neutral silicon. I don't know, maybe it's the first time you guys hear about this, but, I'm excited to introduce to you guys from Dow. So how can we work together to overcome challenges of time? So I think the key here is collaboration. Let me talk a little bit about what is Dow. I don't know, a lot of people maybe don't know where I come from, what is Dow. So, by leveraging our customer interaction, manufacturing size, the global connection that we have, and the growth that we have in the company, I think we can leverage that on how we can overcome the challenges of time. So Dow is a global company. We have sites and offices around the world. We have a headquarters in Midland, Michigan. We got 35 sites in 2 countries in Latin America. We got Europe, Asia. We got Africa, India. So we practically everywhere. So, we are a big company. Yeah, we leverage much about, especially in sustainability that we're trying to achieve now, right? To help a little bit, safe, I would say, safe for poor, I would say. Okay, we have more than 7 years of experience from waterproofing to structural glazing and insulating glass. I'm going to talk a little bit about waterproofing, a little bit of structural, and how can we do this carbon neutral to implement our product here. I think this is one of my fun and favorite slide. The 20 tallest building in the world, 14 of those buildings, is Dow. They use Dow product. So, you have a lot to say about using our product, right? And let me ask you guys a question. Do you know what is the tallest building here in LA downtown? It's the Wilshire Grand Center, which is pretty close here. I mean, this is a beautiful building. I think it's a 74th floor, and actually that building was done by Dow also too. So very proud of using our product. Other thing that actually impact me too is like by 2040, 2/3 of the global building is start with a building that exists today without any upgrade that we're meeting all these gases. So like if we don't do nothing, it's all that old building that we have, it's gonna meet all the gases. So it will require, let's say it require 45% more energy to actually run those old buildings. So we need to do something about it to actually help the environment. So that's why we're doing this. Building environment, I think I saw one of the presentation that is true, right? I was hoping that it matched my percentage here. Like the building environment is 39% of the global CO2 emission. 28% is from the operation for all the buildings, heating, cooling, lighting, all the machine that we run. And then 11% is the embodied, which is, all the manufacturing, from construction, materials and material that is and the building itself, right? So, we have to keep that in mind. 39%. This is a graphic that I want to show you on how we actually get our product. How do we do our sealing? We extract our natural resources from the core using clean energy, using wood chips from charcoal to clean energy, electric hydraulic clean energy to produce that, and then it go to the silicon metal, and then it go to the siloxane, which is our intermediate product that a lot of other companies use our product to make the cosmetic or electronics. So they use a lot of those intermediate product that we use. But for us, it's the last end of the product, which is the only final finished product that we have for that, which is our silicon sealant and product that we use for a structural, that we use for glazing, and we use for waterproofing a seal on the windows. So I'm here to introduce our first carbon neutral silicone for facades, which is integrated on a structural, insulated, and water seal. As you see this, this is it's one of the standard section on a corner wall, and then you can see the structural part of the seal in the back, insulated on the glass, and then the waterproofing sealant. So we are the first one. I think we are the only one that have this capability to do the first carbon neutral silicone for facades. And then not only meeting this requirement for all the architectural and engineering to use this product, but we also align with the carbon neutral certification, like the green building certification, all the LEED certificates, all the certification that we have to meet that carbon neutrality on the facade. So I think it's very important for now that we live in the, how we said in the modern world, it's very important to choose what material do we actually use our building, because if you see here, now with this new technology that we have, the SSG that we call it, structural silicone glaze, compared to the captive system, which is the all aluminum, we have to understand how the actual system works, right? How energy efficient is, on terms of the structural or thermal, and then how many material we use to produce that. So it's very important, and actually to keep in mind to the way that we're actually helping all the emission of the CO2 is just to choose the right product for our construction, for our project. This is just a comparison. A lot of people are asking, what is the difference between a structural and a capture system? Well, you see, right? A structural, we use strictly silicone to hold the glass, and this is what you see is pretty simple, pretty I would say pretty pleasing. You want to see all glass. In comparison with the capture system, you have a retainer and a face cap on the front, a mechanical fastening. So that they have disadvantages and advantages of using either system, which I'm gonna go over on the next slide. So using a SSG system, a structural glaze system, you will have more climate resistance and weatherability. You have more movement capability, and then the heating and strength of the sealant. You will also have that, right? You know that cycle span on the silicone is more than 50 years compared to, let's say, a gasket or plastic, which is like, I would say 10 to 15 years if it's exposed directly to the sun. So it's very important to know the product and technology that's out there in the market to design your own building. We also did a study, right, in comparison with the two systems that I was talking about, a capture and the structural, to see how much energy saving we actually save using two different systems. We not only choose the system that is here in North America, but we choose a system which is in Asia and here in North America, and compare them to both to see what was the difference. And then what we find out is using a capture system, the capture system in the bottom, you see they have a face cap and a pressure plate, and then the structural one that they use strictly our silicone sealant, you actually can save you from 10 to 15% on energy saving. So it's a great deal. I mean, imagine having that Wilshire Boulevard full of glass. I mean, that you would say 25% on that is just that's significant saving on energy costs. And also, right, in a capture system, you have to understand the material-wise. I was talking about the silicon sealant, the lifespan. Remember, 50 years. I mean, we have building that is up there more than 15 years that I haven't done anything to change it, and it's still intact and still performing. So having that technology, I think it helped, producing more material. Like we see systems that use rubber gasket. Those systems, I mean, last, I would say 15 years, depending on how exposed it's to the environment or to the UV. But also, if you use the structural silicon sealant and not using the plate, you're saving about 15% on metal, just the Facades and pressure plate. So that is a significant percentage in reducing the material on usage. So, okay, how do we actually calculate, how much emission do we actually emit, using, let's say, a standard regular silicon sealant? Because this is what we do, right? So let's take a 4x10 IG unit. So a consumption that you see over here is by linear by meter square. So the 7 points, that's the CO2 that you actually need to actually produce that. So overall, if you do a carbon footprint on the silicon sealant, it's about 8 to 12 CO2 per kilogram of producing the silicon sealant. So if you average that, you're about 20 kilograms of CO2 per square meter. So if you have a building that say it's about 200 square thousand, I mean, you will have I think I have the calculation over here. You see here, right? If they say you have, well, this is the comparison on the, I don't think it's in this slide, but this is the comparison about the capture and the structure I was saying, how much consumption you have. So 12 to 14 kilograms using a capture, and then on the structure silicon it's 10 to 11. So the embodied carbon is about 200 kilograms per meter, and then 170 kilograms per square meter. But using the benefit of the structural silicon sealant, you will actually save 3,000 kilograms of CO2 per 10,000 square meter of facades. So that's quite significant on the saving of the CO2 by producing that or using carbon neutral sealants. And then again, right, Dow is committed to the sustainability. I think we started in 2005 by reducing our production to 50% of the CO2. Now we're trying to achieve from 2020 to 2030 another 15%. But always, we always grow. So there's always volume there. But we still, by now, we're reducing about 30%. Our goal is by 2050 is totally decarbonize one growing capacity volume. So that's our path. By 2050, we want to reduce it, if we can, 0%, using all energy, renewable energy to produce our product. This is our product that all for carbon neutral, a structural glazing sealant, insulated glass sealant, water seal. I think I'm running out of time, but if you guys, more interested, I'm happy to talk about what kind of product do we actually offer for this this program. And then we did our first carbon neutral silicon project in North America, which is in New York. This is our first project that we did. We partnered with Cherry Glass. We used 982 and 983 and 795 for the water seal, 982 for the IG, and 982 for the structure. And I think I'm done. I'm over 2 minutes, but thank you. Bye.
Okay, yeah, thanks for sticking around. We're on to our last panel, which I've been looking forward to. And so I guess we have any out-of-towners here? Any out-of-towners? All right, we got a couple. Appreciate it. I think if there is any chance while you're here, I would try to check out some of the work that has been presented. I mean, there's a bunch of projects here that are in downtown, but certainly some of the projects that we're mentioning, Culver City, it's a nice area to kind of go visit and walk through. And so, yeah, I mean, I think, I think here in Los Angeles, we've been pretty blessed as far as the kind of culture of architecture that's gone on. And in general, I think we are also kind of spoiled as far as some of the options we have as far as high performance facades, right? And I think it's even us, though, we're having to not take the shortcuts, right? So high performance detailing and all these kind of considerations about carbon, and that's something that even in the temperate climate, right, we have to really be cognizant of. So yeah. And so it looks like we're almost ready. I'm going to start introducing our moderator here.
This is actually cooking this. Thank you.
And so our moderator is Olivier Sommerholder, and he is the design director here at Gensler, and he will be introducing the panelists for this last session.
Can my mic work now? Good afternoon. So we're gonna finish the afternoon here talking about office to residential conversion with my three colleagues here. You know, we have a policymaker, we have an engineer, scientist, and an artist/architect, you know, that we're gonna hear from. So when we talked about the panel, you know, we were thinking, like, what are the things that one will want to know about, you know, around adaptive reuse? So you see the questions that we looked at, how the ordinance changed, you know, the things, and Ken will talk about this in a little bit. You know, how can we unlock the greatest values, essentially, of those buildings? And then what are then the aesthetics factors and the challenges that come with this? So I would say that we have a little more time for questions afterwards. I would say, Ken, we're gonna start, you know, with you on the project. I think best thing is we just click through. Oh, this would be sounds much this slide, but let's. Yeah,
that's you.
That's me.
That's me. Perfect. Okay. Good afternoon, everyone. I'm Ken Bernstein. I'm a principal city planner for the city of Los Angeles City Planning. I oversee our historic preservation program in Los Angeles, the Office of Historic Resources, and our urban design studio. So as that indicates, I am not a facade engineer. I am not an architect, but I appreciate your welcoming me into your world of facades, which is quite wonderful. So it's a pleasure to be here. And I wanted to set the scene for this discussion by talking a little bit about the kind of policy background here in the city of Los Angeles for adaptive reuse, conversions from non-residential to residential. And what we've been developing our citywide adaptive reuse ordinance that just took effect in February of this year. So the city of Los Angeles has really been an adaptive reuse pioneer in many ways, going back about a quarter century to our 1999 original adaptive reuse ordinance that began in downtown. And it was made necessary because if any of you are from Los Angeles and go back that far, we had largely abandoned our historic core in downtown. We had dozens of buildings that were vacant above the ground floor, really creating a major challenge for the city and really ripe for revitalization. The original 1999 adaptive reuse ordinance facilitated the conversion of pre-1974 buildings constructed before 1974, and allowed those conversions to bypass regular planning and zoning approval processes and go right directly to the permit counter, and waiving requirements from density to parking to floor area, setbacks, unit size, heights, and more. And it had a tremendous impact throughout the city in spurring adaptive reuse, beginning in downtown. And then we grew on that by developing a 2003 extension to targeted areas in the city, including Hollywood, Wilshire Center, Koreatown, South Los Angeles, the Chinatown area. But
the streamlined processes that we created in the adaptive reuse ordinance, aside from downtown and these targeted areas, were not yet available throughout the city. So projects proposing residential conversions still needed to go through a public hearing, environmental review, many, many months and costly approvals to move forward. But nevertheless, the impacts where we did have the adaptive reuse ordinance, they were dramatic. More than 12,000 new housing units in downtown alone. The preservation of really remarkable historic buildings like the Eastern Columbia building, one of our great Art Deco landmarks of the city on Broadway, the revitalization of our retail and entertainment base, kind of created the seeds for much of the new development that came in and revitalized downtown, and the new arena, what was Staples Center, now Crypto.com, and also established a market for new residential development. Before 1999, very few people chose to live downtown. It was not believed that there would be a residential market in downtown. Now we have high-rise, new construction, condominiums and more in downtown, made possible in many ways by the success of the adaptive reuse ordinance. We built on that more recently through the update of our downtown community plan called DTLA 2040, and kind of laid the groundwork for what we then did citywide by creating new incentives in that downtown community plan and through our new zoning code in the city of Los Angeles, allowing for conversion between a broader range of uses and creating a rolling date rather than that fixed 1974 date for building eligibility. But this, again, kind of laid the seeds for bringing our adaptive reuse policies, our approach into the 2020s and addressing current challenges. In 1999, it really was focused, on that vacant historic core. And now we really saw that we had three intersecting crises that adaptive reuse could help address. Of course, the housing crisis in the city and in California, the issues of housing access and housing affordability. We have the greatest disconnect between rents and incomes of any major city in the country. And of course, the post-pandemic commercial vacancy rate, our commercial crisis. We're working differently than we did pre-COVID. The office vacancy rate, as we were developing the adaptive reuse ordinance, was over 26% across the city. There have been some recent reports that in some targeted submarkets, that's over 30 or even over 35% in parts of the city, highest ever recorded, at least in recent memory. And so the ability to repurpose these commercial buildings is really compelling. And then our climate crisis, the reality that the greenest building is the one that's already built, and rehabilitation is a way to reduce carbon emissions, the need for demolition and extraction of new resources, and the opportunity to bring our buildings up to new energy efficiency standards. So the citywide ordinance that's now in effect as of February 1st, again, that applies everywhere but downtown that had that original downtown community plan provision. We now have a rolling date for eligible buildings. I'll get into that a little bit more in a moment. And this is a key component of our overall housing strategy in the city. We have a housing element of our general plan called the Plan to House LA. And that estimated that we could conservatively convert over 40,000, have over 40,000 housing units if all goes well, created through a citywide adaptive reuse program. So now through the citywide program, all buildings 15 years old or older are eligible for a by right approval process. Again, no planning and zoning approvals, go directly to our Department of Building and Safety. We did leave in place approvals being needed through a zoning administrator for buildings between 5 and 15 years old, because those were built in the more recent past and may have conditions of approval or unique conditions or agreements with the community that we want to take a closer look at. But anything 15 years old or older is by right. And we expanded, we kept some of our previous incentives in the original adaptive reuse ordinance and expanded those, and also allowed partial conversions to take place, that you don't have to convert the entire building to qualify for the adaptive reuse ordinance incentives. Optimization of the building interior is really key to this. The zoning code minimum unit size requirements are eliminated. You can add a rooftop structure of up to 1 story and not have that count toward either your height restrictions or floor area ratio requirements, as long as those are meant as shared amenities for the residents. And that you can also do full intermediate floors. We used to call them partial mezzanines, and those don't count toward floor area ratio requirements either if they're within the building envelope. So these are ways of really helping to create flexibility and optimize the interior. Parking was a key to the original adaptive reuse ordinance. This is the first time we really waived parking requirements in the city, and that really helped influence our parking policies throughout the city to allow the market to really dictate how much parking could be provided, because most of these buildings did not have 2 spaces or more for each residential unit. So the original adaptive reuse ordinance allowed parking to remain essentially as is. Whatever parking the building had could remain, but you don't have to provide more. But the new ordinance actually allows applicants to go further, that in many cases, new housing uses, because of changes in state law or new city incentives, don't have to provide as much parking. So you can actually reduce the amount of parking if that's compliant with either state or city requirements. And in fact, for some transit-adjacent projects under state law, now 0 parking is required. Most projects still do choose to provide some level of parking to meet resident demand. We also have an incentive-based approach to affordable housing. Rather than mandating a percentage of affordable housing units, there was a policy discussion about this. We created a program called Unified Development, which allows for new construction to take place across the street or across an alley, and allow unlimited density for that new construction. And this is allowed where affordable on-site affordable units are being provided. And you can also do up to a 2-story rooftop addition if you're providing affordable units as a set-aside on-site. So again, creating an incentive-based approach to meeting our housing affordability needs. And I'll just close by teeing up what might be some of our discussion, if we have time to get to this, that to recognize that what we've done as urban planners is address the zoning code and our planning processes. And that is a necessary prerequisite for these projects to happen, to clear away those obstacles and that extra time that might be needed. But it may not be sufficient in many cases. There are other issues we have to address as we create a concerted adaptive reuse program in the city. So we also have to address, and others will get into this, our building code requirements, fire, life safety, structural considerations. And so we are coordinating closely with our partners in our Department of Building and Safety and our fire department. And also there may be the need to help projects pencil out economically through complementary financial incentives. Other cities have done this in the US and elsewhere, looking at federal or state support or other incentives to help make adaptive reuse economically feasible. We can have a whole discussion just on that point, but I'll leave it there. Thanks.
Thank you so much, Ben.
Bob, Ben.
So Jeff will talk to us about the performance of facades.
Thank you.
Challenges with that.
All right, this is fancy. And it works. Okay, so as Ken was saying, first off, it's an honor to be up here. Thank you, everyone. It's a great discussion to have, an important discussion to have. We could have a day-long discussion on just about any one of these items, even us nerds talking about facades and different building skins and envelopes. And so we're just going to touch on a couple of these to facilitate and hopefully set Rocky up for even more success. But first, I want to talk about just sun, and we all need sun. And, it was really modernism in the mid-19th century, the mid-century, back a year or two, that brought design into the light, pun intended. But, my bullets are a little bit misorganized, but Corbusier brought up with us the screens, the brise-soleil, and in the 1920s, the sun was everything. It was light, it was health, it was hygiene. It was those ideals that more than doubled the population of Los Angeles from 1920 to 1930. In the same time, Mies van der Rohe's ideas were coming forward, the hermetic building. We don't need an operable window. Just give me full glass and let's let the mechanical give us that comfort. Energy was relatively cheap at that time. Hannes Meyer, succeeded Walter Gropius with the Bauhaus, and it really was at that time that we really started to see these diagrams and really the application of what the sun and what the solar is doing to our architectural designs. It was first time something really measurable and programmatic for these designs. And then it was the Olgier brothers, the twins from Vienna, that really brought everything to the forefront and a fully mature outlook and approach in the 40s and the 50s with shading and working with solar and integrating that into their designs. But that's the key there. Those are new designs, and what we're talking about truly is the existing built environment. And so just two types of wall assemblies. We've got an early stick-built curtain wall system. This is a Pereira Luckman building from 1958 over on Wilshire Boulevard. There's a lot of those down on Wilshire Boulevard. And then in 1930, of course, the Eastern Columbia building designed by Claude Beelman. Now, it's at times, to absolutely simplify it, it just is three main things: mass, materials, and geometry. These thin wall systems like to heat up quickly, right? We all understand that. And those are things that we now need to realize and really consider in a change of use. And similarly, these thick wall systems, concrete, masonry, terracotta, brick, these take a while to heat up once the sun is shining. And of course, regardless of the wall, the opaque aspect of the wall, we always have that glass to deal with, glass and glazing. And, with something like that, there's only so much coating, there's only so much film that can be applied. And we have the tools to better understand these conditions at the time, and here's my pitch, at the time that this conversion is happening. And so sometimes a precast curtain wall is going to allow for a lot more consideration or leeway once that data is collected and incorporated into the larger design, the larger programming of that new building use. This is, of course, 444 South Flower, built in 1981. A.C. Martin and Associates was the architect, and approximately 10 years ago, that owner at the time introduced at upper floor levels these open terraces. And this particular project was designed by Gensler, and it was a great, fun project to be part of. And now the owner didn't say, solar heat gain coefficients are really driving me bonkers, let's just take the windows out. No, this was a completely separate thing. It was a programming approach, and they wanted to introduce fresh air. But the purpose for sharing this as an example is there are downstream benefits to consider when things are thought through. One thing that, of course, is a challenge at times is making sure that that building envelope, that continuous line, remains continuous. When you remove that glazing, now we've got to compensate for air and moisture and manage those things. And same thing with a roof structure. On the left, a historic aerial photograph of the Eastern Columbia, and the roof is happy. It's serving a roof function. It's holding up the mechanical units, no problems. But now we're introducing maybe multiple floors, vertical additions, or maybe we want to put a big 30,000-gallon swimming pool on the roof, and same basics apply. And Some of those basics can be kind of boring, but it's important to consider those, capture the data and that information, and continue on with that design, that transition as that building is repurposed. This is my last slide. I left it for my last slide because maintenance is boring. I used that term already. Maintenance is dirty. It's not sexy. It's expensive at times, but depending upon the facade and facade types, the age, those are things that really have an opportunity to be zeroed out, or at least baseline calibrated when we're putting that pool on the roof, or when that vertical addition is going in, when those windows might be modified. And, you know, it always falls with the joints. This is my last slide. It always falls with the joints, whether it's a aluminum glazed curtain wall, whether it's a historic terracotta cladding assembly. The joints are going to be the weak place. And I use that as an example of there's a tremendous amount of consistency, even if the facade is much different, whether it's a 1960s, 1970s facade. The approach to implementing that maintenance is consistent from a philosophical standpoint. Thank you very much.
Thank you so much, Jeff. No, it's very interesting as we are venturing, you know, kind of like now, and Rocky will talk to that in a couple of minutes, you know, from the transition from punched window openings, traditional buildings, and we're converting those, and Rocky has done many of those. Now, as you will see also in his work, you know, as you can convert buildings that are really fairly recent, these modernist buildings are a very different animal. And I think what, you know, Jeff, you did really well. It's like, that's understanding that transition between the two, and what does this now really mean for us, you know? Lots of buildings on Wilshire, you know, and in under Skyline, and then also for owners and for us architects, and how to transition in this.
Okay, so I'm going to take you through a little timeline of my life. Well, we aren't going to go back that far because that's really boring. But the early part of my professional career was started about 46 years ago. And I did a lot of remodels and rooms over garages and TI work and you name it. And then we had an earthquake that obliterated Santa Monica in the early 90s. And so we got into more renovations. And then all of a sudden I had friends who said, you know, we got to make a difference in downtown. And the new adaptive reuse ordinance came to play in 99, I believe what Ken said, which I was very game for. My wife wasn't as game, but we did buy a building. And she said, oh, for Christ's sake, what are you doing? But we bought the Douglas building, which was part of the downtown ARO, and I'm going to go through that phase of my life. And through the first 8 or 9 years of the adaptive reuse ordinance, we kind of plodded along on Spring Street. Then we migrated to Broadway, doing projects along Spring, then along Broadway. And then getting bored with that, we moved to the Arts District, and we found ways to work around the requirements of the adaptive reuse ordinance by doing live-work lofts. So as things progressed, we took some sidetracks. And as you see the sidetracks, things like hospitality became really important. So we got into hospitality. We're really focused on our marketing, right? We take whatever kind of work comes around. So we changed and we went into sort of hospitality, hotel rebirth. The industrial to residential was part of that early part. And then we got into more citywide. We moved on to Wilshire Boulevard. We're moving up in the world. Wilshire Boulevard became project after project after project. Very different from our early projects. So let's look at some of the early ones. Let's see if I can make this work. Douglas Building, windows, punched in a big, thick, 5Y thick wall. What's that wall for? Fireproofing. The windows, all operable, all wood. They slide up and down. Building had been closed from the first floor up since 1974, when they caught homeless people building fires in it. The floors were wood joists. Uh-oh. Sorry, still doing well. Wood joists, and the steel was more like cast iron, built in 1898. So on this facade, we restored all the windows. We took them apart, we sanded them down, we tried to keep the glass. You notice the corner windows on the curving corner is curved glass. I hate to tell my friends who gave their presentation earlier today, but curved glass has been around since 1898. They heated glass and kind of bent it. Thankfully, that glass, none of it had ever been broken. We kept it. We put a little film on it so it wouldn't like shatter because it wasn't tempered. And after we rehung all those wood windows and put in all the pulleys and put in we put in chains instead of the old rope, they went up and down again real well. We moved on to the El Dorado. And the El Dorado, I guess we went to Metro first. I don't know. Metro Lofts. Somebody on the left-hand side of this picture is the entry that somebody fixed in a modern way. And then on the right, we started doing demo, and you see up above, you see this thing that says Met or something in terracotta. And that whole terracotta facade was there. It was just covered by this really wonderful black granite that some idiot put on there. So we peeled all that off, and all those windows in that building are wood, and they are gigantic wood. Some of the operable windows are 10 or 12 feet wide, and they still slide up and down. Now we had to rebuild them all. But again, wood windows punched through a very thick facade. So one claim to fame of this building was it was the LA library from 1913 when this building opened until 1926 maybe when the LA Public Library was opened, right? So it had some history, so we worked on it. We converted it to housing on everything from 2 to 10. We put a pool on the roof, of course, because that's what architects do. And we continued to, that building has some people that have moved in I think 2000, I think it was 2008, they finally moved in, have been there ever since. So, big units, nice. We moved on Spring Street again to the El Dorado Lofts, which was, it was a hotel when it was built in 1913. It was built by an architect who I don't think he did very many projects. As you can see on the left, the facade was a mixed bag. It had been up against another building. So those little shafts were air shafts. And the other building was almost glued up next to it. That building got torn down. And for what we thought was just an empty lot next door with a parking lot on it, was actually that building they tore down. They just kind of put it in the hole and paved over it. So when one of my partners decided to build on that lot, they started digging, and they just found building, basement, brick, you name it. So this building, fenestration, punch windows, right? Piece of cake. 1913, the building had 10 windows. Very amazing. Tinsmiths were amazing. They built this window shape. It was perfect. All the windows were supposed to move. They didn't. But they were all made as double-hung windows. And they were 10. And you could walk up to them and stick your finger into them because they were rotten. So we had to fix that. And we replaced them with identical because we had full windows. We could do molds and figure out exactly what they look like with aluminum windows. But now it's 65 condos, and it functions very well. So that was our lark along Spring and Broadway. Now we move to the Arts District. This building on the left, not improved yet. It was originally built in 1905 by the Spreckels Sugar Company. Heard of Spreckels Sugar, right? They don't actually make sugar in America anymore. They used to make it out of sugar beets. And they would farm the sugar beets and bring them on railroads. And they'd run railroad tracks down both sides of this building because it's right next to the rail yard. And they would shovel out 40 feet tall by 300 and something feet long sugar beets. If you've ever been to Syark, it's right next to, it's 2 blocks or 1 block from Syark. So that building was brick, again, like 4 or 5 wise thick. It had windows, but because, as you know, the Arts District was kind of sketchy in the 70s and 80s, they had bricked them all up. It was a sweatshop in the front, and it was some kind of live-work thing towards the back. When we got there, they were filming, quote unquote. Not the kind of movies anybody here watches. But it was pretty interesting. So we gutted the building and found that we had a 42-foot tall warehouse. Light steel trusses. Again, built in 1906, so the steel was steel, sorta. So what do? You fix the windows. So we went back and found all these openings that were closed in, right? So we opened back up. Down the middle, we put a driveway. Because it was live work in those days, being back in the dark ages of adaptive reuse, we pulled down this driveway one way and we parked both sides, and people lived in their apartments, which were condos, but the ground floor would be the work part, where you came in from the parking. You go upstairs and you got the live part on 2 more floors. Plenty of room. Between the trusses, units. So it worked out great. So then we come to the high-rise part of our show. The Pacific Indemnity, we started on this building. It was designed by Langdon and Wilson. We're all the way forward to like 1971 now. Langdon and Wilson were a big going concern at this time, and they continued to be for another 30 years, 40 years. And we started an adaptive reuse of this building. We converted all 18 stories to like 255 units. We've got a roof deck with gas, a pool, right? But structurally, it's steel. So as opposed to the other buildings, which were non-ductile concrete or brick with cast iron, you didn't have to do shear walls anymore. We had now graduated to this whole new system, which you can see there in the picture. These dampers are sort of the magic bullet. Not a lot of concrete work, not a lot of basement foundation work. Kind of excruciating. Plan checkers in LA. Any plan checker here from LA? They can't handle it. So if you're doing a plan checker, they have to go to somebody else and create this whole separate review panel, not City of LA review panel. And you have to get it approved by a task force, a joint task force of 3 people. They've got to approve your method of designing these dampers. But it's a magic bullet. You end up stiffening the whole building. You do have some column reinforcement to do, but it's all steel work. So a steel building became our model to improve and to do these high-rises. So I'm talking too long, and I don't think Libya's kicked me yet. But here's another one. This is the Paramount Plaza. Again, designed by Charles Luckman. You've heard him in many of the things today. Luckman was a big mover and shaker. And we're slated to complete this soon. And our PM's in the crowd today. Thank you, Cheyenne, for being here. It is 21 stories, steel curtain wall. We're, of course, cutting into the curtain wall to do operable windows. And curtain walls are much different than punched openings. So a very big difference. But with the new adaptive reuse ordinance now, no longer live work, we can go through and actually do. SOM was here earlier. Are you still here? This is an SOM building from 65, maybe 1965, and we are converting that to joint live work facility with 370 units. And these projects are bringing an enormous amount of housing to LA. When we get done, we're going to be adding more than 3,000 units to the Wilshire corridor in LA. That's a lot of units, and it's coming fast. Our last beautiful picture on the line is a project that you all drive by and go, why the hell haven't they torn this down yet? Huge building, takes up a whole city block, designed by an engineer, not an architect. Post-tension, 6 stories of parking, enormous floor plates, and a nightmare, but we're converting it. So I think that's this is the last one. This is CNA building, which is on Commonwealth, which, again, curtain wall. Since this building was built in 69, again, Langdon and Wilson, this building needs a completely new curtain wall. Now, the structural curtain wall part, the aluminum, will probably stay. It'll get repaired, but it will stay, but all new glass. The glass is dual glazed glass. The air parts of the glass are gone. So we're going to spend quite a bit of effort replacing that and putting in operable windows and living in there. And this one we're actually targeted to do elder care, which is a whole nother thing to learn. So elder care is getting popular because guys like me are getting old. So soon we're going to have a lot of elder care work, I'm sure.
Thank you so much. So we have a couple minutes for questions. Fantastic. So Jeff, you kind of like showed, and also Rocky now going through his projects. You know, we have kind of like the 100-year-old building to 50-year-old buildings that are, lots of those are traditionally built. And now we are venturing into the curtain wall environment also, facilitated to also what Ken was describing to us in his efforts with the adaptive reuse ordinance. So where do you see kind of like the biggest challenges in that, and what should we think building new buildings or moving forward? Or let's say we take down one of those curtain walls in worst case and rebuild them in mind of the next 50 or 100 years.
Not to put you on the spot.
That's it. Okay. I think, well, there's two things. One of my notes I've got, repair is on one side and maintenance is on the other side. And there's certainly economies of scale and costs can go way up when we have a high rise where it hasn't been maintained and there's a tremendous amount of repair needed versus something newer that may be just resealing, regasketing, replacing a few lights here and there or IGUs. That's one thing. The other thing that was fascinating with what Rocky was discussing was used examples of older materials not holding up. But I think with certainly in our climate, an aluminum curtain wall is going to perform well. And even that construction of supporting that curtain wall off the edge of the slab or whatever, it does allow for an efficient replacement of sorts. And I think from the green standpoint and from embodied carbon, that's certainly a discussion worth having.
Good, interesting. Thank you. So perhaps we can, just because of can pivot in your last page, you had kind of like, what are the next hurdles that are out there? So fire life safety, structural, as Rocky was saying. So in which areas you get like the most requests or like from groups that what is kind of the next frontier to facilitate adaptive reuse? Hard to say.
I think it may be, again, on the code side, both structural and fire life safety. And again, we can't solve those issues from a planning and zoning standpoint. We have to work with our partners at our Department of Building and Safety. And in many cases, they feel they also need state policy guidance because the state codes come down to us at the local level. There may need to be additional state legislation in Sacramento. There's been a working group that was already formed by some previous state legislation that was supposed to report back on code relief, code flexibility around adaptive reuse. That hasn't quite come forward yet. So I think it's really important that all of the policy for adaptive reuse be aligned, that our planning and zoning policy also be aligned with state and local relief and flexibility and strong coordination among all the public sector partners to really create as I said, kind of a concerted, dedicated adaptive reuse program that turns the ordinance into reality. I don't know if you agree.
Yeah, I think fire life safety is going to be a big hurdle. We had an expert here earlier today. He was talking about it a little bit. It is when you get into a high rise and you're converting it from one use to another, it has its landmines. And so that takes a lot of effort. But we have been trying at a much higher level with AIA. We've tried state to get them on board. We've tried state fire marshal, talked to our own fire marshals here in LA. And it is, like Ken said, we're going to spend a lot of time trying to get everybody on the same page.
So think about landmines. So when your clients come to you, and say like, oh, Rocky, so what type of building should I invest in and build so we can...
That concrete.
So what are the things that you recommend to your clients to look out for good and successful adaptive reuse project?
Yeah, I think concrete buildings of a certain age are difficult, non-ductile.
Can you elaborate a little bit why?
Sure.
The challenge?
The challenges are structurally, you end up building a lot of concrete walls to hold it up, steel collectors, concrete walls. It just gets very tedious. You dig and dig and dig. You're in the dirt longer than you would be. The amount of embodied energy you already have in a building that's steel, you don't destroy it doing the adaptive reuse. Mm-hmm. But on a concrete building, you go through a lot of effort. And you feel like every time you go to the job site, it's a dig in the middle of Egypt trying to uncover one of the Pharaoh's tombs. It's brutal. So that's structurally, I think, tough.
And perhaps the same client, is it easier to do adaptive reuse for a project that is like more of a punched window type project or a modernist curtain wall type project?
Yeah, I think they're equally challenging.
Mm-hmm.
Punched windows, they leak just like curtain walls leak. I don't know why. That's just the way it is. Yeah, you've got the same challenges with both. Now, punched windows, yes, there's less of them. And you can control your efforts, But even like when we did the Hotel Figueroa, all the windows had to get changed because nothing was being held out. When we did Ford factory, the amount of steel industrial windows on that project is massive. Mm-hmm. It's probably more than anywhere else on earth, I think. Why is that? But to rework those, they're steel. They're the same windows now. They just get blasted down, refinished, reglazed, and you got a brand new window system. So there's a lot of good things in those punch windows. But again, you got 4-foot thick shear walls.
So, thank you very much, gentlemen.
Thank you.
Thank you very much.
Your fan club.
Thank you all. Have a nice evening.
Great job. Thanks so much to our last panel here. And thanks to you all for making this a great discussion and joining the conference.